Have you ever wondered how Netflix knows what to recommend or how online stores seem to read your mind? Now that's the magic of data analytics, and you are about to learn how it works. Hey, and welcome to our Data Analytics full course by Simplilearn. Every click, swipe, and purchase online creates data, but without someone to make sense of it, it's just a bunch of numbers. Now that's where you come in. Data analytics help turn those numbers into smart insights that businesses use to grow, improve, and make better decisions. And guess what? By 2025, almost every industry from tech and healthcare to finance and retail will need data savvy professionals. So, learning these skills right now are super smart move. In this course, we will walk you through the basics, show you how to use powerful tools, and teach you to turn raw data into real stories. You'll also explore real world example, build cool visualization, and gain job ready skills. Before we comment, if you're interested to supercharge your career in data analytics, then the Professional Certificate Program in Data Analytics and Generative AI by ENICT Academy IT Guwahati is the perfect choice for you. Now, this 11-month live online course offers interactive masterclasses by IT Guwahati faculty and industry experts combining cutting-edge tools like GenAI, ChatGPT, Python, Tableau, and SQL. Experience hands-on learning with real-world projects and immerse yourself in the campus environment with a special session at IIT Guwahati. Plus, earn an executive alumni status from IIT Guwahati and IBM recognized certifications to stand out in the job market. You can find out the link mentioned in the description box below and in the pinned comments.
Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer-related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large data sets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial. Now that we have looked at what data analytics really is, let us understand the ways in which you can use data analytics. First is improved decision making. Data analytics eliminates a lot of guesswork and manual tasks from choosing the right content, planning marketing campaigns, and developing products. Organizations can use the insights they gain from data analytics to make informed decisions, leading to better outcomes and customer satisfaction. It gives you a 360-degree view of your customers, which helps you understand their behavior completely, enabling you to better meet their needs. Second is better customer service. Data analytics provides you with more accurate insights of your customers, allowing you to tailor customer service to their needs, provide more personalization, and build stronger relationships with them. Your data can reveal information about your customers' communication preferences, their interests, their concerns, and more. It helps you give better recommendations for products and services. Next is efficient operations. Data analytics can help you streamline your processes, save money, and boost production. When you have an improved understanding of what your audience wants, you waste less time in creating ads and content that don't match your audience interests. This helps you optimize your campaigns, create better content strategies, and hence improve results. And finally, we have effective marketing. When you understand your audience better, you can market to them more effectively. Data analytics also gives you useful insights into how your campaigns are performing so that you can fine-tune them for optimal outcomes. You also find out the probable customers who are the most likely to interact with a campaign and convert into leads. Now, let's discuss the various steps involved in the data analytics process. As you can see on the screen, there are 5 process steps. Now let me make you understand each of this one by one. So the first step is to understand the problem. Before starting with the analysis, you need to understand the business problem and define your goals. Asking questions at the outlet is vital because this would address issues such as how can we reduce production costs without sacrificing quality? What are some of the ways to increase sales opportunities with our current resources? Do customers view your brand in a favorable way? Answers to these questions will help you build a clear roadmap with lucrative solutions. Also, try to find out the key performance indicators and consider the matrix to track along the way. The second step in the process is data collection. After you have finalized your goals, it's time to start looking for your data. Data collection is the process of gathering information on targeted variables identified as data requirements. The emphasis is on ensuring accurate and right data is collected. Data collection starts with primary sources, which are also known as internal sources. This is typically structured data gathered from CRM software, ERP systems, marketing automation tools, and others. These sources contain information about customers, finances, gaps in sales, etc. Under external sources, you have both structured and unstructured data. So, if you are looking to perform a sentiment analysis towards your brand, you would gather data from various review websites or social media apps. The next step is to clean the data. The data which is collected from various sources is highly likely to contain incomplete, duplicate, and missing values. So, you need to clean these unwanted redundant data to make it ready for analysis. So to generate accurate results, analytics professionals must identify duplicate and anomalous data and other inconsistencies that could skew the analysis. According to a report, 60% of data scientists say most of the time is spent cleaning the data, while 57% of data scientists say it's their least enjoyable task. Now the fourth step in the process is data exploration and analysis. Once data is cleaned and ready, you can go ahead and explore the data using data visualization and business intelligence tools. You can also use various data mining and predictive modeling techniques to analyze the data and build models. You can use different supervised and unsupervised algorithms such as linear regression, logistic regression, decision tree, KNN, k-means clustering, and lots more to build prediction models for making business decisions. And the final step is to interpret the results. This part is important because it's how a business will gain actual value from the previous 4 steps. Interpreting the results will help you find unseen trends and patterns in the data and gain insights. You can have a validation check if the results are answering your questions. These results can be shown to your clients and stakeholders for better understanding and business collaboration. Now that we have looked at the various steps involved in data analytics, let's now see the different tools that can be used to perform the above steps. So as you can see, we have 7 tools including a few programming languages that will help you perform analytics better. Now let's discuss them one by one. First, we have Python. Python is an object-oriented open source programming language that supports a range of libraries for data manipulation, data visualization, and data modeling. Python programmers have developed tons of free and open source libraries that you can use. You can find many of them via the Python package index, which is pypi, the repository of Python software. Python provides the default package installer called pip or pip. Python has libraries such as NumPy for numerical computation of data, pandas to manipulate data on numerical tables and time series. Then you have SciPy for technical and scientific computations. It also provides scikit-learn, which is a machine learning library for creating classification, regression, and clustering algorithms. And finally, it also has PyTorch and TensorFlow for deep learning. Up next, we have R. R is an open source programming language majorly used for numerical and statistical analysis. It provides a range of libraries for data analysis and visualization. Some of these libraries are ggplot, tidyverse, plotly, dplyr, and caret. Then we have Tableau. Tableau is a popular data visualization and analytics tool that helps you create a range of visualizations to interactively present the data, build reports, and dashboards to showcase insights and trends. It can connect with multiple data sources and give hidden business insights and patterns. Then we have a competitor of Tableau, which is Power BI. Power BI is a business intelligence tool developed by Microsoft that has an easy drag and drop functionality and supports multiple data sources with features that make data visually appealing. Power BI supports features that help you ask questions to your data and get immediate insights. You can also forecast your data for predicting future trends. So the next tool is QlikView. QlikView provides interactive analytics with in-memory storage technology to analyze vast volumes of data and use data discoveries to support decision making. It provides social media discovery and interactive guided analytics. It can manipulate huge data sets instantly with accuracy. Up next, we have Apache Spark. Apache Spark is an open source data analytics engine to process data in real time and carry out complex analytics using SQL queries and machine learning algorithms. It supports Spark Streaming for real-time analytics and Spark SQL for writing SQL queries. It also has Spark MLlib, which is a library that has a repository of machine learning algorithms, and then it has GraphX for graphical computation. And finally, we have SAS. SAS is a statistical analysis software that can help you perform analytics, visualize your data, write SQL queries, perform statistical analysis, and build machine learning models to make future predictions. SAS empowers our customers to move the world forward by transforming data into intelligence. SAS is investing a lot to drive software innovation for analytics. Gartner has positioned SAS as a Magic Quadrant leader for data science and machine learning.
According to the industry reports, the global data analytics market is expected to hit over $650 billion by 2029. And that's right, we are talking about a field that's booming faster than ever. And in 2025, data analysts are not just in demand, they are in command. Now, if you love playing with numbers, if solving problems excites you, if turning messy data into meaningful insights sounds like magic, then becoming a data analyst might be the perfect career choice for you. In this video, I've got you covered with the exact step-by-step roadmap to become a successful data analyst in 2025. I'll walk you through the key skills you need, tools to master, real-world projects to build, and we will also talk about all the data analyst salaries, how they grow with experience, what companies pay, and tips on negotiating the best offer. And because I keep seeing these questions pop up online and in Google searches, so I'll also answer the most frequently asked questions about data analytics career. Is data analysis a good career or not? And the best part is, you'll get to learn the free learning resources so that you can start right now without spending a single dollar. So grab a notebook, get comfortable, and let's break down how you can start your journey to become a high-paid data analyst in 2025, even if you're starting from scratch. So let's dive right in. Now, before we jump into the roadmap, let's quickly answer some questions I see asked again and again online and so forums. The first question is, data analysis a good career choice or not? The answer is absolutely yes. Every company today runs on technology and technology produces data. Analyzing this data helps companies make smart decisions, innovate, and plan for the future. As more organizations rely on data-driven decision-making, the demand for data analysts keeps growing. It's a career that's challenging, rewarding, and constantly evolving, especially with new AI tools and visualization techniques coming in. The second question is, are data analysts well paid or not? The answer is yes. Salaries vary based on experience, location, industry, but data analysts generally earn competitive pay. I'll cover detailed salary ranges shortly in the video coming. Now, the third question which I have seen is, what qualifications do I actually need? Now the answer is, you don't have to get a fancy degree. Many data analysts start with skills in Excel, SQL and a programming language like Python, plus a portfolio of projects, and certifications definitely help too. Fourth question, is data analysis an IT job or not? The answer is yes, it is. It sits at the intersection of IT and business. While it involves technical skills like coding and databases, it's also about understanding business problems and providing insights to help decision makers. Now let's start with step-by-step detailed roadmap. Now let's talk about what is data analytics with a simple detective example. Imagine you are a detective solving a mystery. Your clues are data, sales numbers, customer reviews, website clicks. You collect the clues, clean them up, and analyze them to find the truth. Data analytics is exactly that, solving business mysteries using data. Now here's a 4-step detective approach. First is descriptive analytics. What happened, like checking last month's store sales to see which product sold the best. The second is diagnostic analytics. This means, why did it happen? Maybe sales dropped because a competitor had a sale. The third one is predictive analytics. This means, what might happen next? Predicting which product might be popular next season. The fourth one is prescriptive analytics. What should we do? Deciding to run discounts to boost sales. Now let's take an example. For example, imagine a retail company which is trying to understand why sales dropped last quarter. A data analyst would gather sales data, customer feedback, and market trends. They might discover that a competitor launched a similar product at a lower price, causing customers to switch. With this insight, the company can adjust its pricing strategy or improve its product to regain market share. Let's move on to the first step, which is mastering Excel and basic stats. Now, before fancy tools, Excel is your first best friend. Think of it as a digital notebook for data. You need to learn functions like sum, adds up numbers like total sales. The second is you need to learn about average, find average price or rating. Then the third function is if statements. If sales are over 100, mark as good. Fourth one is VLOOKUP. Imagine a giant phone book that lets you find customer information instantly. Then we have pivot tables, where you can just have a quick summary machine that groups data and shows total. Talking about the basic statistics, it's just like learning the language of data, understanding average, how spread out data is, and what's normal or unusual happening. Example, if average sales are 100 units, but some days sell 10 and others 200, then stats help you understand this difference. Now let's move on to our second step, which is learning SQL. Talking to databases like a pro. Now think of databases like huge libraries storing your data books, and SQL is the language you need to use to ask the librarian for exactly the books, that is the data which you want. You need to learn commands like select, which gives me, let's suppose, give me all the sales from January, where only sales from New York. Join will give you the combined. For example, instead of looking through every book manually, SQL helps get your information fast and precise. Now let's move on to our third step, which is picking your programming language, which is Python or R. Now programming languages are like detective gadgets, powerful tools to solve complex problems faster. At first we have Python. This is easy to learn. It's just like a Swiss Army knife. We can use pandas to manage data and matplotlib to make charts. Then we have R, which is focused on stats and beautiful graphs with tools like dplyr and ggplot2. You can start with Python if you're new. It's beginner friendly and it is widely used. Let's move on to our fourth step, which is collecting and cleaning data, getting your clues ready. The raw data is like a puzzle pieces covered in mud. You need to have to clean them before solving the puzzle. You'll have to collect data from websites like web scraping, file APIs, tools that share data between apps or database. Then you need to clean data by filling missing information, removing duplicates, fixing errors. Then you'll need to transform data to the right format, like converting dates into the same style. For example, if one customer's birth date is 1/2/1990 and another one is 1919/1, cleaning makes them consistent. Now let's look at your fifth step, which is analyzing data and visualizing the story. Now is the time to play detective and find the patterns. You need to use averages, sum, and understand the data. If two things move together, for example, more ice cream sales, then you need to test with hypothesis testing, use regressions to see how advertising affect the sales, and visualization helps turns numbers into pictures. Now tools like Tableau and Power BI make it easy to create charts and dashboard. Python's matplotlib or C help you customize visuals. For example, instead of giving you a boring spreadsheet, you show a colorful chart that everyone can understand instantly. Now let's move on to the sixth step, which is learning machine learning basics. Your detective's crystal. Machine learning help computers learn patterns from data and make predictions. At first, we've got unsupervised learning. Now the computer finds hidden groups by itself, like grouping customers by shopping habits. Then we've got supervised learning. You need to teach the computer using examples like showing pictures of cats and dogs so it can identify them later. You don't need to be a machine learning expert, but knowing the basics will definitely make you stand out. The seventh step is optional, which is big data and cloud, super tools for huge puzzles. Now, big companies handle mountains of data. Think millions of customers and billions of clicks. They use tools like Hadoop and Spark to break down and process huge data quickly, like having a team of detectives working together. And cloud platforms like AWS and Azure let you store and work with data online. No big servers are needed. Now the eighth step is building real projects and a portfolio. Show what you can do. Now nothing beats practice. Work on projects like grouping customers, buying habits, predicting next month's sales, creating dashboards for easy understanding, joining Kaggle's competition where you solve real. And these projects are your proof to employers that you can do the job. Then you can also apply to Freelancer, Upwork, and you can check in job postings in Indeed and Glassdoor. We also have GitHub where you can find the repositories. Now, the ninth step is keep learning and networking, stay sharp and connected. Now, data is always changing, so keep learning. Read blogs like Towards Data Science, join LinkedIn groups and Reddit communities, attend free webinars and meetups. Build strong resume, get an internship. You can also look for in Indeed and Glassdoor. Now, just a quick information, guys. If you're interested to supercharge your career in data analytics, then the Professional Certificate Program in Data Analytics and Generative AI by ENICT Academy IIT Guwahati is the perfect choice for you. Now, this is an 11-month live online course which offers interactive masterclasses by IIT Guwahati faculty and industry experts, combining cutting-edge tools like generative AI, ChatGPT, Python, Tableau, and SQL. Experience hands-on learning with real-world projects and immerse yourself in the campus environment with a special session at IIT Guwahati faculty. So hurry up and enroll now and find the course link in the description box below and in the pinned comments. Now let's talk about some free resources. Now to make it easy, here are some free places to learn all of these skills. You can go to LinkedIn and check some blogs from there. And then we have Simplilearn's Data Analyst course, which I've already discussed right now. You can just enroll in that. And we also have Google Data Analytics Professional Certificate from Google, and it's a free course. We also have full courses from Simplilearn. It's a data analyst full course. You can just find it in the comment section below. Then you can also enroll yourself in Kaggle competitions, network and learn from LinkedIn groups, Reddit data science community, and free webinars. Now let's talk about the data analyst salary and career growth. Now that you know the skills and steps, let's talk about the big question. How much can you actually earn as a data analyst? The truth is, data analysts are in huge demand today, and the salaries reflect that. So now let's talk about the entry-level data analyst position, which is around 0 to 2 years of experience. So if you're just starting, maybe fresh or looking to switch careers, you can expect around $55,000 to $75,000 per year in US, and in India you can expect around 6 lakh to 8 lakh rupees per month. Talking about which companies, Google, Amazon, Microsoft, financial firms, and healthcare organizations need data experts to make smart decisions. For mid-level data analysts in US, you can expect salary around $75,000 to $100,000 with an experience around 3 to 5 years. And in India, you can expect around 12 lakh rupees to 18 lakh rupees over the experience of 3 to 5 years. Talking about the senior analyst position, senior data, over 5+ years of experience in the US, you can expect around $100,000 till $140,000 plus. And in India, you can expect with 5+ years of experience, around 20 lakhs per annum. Obviously more than this. So let's look at the job outlook in future. So obviously big tech cities like San Francisco, New York and Seattle will offer the highest salaries, but cost of living is higher. The remote jobs are leveling up. Finance, healthcare and AI focused companies often pay more. Getting certifications from Google, Microsoft, Simplilearn, AWS or specialized analytics programs can help you boost your pay scale. So that's your full step-by-step roadmap to become a data analyst in 2025. Now follow this path, practice often and stay curious.
Hi everyone, welcome to this tutorial on Microsoft Excel. So we will learn about functions and formulas, we will learn about conditional formatting, data validation, pivot chart and pivot table. Now let's look at a scenario here. So one day in a startup, one professional speaks that their business is growing and they would need an efficient way to work with the data. They would have to find a way to work faster with storing and analyzing data. Now, to that, another colleague responds, well, we can make use of Microsoft Excel to do this job. The question is, will Excel be able to cater to their business needs? Now, the colleague responds, well, we can make use of Excel in several ways, and it also is a cost efficient option. Now, in that case, the colleague who posed the question says, let's go ahead with Excel and let's train our employees in Excel. And the suggestion is welcomed, which would make the job easier for them. And they would basically decide on using Excel. So they decide on taking a training right away and basically starting to learn Excel. Now, before we move to Excel, one of the question is, why should we use Excel? So let's look at some of the points here. So Excel proves to be a great platform to perform various mathematical calculation on large data sets, which is one of the biggest requirements of various organizations these days. Various features in Excel like searching, sorting, filtering makes it easier for you to play with the data. And Excel also allows you to beautify your data and present it in the form of charts, tables, and data bars. Now, when it comes to reporting, accounting, and analysis can be performed with the help of Excel. It can help you with your task lists, your calendars, and goal planning worksheets. Excel also provides good security for your data. Excel files have the feature of password protection. This way, your information can be safe. Now, when we talk about what is Excel and how it can be used, so Excel, or you might have heard as spreadsheet, can be basically used for a lot of different tasks than just storing the information in so-called tabular format. Now, Microsoft Excel is an application that is used for recording, analyzing, and visualizing data. It is in the form of a spreadsheet. Let's have a look at few of the functions and formulas used in Excel. And before we do that, we can also quickly take a small tour to understand how to work with Excel. Now, to do that, what we can do is we can type in our search, say for example Excel, and just select your Excel app which is installed, and here you see you have a lot of options which says take a tour, drop down list, get started with formulas, make your pivot table, going forward with pie charts, and much more. So we can click on this one which says take a tour, and that basically pops up a window which says welcome to Excel. And if you have always wanted to be better at Excel, you have this which can help you. So let's click on create, and that takes us to the store window. Now that says instructions for screen readers, which basically talks about 10 different steps in which we can learn Excel and using the spreadsheet app. So there are more than 11 sheets which we see here at the bottom end, and each one gives us a simple example which we can work on. So for example, if I click on add, now that takes me to this page which says how do we add numbers. Now you might be provided data which we can upload by loading a file from our machine, or getting data from a web source, or even connecting to a database. So there are various options which we will see in some time. So here we have an option which is called data. You can click on this one, and this basically has options where you can use existing connections. If you have created some, you can always click on from other sources, and you can get your data from SQL Server, from analysis services, from OData data feed. You can get in from XML, from data connection wizard, or also from Microsoft Qurey. You can be running in different queries here, which shows up in the option which says new query. There are connections which you can use, and that basically will display all the connections for this particular workbook, which we do not have as of now, but we can create them. But let's look at simple examples. Now you can follow these instructions here, which says basically adding up the numbers, and that could be easily done by just placing your cursor here. And what you could do is either you can type in the formula, that is from which row to which row you would want to add the data. So for example, I could just do a sum here, and that shows up all the different functions which are available. Then we can open up a parenthesis, and we can say I would be interested in totaling the amount from column D, and I would select, for example, D4. So I could be doing this, and then I could say D4 onwards till D7. So that's the data which I'm interested in. You can close your parenthesis and hit enter, and that gives you the total. There is also a shortcut for this, which you can always do, is we can first delete this, and you can just place your cursor here and just use your alt and equals. That automatically selects the numericals, which we can anytime expand or basically collapse. So I will basically select this, which says this function needs two numbers, which is number 1 and number 2, and then you can hit on enter, and that gives you the total. So similarly, we can be getting in the data here by selecting all the fields. So here it also says that you can use a shortcut. Now what we can also do is we can add numbers over 50 by selecting the yellow cell here, and then giving a condition such as, so I can basically use something like sum if, and then open a parenthesis. I can select I would be interested in this row, and then I can even drag and drop till here. So that tells me D11 to D15. You can then put in a comma here, and you can give your condition. Say for example, we would say I would be interested in numbers only above 50, and we can select this, close your quotes, and then just close your parenthesis, and that's your formula. So you can do this, and that basically gives me the total is 100. Now similarly, we could do that for the amount here. I could select this. Now there is also an option, I can click on home, and I can go for something like auto sum. So that's one more way. of doing it, which anyway says sum is alt plus equals. So it automatically adds up your values, and I can try doing a auto sum that automatically selects my rows, and then I can get my total. Now, as per this activity here, it says try adding another sum if formula here, but add amounts that are less than 100, and the result should be 160. So what we can do is we can basically select all the numbers which are lesser than 100. So the way we did earlier here, there can be always a shortcut. So you can always, for example, if you would want to avoid typing in the formula, you can always copy it from here and then just hit on enter. So you are back into this cell, and then I can basically go here and paste the number, and then as per the requirement, we are required to select anything which is lesser than 100. So what I could do is I could select here, I could say, let's say G, and then I can change this value to G15, and that's one more way. Now we see our selected rows have been changed, so I can hit on enter and I can check what is the result. So we would be interested in looking for numbers which are lesser than 100, so I will have to also change this one to a lesser sign, and that basically gives me the total, which is 160. So that's how you can simply add numbers. You can use auto sum, you can type in the formula, you can select the fields, or you can just place your cursor where you would be looking for a sum, and then you can just do a alt equals, and that basically populates the sum. Now let's look at some easy options of filling your cells or automatically populating the values in your cells within your Excel sheet. Now here we have an option which says 100. Now we can click on this, and that basically says it is making a sum of column C4 to D4. So if I click on this one, I can check that this is row number 4, which shows up here, and I also know this is column C. I also have D, so this equals is basically giving me a sum of C4 to D4. Now what we can do is we can always place our cursor here at the right corner, and then we can just drag and drop, and this basically gives me a total of all the numbers for all different rows. So this is one shortcut which we can do to get the total. Excel will automatically give the totals, which we call as filling down. Now what we can do is, in the same way, if we would want to get the totals here, we can first check what is this 200, and this tells me it is C11 to C14 total. So it is totaling the rows from C11, so column C and 11th row, till 14th row, and that's the sum. Now what I can also do is I can similarly, like above, we can do a filling right, which basically means bringing your cursor here and then just dragging and dropping it all the way where you would need the totals, and this basically gives me the total. There is one more quick way to check if this is right. So the easiest option would be to select this cell. Now what I can also do is I can just select all of these fields by just highlighting and selecting all the fields. Once it is selected, press on Control R, and that gives you the total. Now if we would be doing this top down, then I could select all these rows for this particular column, and then I could do a Control D. So that's your filling down, and this one was filling right. So this is an easier option of doing a fill when you would want to have the formula applied to every row as it occurs in the first row or the last row. We could test this by, for example, selecting these fields. I could delete them, and I have here which says 130. I could just place my cursor here and I could drag it all the way up, and that should also do the same magic which we were seeing from top down. So this is a simple way wherein you can fill up your cells, and you can also automatically propagate or move your computation to all the cells. Let's look at the split option, which basically helps us in splitting the data when we have some kind of pattern or when we have some kind of delimiters in our data in, say, one particular column, and we would want to derive the values out of it. So we can always use the splitting option. Now the easiest option would be, so for example, we have our email column which has the email IDs and which we can clearly see has a first name dot last name. Now I see that there is a last name Smith filled up here, first name is empty. So what I can also do is I can just type in, say, Nancy here. Now that's the first name. I can again start typing the second name, and as soon as you do that, you would see a faded list of numbers, and that's your clue to hit enter. And once you do that, you would see all the first names have been filled in here. If you would want to maintain the case sensitiveness, you can just go ahead and delete these, and let's type in as it occurs. So let's say Nancy as the first name, go down to the next cell and just type in Andy, and there is your grade list. So just hit on enter, and that basically fills up your first name. What we can also do is we can just select this particular field, and either we can type in Control E, which basically fills up all the options. Now I can just do a undo by typing in or clicking Control Z, and that's basically gone. What I can also do is I can select a particular field, and then I can go into home option, and under home you have an option here which says fill. So you can select this, and then you can do a flash fill, which is what we are doing here. So click on flash fill, and that automatically fills up the values. So in this way you can work within your spreadsheet, and you can be filling up the values where a delimiter by default is understood, and we can split the data. Now however, sometimes you might have some data which has a different kind of delimiter, and there is again a smarter way of splitting your data. So you can always scroll down here, and that says splitting a column based on delimiters. So we have some values in the data column, and these values in each row are separated by comma. So select this. Your data is already selected. Text to columns, delimited, comma is selected, and now click on next. So it basically says what is the destination. Let's select this one, and I can choose what would you want to have. So that shows me this would be my data preview. Now I can basically select this one. I can say finish and say okay. And now if you see, our data has been placed in the columns appropriately. So this is how you can split your data based on a delimiter and then organize your data in a better way. Now there are some advanced options which we can learn later, but this basically tells about using a formula. So this is something, if we have some name in one cell, and if you would want to split it into first name, your helper column, your middle name, last name, so that can also be done using formulas. And this basically tells how would you extract characters from your left cell and how would you place them in your right cell. So you can try this activity, which is a little more of advanced option. The benefit is that you can always use this, wherein if you do some kind of transformation using your formulas, if your original data gets updated, then the split data will also get updated. And that's the benefit of using formulas, where you can place values from one cell into multiple cells based on execution of your details in the formulas. How about using the transpose option? Now, you might have heard of situations where you would want to switch or turn your rows into columns and your columns into rows, and that's where transposing comes into picture. It might be useful when you have your data in your X and Y axis, or as I would say in rows and columns, and you would want to switch your rows to become the columns and columns to become your rows. So what we can do is, the simplest way is you can select all your values. So here we basically have 6 columns and I would say 2 rows. Now I can select all of these and then I can select an empty field. For example, the one which is highlighted here. Well, you can always do a Control Alt V. That's a shortcut. What you can also do is, once you have selected all your fields, you can just copy them. So just do a Control C and then click on an empty cell, and then what you can do is you can do a special paste or paste special. So under your home you have the paste option, and here you can go for paste special. And once you do that, you need to select the transpose option over here and click on OK. And now you will see that the columns and the rows have been transposed. So your row name was item and that has become the column heading. You had row name as amount and that has become the column heading, and all your values have been transposed in this particular format. Now there is another way of doing that, and again that's using your formulas. So what you can do is you can transpose with a formula also, and that basically works when you have similar kind of data. So this has 6 columns and basically 2 rows. So you can basically do this. So you can select this, and earlier we were doing a copy, but now what we would want to do is we would want to just look at the row numbers, which tells me it is C33, C34, and it starts with C and ends in with your H column. So what we can do is, we know that we have 6 columns and 2 rows. So transposing that would actually give me 2 columns and 6 rows. So what we can do is we can select 2 columns and 6 rows in our Excel sheet. I can then basically start typing in the message, or I can just go to the address bar, and here I can say transpose. Let's go for C33, H34. It basically selects my data, and now I can just do a Control Shift and enter, and now if you see, all the values have been populated. Now you can just place your cursor in one of the cells, but if you see the address bar, the formula remains the same. This is because this is an array formula. So we can read more about an array formula here. It's basically something which performs calculations on more than one cell in an array. And in the example here, the array is the original data, that is C33 to H34. So your transpose is just changing the horizontal orientation to the vertical orientation. So this is a very simple way in which you can basically use the Excel's capability to transpose your data and convert your rows into columns and columns into rows. Apart from working on additions, subtractions, filling up your data, sorting the data, or basically splitting your data, transposing your data, one of the other requirements is sorting and filtering your data. Now that can be very handy when you're working on huge data and you would want to sort it in a particular order, say ascending or descending, or might be based on a particular field, or if that field was, or if the cell was highlighted with a particular color, sorting the data. So let's look at how Excel can be used for sorting and filtering. Examples are pretty simple here. So let's check that. So if we're going to sort and filter and say this is the data I have, say for example, I would want to sort the values in the department column alphabetically. So what I can do is I can select department column, and I'm already in the home tab. I can straight away go here which says sort and filter. I can then say sort A to Z, and that's basically alphabetically sorting your department column. And once I do this, you would see the data has been sorted. But it's not just this data. We can just do a Control Z and check what are the values we have. So here we have meat, which is beef, and 90,000, 110,000, the values. Then you have bakery, which should ideally be the first row, if we sort it in an alphabetical order, which goes with bakery as desserts, you have the values. So we can check this again. So select department and then just do a sort and filter, and let's say sort A to Z. And if you see, the data has changed, but it's not just in changing your first column, but then it has taken care of all the data. However, the data has been sorted based on the department column. So you have bakery, which aligns with desserts, which has the values, and now we have all the data which has been filtered. Now what we can also do is we can sort December's amounts from largest to smallest. So what we can do is we can basically click any cell in the December column, let's say 20,000, and then what I can do is I can go into sort filter, and then I can say sort largest to smallest. So if you see, bakery breads is the row which has the smallest data, or might be you have deli sandwiches, so that one looks also smaller. So let's do a larger to smallest, and if I do this, you would see the values have been shifted now. So it is no more based on the department column, because now the data is being sorted based on the values in the December column. And you see bakery, which was alphabetically the first one, has become second last. So either you can sort the data based on a department column, which goes based on the values. These are all string values or words, so it sorts alphabetically. If you have numbers, might be you can give some values and you can sort the data. You could anytime do a custom sort, and you could basically select if you would want to select the data. So I could do a custom sort, and then I could choose which is the column which we would want to use for sorting, what is the sorting needs to be done, is it cell values, is it cell color, font color, conditional formatting, and then you can also choose the order. So that's one more way to do that. Now, if you scroll down, that also shows how you can sort by date or a color. So for example, if you would want to sort based on the expense date, so there are different options. So what I can do is I can select this date field. I can just do a right click. I can go into sort, and then I can choose. I would want to sort oldest to newest. So since I selected the date field, it basically has sorted all the data, and it has taken the expense date into consideration. Now there are these filters which you see on the row headings. We could have also used those. So I could have selected this, and that basically says or mentions which are the dates I would be interested in looking at. I also have sort by color here. I can do a sort oldest to newest or newest to oldest. So I could also use these filters which have been applied here. Now we have the data which is in color. So if I would want to basically select the color columns or color cells, I could select this. I can basically do a right click here, and when I go into sort, I could choose put selected color or cell color on the top, and that basically will make sure that my data is sorted, and it has also sorted that in a descending order. So in this way you can sort or basically filter your data. What we can also do is we can add filters. So sometimes we can go for formulas which we would want to use. What we can also do is we can basically select the filter which has been applied here. Now how does the filter come in there? So if I would select a particular row, I could select a particular row, and then I could decide if I would want to just add a filter to this one. And that's how the filter has come in. So we have the filter. What we can do is we can basically click on this drop down, and then you have something like number filters. So we can always go here. We can basically choose one of these. So we can basically choose above average. So I could select this, and then basically it shows me the values. We could also delete the filter by clicking on this one, and we could say, well, I'm not interested in this filter anymore. So I could clear the filter, and that shows me all the values. Or I could say that let's click on some other field, for example food. I can go in here, I can go into number filters, and then I could say, well, I'm interested in values which are below average, above average, might be greater than, and then I can choose what is the value. So for example, if we say I'm interested in food which is greater than $25, I could give a value here, I could say okay, and now I have applied the filter. Similarly, you can select this and then you can just clear your filter and your data is back. So remember, no data is lost. It is just hidden, or basically based on the filter not shown. So that's good enough for us. And in this way, you can sort and filter the data. So for more details, obviously in all these sheets, you have the links which point to more information on the web, and you can always refer to these. So this is simple way in which you can sort and filter any amount of data which has been stored within your Excel within a particular sheet. Now that we have learned about add, fill, split, transpose, sorting, and filtering, it will also be good to learn how to work with tables, or basically converting your data into a tabular format and then doing some easy computations. So click on this tables option here. Now here we see there is some data which is in 5 columns and n number of rows. So I can basically select this data, and then what I can do is I can insert, choose the table option, and then it says my table has headers, and we'll be okay with that. I'll say okay, and now if you see, this is the table created. It basically has different filters which we have learned earlier how to use, and this is basically my table, which is a collection of cells which has some special features. So we can easily add rows to this table, we can add columns to this table, and we can even do some calculations. So for example, here I can click on this one, I can basically enter some field, and then I can hit on enter, and we see that this row has been inserted, wherein we can easily fill in values. For example, I would say chocolates. I could give some value here, size 25,000, might be 35,000, and then basically I can give in some values here. Now what you can also do is you can continue adding rows in this way, and say for example you would want more columns, so you can select this option here in the top bottom right corner. You can just drag it towards the right, and that basically has automatically created columns for my next months wherein I can feed in the data. So this is a simpler way wherein you can keep adding more rows and columns to your data if that has been converted in a tabular format. Now let me just do a Control Z, that basically deletes the columns. Again, Control Z deletes the last row which we added, and I can stop here, or I can even remove my values by doing multiple Control Z and removing my rows. So this is how I converted my data into a table, and then I can easily work on this. What I can also do is I can do some calculations. So what we can do, we have a table here, we have a total field, and what we can do is we can just select one cell here. Now as we have learned earlier, we can do a alt and then equals, and that basically says what is this doing. So it says it is calculating the sum of the last 3 months, and if that's what you would want to do, just hit on enter, and it has automatically calculated the totals for all your rows for these 3 columns. So the sum formula is getting filled up. Now I can select any particular cell and I can look in my address bar. So it has already given me the formula where it has started calculating the sum from the October column till the December column, and has given me the calculated values of the columns. What we can also do is we can get total rows in the table. Now that's a simpler option. So what we can do is we can select any cell in this particular table, And then we see that there is a table tools design option showing up here. Now I can select this, and then it says, well, let's get a total row. So let's select this, and it automatically populates the total here. And if you would want the average, then we could select this, and from the drop down I can select what I'm interested in. So for example, I would want the average values and not the total. I could just select this, and that gives me the average of these values. So we can always do simpler computations here by converting our data into table format. Let's learn about one more efficient way of working with the data, and that's using your drop downs. So let's see how drop downs work here. Now, say for example, you have this data which has the values in the food column and department is empty. And say for example, you would want to enter the values in department. However, you would want to select that department should either have produce or meat and bakery, and these are the only three options which should be available for any user to fill in the values. How do we do that? So we can basically create a table by pressing Ctrl D. So what I can do is under my department here, I can select one of the cells, and then I can do a Ctrl T that basically converts this into a table. I can say OK, and my table is created. Now what I can do is, once this part is done, we can select all the blank fields here where we would want this drop down to be applicable. Now under your data tab, you can go in and select data validation, and this has an option called data validation. Click on this, which basically says allow any value. So here I will select I would want to give a list of values, and then I can type in my values here, which I can say produce, say for example meat, and then say bakery. Now these are the values, so we can click on OK. And once we have done that, we basically have a drop down here next to apples, which will only show us the values which we can feed in under the department column. So I can go into every cell, and then I can basically choose what is the department which handles this, and then basically I can select one of these from the drop down. So this is an easier option of creating your drop down and then feeding in the values from the set of values which you have defined here on the right. So this is a simple example of using your drop downs, working with your tables, working with your sort and filter, transpose, split, filling up your data, adding in some data here. And similarly, you can use Excel for more than one use case using its inbuilt features to easily work with your data. Let's see how we can import data or bring in data into our Excel from your local machine or from an external web source. So what we can do is we can open up a blank Excel sheet and say, for example, you have been provided a text file or a CSV file and you would want to import that data into your Excel sheet. That can be easily done. So right now I've opened an Excel sheet. Now I can click on data, and here I have an option which says existing connections from other data sources. So, or you can click on connections if you have already created some. So we can click on from other sources. So this is one option where you can connect to your different data sources and you can get the data from one of these. What we can also do is I can click on connections. Now it says there is none. I can click on add. It says, well, show the connections where connection files on network, connection files on this computer. So I can say, let's get some files from this computer. Now, if that does not show up something, so say browse for more, and that basically shows you different options. So let's basically select a folder where I have some data sets. I'll click in here, and this is basically a folder where I have some data sets. Now let me select this particular file, and I know it is a CSV file. So let's click on open. Now if you would want to verify this, you could have gone and looked into the properties of the file, and it says it is a .csv file, which is what we are interested in. So I'll take this file, I'll say open. Now this basically shows me the text import wizard option, which says, is the file delimited? I'll say yes, click on next. So I will select comma as my delimiter. I can say text qualifier is none. Now this is my data. So my data preview is already showing me the data is what is the data in the CSV file. You can click on next, and then you have an option which says data format is general. You can go for date format, you can go for advanced options. So I'll just say finish, and basically now this has been created here. So we basically have this, and now I can click on close. Now once you have done that, you can click on existing connections. It shows me the data which we have here, the connection which we have created, say open, and then it says, do you want to import this data or bring this data into existing worksheet? You can also say add this to a data model if you are doing some data modeling. So click on OK, and now this data is automatically inserted in my Excel file. I can basically save it into this particular sheet. Now what we can also do is we can also start a new sheet, and that does not have a data, and we can get some other data from web. So what I can do is I can go into my GitHub, and let's say I would be interested in this CSV file. So I can select this, and this is my GitHub path, a path on web. So I can click on raw, and that basically gives me the raw path where this particular file is. Now you can select this, copy this particular path, and here you can come back to your Excel sheet. We would be interested in getting the data from web, might be from a text file where we will have to specify the delimiters, or let's go to web, and here I can give in the web path from where I would be interested in getting the file. Let's give the GitHub path, which is publicly available, and then click on import. Now once you click on import, it tells me there are two fields, data and value. These are within double quotes, separated by comma. So first let's click on import. Now once we do this, it will basically get the data from web and put in here. It says existing worksheet, so we had already created a new worksheet. So let's click on OK, and now you have the data coming in, but then this basically shows me in one particular field. So what we can also do is we can just do a Control A, that selects all my columns here, and that's my data. So we can then basically filter this out. So we can say text to columns. It's a delimited file. Click on next. We can select comma and let the text qualifier be quotes. It shows me data preview. Click on next. So you have the general format. It shows the destination, that's the column. Click on finish, and now your data has been split, and you have the data which you have imported from web. So this is the data which is coming in from web. This is the data which came in from my local machine. And similarly, we can even create connection with an existing database. So I can basically click on connections if I would want to do that. So I have an option called connection here, and it says where the selected connections are used. I can basically click on add. I can basically choose if I would want to get the files from network or from computer like we did earlier. I can click on browse for more, which should show me different other options to create connections. Say you would want to create a new SQL Server connection. You can connect to a new data source coming in from different place. You could basically choose what kind of connection would you want. So these are all the different options which we can go for, and we can basically connect to a database. For example, if I have some database and say, for example, access database. I can see if there are some files with that particular database and I can import it. So similarly, we can also click in here which says new query, and that also gives you an option of getting the data from your files, from all these folders, from databases. So you can basically click here and then you can import data from a MySQL database, provided that is set up on your local machine or on a particular server. You can go from cloud, you can get it from online services, you can get it from other sources, which says from web, from your Hadoop file system, from Active Directory, from a blank query, and you can even combine queries wherein you can run a Power Query editor. You can get the data from different sources and then you can bring it into your Excel. So in this way, you can get your data from different sources into your Excel, into your spreadsheet, and then you can continue working on those data sets. We have already learned some basic operations which you can do in Excel, and let's implement our knowledge by working on this particular data which is coming in from housing data set. Now here, if we see some fields, we have agent, date listed, area, list price, and this is basically the data which has been sorted in newest to oldest order of date listed. So how do we arrive at this? So what I can do is I can just click on data listed, and then I can either go in here, I can select sort, I can get into custom sort, and then I can choose the column based on which I would want to sort the data. So I would look for the newest data to the oldest data. That means that would be in a descending order of dates, or you could say the oldest date or the earliest month will be towards the lower side of your sheet. So here we can select date listed. Now I can say let it sort based on cell values and the order what we have here. So we have newest to oldest. So let's select this. I can say okay, and now if you see, the date has been sorted. So we have your 10/18/2007 on the top, so that seems to be the latest date. And as we go down, we will see an earlier month or an earlier month than that in this date listed. So we have sorted our data into newest to oldest order, and that's based on your date column. So the result shows up here. Now what we can also do is we can have different questions which we would want to answer. So for example, I would want to sort the data in ascending order of area and descending order of agent name. How do we do that? So let's look into this. So this is here. I already have the result here. And how did I get this? So I'm looking for ascending order of area and descending order of agent name. So we can start with any particular column, that does not matter. So for example, if I look into this Excel sheet, I have my agent name, select this, which we want in a descending order. So we could either do a sort and then go for descending sort Z to A. We could also use the filter option here on the top right, and we could do it, or I could just say sort Z to A, and then it has arranged the data based on the agent column being in descending order. Now I can go into area and then I can again do a sort, and I wanted my area column to be used for sorting the data in ascending to descending. And that basically not only changes the order of this particular column but for my complete data. So let's do that. And now if you see, we have the data which has been sorted. So we can see how many values we have here and the area values which we see, and this is how you get your result. So I'll just do a Control Z and again, and I'm back to my original data, and this is the sorted result which we are seeing at. Similarly, we can answer other questions. For example, sort the data according to the following order of area. That is, we are saying county, central, and then your county. So we can basically choose in which particular way we would want to do it. So it is county, central, and then again county. So if I look into my sheet 3, so here I basically have my data which is having some South County, then you have your Central, and then you have your North County. So we would want to sort the data to solve our problem, which is according to the following order. So first we go for area, then we go for South County, Central, and North County. So what we can do is we can basically have area field selected, and I would want to sort this particular data. So I have South County, Central, and North County. So I can basically go for custom sort, and then I can choose which is the value or column which I'm interested in. Let's go for area. We will go for something like cell values. Well, you can also try to explore conditional formatting icon if this is what you would want to use, or we can basically go for just cell values. And here we can say if I would be interested in first getting my values for South County. So for example, I can say custom list, and then I can basically give in the new list here. So I can say S dot county, and then I would want central, and then I would want North County. So let's select this as it exists. We can basically say add, and that's basically the order which we want. Say OK, and then say OK here. And now what we would want is we would want our data, so we can compare that with the values which we see here. It starts with Kelly. You have in the 12th row something like Lang, and that's what we are doing. So we can basically arrange the data in a particular order by choosing a custom list and then sorting your data. So that's one more simpler task what we have done, where we have sorted the data in the order where under our area column, we first wanted South County, then we wanted central data, and then we wanted North County. So this is how you can do it. Now, let's look into one more problem. So it says find all the houses in the central area, and we would want to basically apply a regular filter. Let's see how do we do that. So we can click on this, and here we have the data. So the problem statement is we would want to find all the houses in central area. Now how do we do that? We can do a sorting, but we would want to use the filter which you see here is implemented. So how do you do it? So you can select this area, and say for example I would want to apply filter. I can just go in here and I can say let's get a filter on my first row, and now I have filters applied. So we are interested in looking into the central area houses. Let's go in here. It says all these fields are selected. That means it shows everything wherein your area has all these values. Let's unselect this, and then I will only be interested in the central. So let's say OK, and then say OK. So now you see that the area filter has been applied, and we are looking at the central column. So what we have done is we have applied a simple filter, and we are looking at our data. At any point of time, if you do not want the filter, then what I can do is I can select this, and I can say, well, I'm interested in all the data. So I could do this, or you can clear the filters from area and you get your data back. So that's in one way you can filter out your data. So let's look at an example of sort and filter, where we might have to filter the data based on two columns or multiple columns with different kind of values, where it could be and or condition. Now say for example this is the data I have, and this is the question which we need to answer, such as find the list of all houses in the central region with pool and South County without pool. Now if it was a simple filter based on one cell, I could have just selected my header row. I could have then applied the filter, and once I have the filter, I can look in area where I have 3 regions. So I'm only interested in Central and South County. So I can get rid of North County, and that's fine. But then we have 2 different conditions here. So we need the data in Central region to have the value for pool being true, and for South County the value has to be without pool. Now how do we do that? So what we can do is we can first create a copy of these headers here. So let me do that. Now the area has to be South County. So basically I can either just select this and I can choose this value, and then I can select this and then I can choose Central. So that's the criteria which I have, and the pool value has to be, so Central region should be with pool. So then this one basically has to be true, and this one has to be basically false. So South County is without pool. So let's select one of the values here, and this is my criteria. Now to get my result, we can always place your cursor here and you can check this is M column and 8th row. Okay, so we would want the result here. So let's go ahead and now click on data, and then in filter you have an option called advanced, and here what I can do is I can say I would want to filter the list in the place, but that's not what I would want to do. So I'll say copy to another location, and here if you see the list range will tell me that this is the data. So A1 to J126, so A to J column selected and all the rows. Criteria range is basically based on what I've given here. So that is M from 1 to V, which is 3. So I'm selecting these columns and then I'm saying all the way whatever criteria I've given, and copy to, I'm saying M8 to V8. So that basically will give me my filtered result. So you could basically just say okay, and now I have my data which has been filtered, and I have my area which is South County, that is without pool, Central with pool, again South County without pool, and then if you look at your Central value, that's pool. So this is an advanced filter which we have applied, where simply we have filtered the data based on 2 columns and then we have our result. So in this way you can have your customized filter applied on 2 different columns and get your data, which can be either replacing the existing content, or in the same sheet in different set of columns and rows you can have your result. Let's look at one more example of filtering where you are trying to filter the data based on an AND condition being met in 2 different columns, and then you would want to filter out the data for only specific columns. So the situation is the agents with a house in North County, that should be county, area having 2 and a single type family. So we are talking about 2 bedrooms, and we would basically have a single type family, and here the criteria is that we would want to only populate these columns, which is agent, area, bedroom and type. Now what you can do is, as I explained earlier, that you can get your result in the same sheet in a different location. So here I have created these headers which says agent, area, bedrooms and type. Now this is basically a copy of all the columns what we have here: agent, data listed, area, list price, bedrooms, bath, square feet and so on. So you can basically create a copy of the headers here, and this is where we will give our advanced criteria to filter the data. So the conditions which need to be met is we need to look at North County. So for example, here in area, I can basically go ahead and select one of the values, North County. Now the criteria is having 2 bedrooms only. So let's say bedrooms, and let's say the value should be 2. And then basically I am saying a single type family. So when you would want the single type family, so here under type I can give the criteria single type. So this is my AND condition. So we are saying North County area having 2 bedrooms and the type is single family. Now this is the criteria, which basically means if I select this one tells me that this is M1 row onwards till V2. So this is what we have, and we would want to filter based on this. So let's go ahead and then go for data filter advanced. And here in advanced, it says filter the list in place. Now that's not what we would want to do. So I'll say copy to another location. This basically selects the list range. So which is telling me A1 to J126. So that's the columns and rows selected. Criteria range is based on M1, V2, which we have given here. And copy to, I would say, for example, from M7 to P7. Now this is the area where this is the place where I want the result. Let's say OK. And now I get my data, which is based on the question which has been asked, that you would want the agents with a house in North County area having 2 bedrooms and single type family. So in this way, you can basically do advanced filtering, get your data and get it stored in the sheet anywhere at a different location. Well, I could have also done filtering in place, and that would have replaced the data which we have, but that's not what we want. We would want the filtered result in a different place. So this is how you can do some advanced filtering. We can also use Excel to filter out the data in one particular column, which might be conditional or say using some numerical filters. Now here, say for example, the problem statement is that you would want to display all the houses whose list price is between 45,000 to 600,000. Or say for example, we would want to filter out the data to something else. Say for example, let's say I would want to filter out the data between 300,000 and 400,000. So we can basically update this. Say for example, I'm saying I'm interested in 300,000 to 400,000, and that's the criteria to filter out the data. Now there are two different ways, or there are two easier ways to do it. One is I would want to look at the list price. So I can select this, I can go ahead and do a filter here, and in the list price, now this is where we would want to do the filtering. So it's pretty easy. You can click on this one and then you can go into number filters and you can choose between. Now that's one easier way of doing it. So I could basically select this. I could say I'm looking for value which is greater than or equal to 300,000 and then is less than or equal to 400,000. So if I just do this, I have applied my filter and I have my data which is filtered based on my criteria, right? So that's one easier way of doing it. Or let me do a Control Z. Now let the filter be there, which you can anyways use. But what we can also do is, as we have seen earlier methods, so get a set or get your column headers here, and then you are giving two columns here. Now the only difference between my this set of columns, which I have 1 2 3 4, and then you have 7 and 10 columns, and if you see here we have 4 5 6 7 8 9 10 11, right? So whenever you want a AND condition, you will basically add the columns where I can give add condition if it is the same column. If it was a different column, then it would be same number of columns, but AND conditions will lie in the same line and OR condition would lie in a different line. Now here I can give this value, so I am looking for listed price being between 300,000. So I'm saying it should be greater than or equal to 300,000, and then I can say less than or equal to 400,000. Now that's my criteria, and then I need my result here, which is in M7. So what I can do is, once I've given my criteria which I'll be using to filter, I can get into data, I can get into advanced, and then I can say copy to another location. So it is selecting my A1 to J126. Criteria range is based on M1 to W2, and then I would want my result from this particular column. So let's say OK, and now you have your data filtered out in a different location in the sheet, which has been filtered based on your AND condition. So you can filter out the data in this way, or you could just apply a filter on a column and give the conditions. Now let's solve one more interesting problem. And here we would want to use Excel, where we would have an and, an or condition. So say for example, this is the data given to you, and the question is that you would want to find all the houses in North County. Again, that's a spelling mistake, but then they are North County area with a list price greater than 300,000 and having 3 or 4 bedrooms. So the bedroom has conditional, so it has or 3 and 4, and then basically you have list price which is greater than 300,000. Now I could have obviously selected the columns and then basically gone for a filter. So I can just do a filtering here, and then I'm looking for list price being greater than 300,000, so which we can always give a number filter, and I can say greater than, and then I can say greater than or equal. So I can say greater than, and then I can give 3,000, 30, 300,000, and that's basically the filter which we would want. And here I would want to select the bedrooms, which should be just either 3 or 4. So if for example here I go in here and I unselect this and then I say 3 and 4, right? So I am getting my data which is greater than 300,000, and it should have the bedroom values which will be either 3 or 4 selected. Now that's one way of doing it. Let's do a Control Z and get it back to as we were, or you can even just say clear filter, so you get your data back as it was. So what we can do is we can here give the criteria. So for example, I have my list price. Now this is what I would want as a condition. So let's say greater than 300,000, and bedrooms should be 3, and then I can say greater than 300,000, and then I can say 4. So this one basically gives me a situation where your list price has to be greater than 300,000 and bedroom should be either 3 or 4. So we have given our filtering criteria. Now to get the result, what we can do is we can go into data, we can go into advanced, and we can say copy to another location. So our list range is selected, which is columns A to J, row number 1 to 126. Your criteria range is given in M1 to V3, where we have specified, and we are saying the result would be in M7 to V7. So if I do this, now I have got the same data which we were seeing earlier, and here the bedroom values are 3 or 4, and basically the list price is greater than 300,000. So this is a simpler way in which you can create your filters. And all this advanced filtering, what we are seeing, it will be saved with your sheet. You can always go back and change this value, or you could do filtering where one person has to look into the filter to see what values have been selected. Now that we have looked into some operations which we can perform in Excel using filter or sorting the data, creating your tables, let's also quickly look at functions and formulas which can be used for doing some easy calculations or computations. Now, Excel can be used in different kind of data analysis. So for example, you have different inbuilt functions which can be used, and we can always check for a particular function. So for example, if I wanted to look at a particular function, I could just type in here something, for example is, and then it shows me all the possible functions. And you can always have a look at the detail of the function. For example, you have is even, which will return true if the number is even. If we would say is logical, so I could search for is logical, and that tells me whether a value is logical value, true or false, and returns your value true and false. Now we can obviously say subtotal, so you can search for any of these useful functions, and that tells me what this function can be used for. So returns a subtotal in a list or a database. You have many other such functions such as integer, sum, average. You may be interested in working on truncating some data, getting the absolute value, getting the square root, basically getting a count or getting a max value. You can look for any particular functions within your Excel sheet. Now you also have other functions such as now or time. For example, let's look at now function. So I can search for now, and here it is. So this is returns the current date and time formatted as a date and time. So this is the function which we would want to use. And if I just give the function, it tells me what is the current time. Let's first look at the description of time here. So say for example, I would want time. It says converts hours, minutes and seconds given as numbers to an Excel serial number formatted with a time format. So for example, if I would say 2 hours and then 30 minutes and 30 seconds, and if I do this, it has basically converted this into your time format. So you can always use different inbuilt functions for your work. Now we will also look at some advanced functions like SUMIF or SUMIFs. You have COUNTIF and COUNTIFs, and you can be working on various functionalities of Excel to easily help you in doing some calculations, computations, working with your data, working with your different cell values. So let's look at some example of using functions like sum or SUMIF. So for that, let's go to this sheet, and here we have some data. Now I have already applied a filter which can allow me to filter out the data. So it says find the total units that were sold in the East region. Now we know that in region we have East, and I have multiple regions. I could basically be saying unselect all and select only East and say OK, and that basically gives me the units which were sold. And if I placed my cursor here, and then if I did a auto sum, so it would basically give me the function which is being used, so something like subtotal, and it is basically working on your rows which is E2 to E44. And here we can just do this, so that gives me the total. But this is fine, you could do that, but it would be good if we know how do we use a function like SUMIF to do that. So here I'm seeing this is the subtotal where I'm looking at the values, and basically what I have done is I have filtered out the region, and then basically I'm getting a count. But this does not give me clearly how a sum was calculated from all the values which were listed. What we can also do is let's do a Control Z and let's get it back. So now we have our data and we would want to get the total units that were sold in the East region. So what I can do is I can start typing in my formula, and for that I'll use an inbuilt function. So for example, I would be interested in going for SUMIF. Now it says SUMIF adds the cells specified by a given condition or criteria. When you talk about SUMIFs, this is when you could give set of conditions or multiple criteria. So let's look at SUMIF. Let's do this. Now obviously this gives me an error because the formula is not right. So we have to basically come in here and let's start with sum if. Now when I say sum if, it shows me there is a function with sum if which we would want to use, and here once I open up the bracket, it tells me, okay, what is the range of data which you are interested in. So I'm interested in all the units that were sold in the East region. So we are interested in the region which is here. So I can basically be selecting this, and this tells me you are interested in the data here. So let's not take the header value. So let's say B2, and then we can go all the way to the end. So we can basically select this way. That's the data we have. Select this and hit enter. So now here it has selected B2 to B4, but we need to basically now give the criteria. So the criteria is either a value or you can point it to a cell which has that particular value. So as per our problem statement, we are looking for the units which are sold in East region. So I can select the value East here, and then my SUMIF needs the range on which you want to calculate a sum. So let's select this, and now we are interested in finding out the sum of units. So that's basically this column, E column. So I can basically type in instead of selecting. So I can say E, and I'm interested in E2 to E44. So that basically selects the area or all the values. And now let's do this. So that basically gives me the sum is 691. Right now, this is the criteria where I have pointed it to a cell, and whatever value that cell has, well, I could have done something like this. So I could have selected East, giving the value, and then doing it. It still does the same thing, and in this way you have more clarity that you are using SUMIF. You are filtering the data, so you have given the rows, you are given the criteria, and then you have given the range on which you would want to sum up the values. Now similarly, if the question was what was the total revenue generated from binder, now we would want to find out what is the total revenue generated from binders. That means my filtering criteria will be binder, and then I want to find out the total revenue generated. So we have the revenue generated field also here, and we don't have any region to be filtered. We are just looking for binder. So let's again start doing the same thing. So we can go for sum if, we can open the bracket. Now it needs the range, so we are interested in revenue generated. Now that's the summation we want, and we would want to get the range of data. So here we can basically select D2 to D44. So that's the data selected. Now I would want to give the filtering criteria. So let's say binder, and then we need to give the range on which the sum needs to be calculated. So that's my revenue column. So that's G. So I can say G2 to G44, and that basically selects the column, and then you get your sum. So it tells me what is the total revenue generated from binder. Now, I could be doing this for other things also. So say for example, if you would want to filter out something else, you could basically just drag and drop here, and then I could come here and change this to, say, instead of binder, I would be interested in, say, pencil, if that's the criteria you are interested in. Remember to change this so that you take all the values, and here we will change it to select the relevant rows, and then this is the data I'm getting. So I know that this is the revenue generated from pencil. This is the revenue generated from binder. Now this is a simple use case where we are using sum if. What if we would want to use some ifs? So some ifs, let's have a look at how we get to some ifs. So some ifs is where you would want to work on doing some calculation, but then you would want multiple criterias to be met. So let's see how we get this. So here what I can do is, let's work on this problem statement which says what is the total revenue generated from central region where the item is a pencil. So that's something which I would want to check. Now, when we are answering this question, we can also look at the order in which things have been asked in the question. So it says, what is the total revenue generated from central region? So we need the total revenue generated. We know there is a revenue column. We are interested in getting the total revenue generated. We are saying the filtering criteria is central region, and we say in that we would be interested only in the item if it is pencil. How do I do it? So I can use some ifs where you can pass in multiple criteria. So let's start with some ifs, and when I start with some ifs, let's open up the bracket. So it says sum range, it says criteria range, then it gives one criteria, and you can give in any number of criterias. So for example, we are interested in total revenue generated. Now that's my G column. So let's follow in the same order. So let's say G2. So that's my first value. And then I know there are 44 rows here. So I can say G44. And you can obviously check if that has selected all the rows. Now that's my total revenue generated. So I would want the total revenue generated. So I'm saying setting this sum range. Then I need to give the criteria range. So it says from central region. So central region comes into column 2, that's B. So let's say B2 to B44. So that's my criteria range. Then you have to give your criteria, but we need to filter out the region being central. So let's select this. Now either I could point to a value in the cell, or I can just give the exact value here. We can also give a wildcard or matching pattern, so that also works. Now this one is fine. We are now also interested in finding the total revenue generated when the region is central and the item is pencil. How do we do that? So for item, we know the column is D2. So let's select D2 to D44. So that basically selects all the rows in the D column, and we need to give the filtering criteria. So let's do a comma and then just given our value. So let's say pencil, and then let's close your bracket, and that basically gives you the result. So we need to just follow the order of our question, which says what is the total revenue generated. So we are looking at the revenue column, we are selecting all the rows. Then it says from the central region. So we need to select the region column and give the filtering criteria as central, or point to a cell which contains that value. And then it says we would be interested only in item being pencil. So then you select the column which has all the items and provide your filtering criteria, that is pencil. So that's your easy calculation of using sum if, which we compare with sum if here. So sum if here was just having your criteria. So basically you are selecting your rows, giving your filtering criteria, and then your sum range. In sum ifs, we are giving multiple condition. Now same thing can be done here. It says how many units were sold by sales representative Jones, where the cost of each item was greater than 4. So how many units were sold by sales representative? So when we talk about how many units, that's your E column. So let's start with that. So let's say sum ifs, I would be interested in E column. And let's give the range. So it says sum range. So those are the number of units on which we would want to find the sum. Then it says you need to give the criteria range. So we say sales representative, where the name is Jones. So sales representative is in sales rep column C. So let's say C2 to C44. Now then we need to give our filtering criteria. So let's say Jones is the sales representative where we are interested, about whom we are interested in. And then the question says where the cost of each item. So cost of each item is what we are interested in. You have unit cost. So that's what we are interested in. So that would be F, and then say F2 to F44. And then you need to give your cost. So it says where each item is greater than 4. So let's select this and let's do this. So this tells me 301. Now, similarly, let's answer our third question, which says how many units did Jones sell excluding pencil item? So we would want to find out what was the total number of units that were sold, and that units or that should not include the pencil item. How do we start doing this? So let's start with sum ifs. Now we know that you start with sum ifs, you need to give the sum range. So we are interested in the number of units. So let's basically go in and select our number of units which were sold. So that's your column E. So I can say E2 to E44. That's where I would want to perform the sum. Now I'm saying how many units that were sold, where we are talking about sales rep being Jones. So let's select the columns C and then give the range. After that, we need to give our filtering criteria, which is Jones, and then we are interested in the items, but excluding pencil. So items is in column D. So let's say D to D44, and then we have to give our criteria. So we can say, well, that should exclude pencil. So I can basically say pencil, and let's close this and let's check. So that's my formula, which says that these are the number of units which the sales representative, whose name is Jones, had sold, and that does not include pencil as an item. Let's also look at an example of using COUNTIF or COUNTIFs. Now, both of these can be very useful when you would want to calculate certain values. So for example, if I would want to work on COUNTIF, let's try solving this problem. Now remember, you can answer these questions using filters and that can be an easier way. But then sometimes you may want to get the formulas so that you can make your spreadsheet and your calculation more dynamic in nature, and that will basically depend on the values in the columns or rows. So for example, if I have find the total number of times Gil has made a sale. Now if I look at my data here, it tells me that for every sales representative there is some value in the sale, and it says sales has greater than 3. So for example, Jones, you have sales greater than 3, or you have Jardine, which is sales greater than 3, and so on. So what we are interested in is doing a quick count and finding out the total number of times Gil has made a sale. How do we do that? So we can use this count if function, and if I go into count if, it says counts the number of cells within a range that meet the given condition. Now what's our condition? Our condition is Gil, and we would want to find out how many times the name say Gil appears or Gil has made a sale. Now I could just say count if and then open up a bracket. I need to give a range. So let's say we are interested in looking at the range. So let's say we will choose sales rep. So I can say C, and then I can say C2 to C44. Now that's my range. Let's not give that in quotes. So you have to give a range. So let's do a count if that selects the data, and then we need to give the condition. So for example, let's here give the name, which is Gil, and then close this. So that basically tells me it is 5 times Gil appears here. We can check this. So I can go in here, I can add a filter, and then might be I would be interested in looking at only Gil, and that basically gives me 5, right? So we can always do that, and we can be using formulas like this. Now what about this question? So which basically says which sales representative made a sale more than 3 times. Now it might be looking little confusing when I say, for example, let me clear out this filter. Now we have sales greater than 3, and we would want to find out which sales representative made a sale more than 3 times. Now I could basically check for every sales representative here if they have made a sale more than 3 times, and what I can do is I can just say equals, I can start with count if, then I need my filtering criteria. So that's your range. So first thing is we will choose, for example, let's choose C2 to C44, and then we need to give an criteria. What is the criteria? We need basically a sales representative. So I can choose the value here in C2, and then I can close this, and then I can say the sale has to be greater than 3, and let's check. So it tells me the Boolean value that yes, this guy has made sales more than 3 times. And what we can do is we can just drag and drop, which basically gives me the value for other sales rep. You can always check the value is automatically changing to this value in cell. And for example, let's go in here. So this is obviously 2, so it says me false, right? And you can basically get the values for all your values. So that basically tells me which sales representative has made a sale more than 3 times. Now, like some ifs, we also have count ifs where you can give multiple criterias. So for example, the question is how many orders were placed from the East region after this particular date. So we have a date criteria, we also have the region criteria, and we need to basically get the count of number of orders which were placed. Now I can in this case use count ifs, And this basically says that you can start with a criteria. So it says how many orders were placed from East region after particular date. So date is in my first column. So for example, I could say A, start with 2, and say for example, let's go A44. That should have selected all the rows. And then I need to, once I've given the criteria range, I need to give the criteria. So we are saying the date has to be greater than 10th Feb. So let's give it 2/10/2019. And then you need to say how many orders were placed. So you need to give the criteria, second criteria range. So we are looking at the number of orders which were placed from the East region. So when I would want to look at the region, that's your column B. So I can basically say B2 to B44. And here I would basically give my criteria. So the criteria is East. Let's give that. And once you have done this, you would want to find out the total number of orders. So let's select this. And if I do this, it tells me 13. Now, is that right? So we are looking for your date, your region being East, and then getting the total number of orders. So here I can just do a count if I'm saying A2 to A44, wherein I have given the date criteria that it should be greater than 10th Feb, because I do not want to count 10th Feb. It says after 10th February. And then you are saying the region has to be East. So we would want to find out the total number of orders. So my region is East, and that gives me the result. Now similarly, you can also find out how many times Gill sold pencils. So here we will have to give the range. So let's start with count ifs. Now here I would want that item is pencils, so we can as well select column D to D44. Then you have to give your criteria, so that's your pencil. And then we are looking for sales rep, which is Gill, so that is my column C. So let's say C2 to C44, and the value should be just Gill. So it tells me it's twice where Gill has sold pencils. So we can obviously check this by going in here, choosing my filter, and then let's search for rep being just Gill. Okay, and now we are interested only in the item being pencil. So I can say, well, let's get to pencil only, and that tells me twice. So you can obviously re-verify using filters, but using functions or using formulas, it is always good to calculate, and that can be making your computation and calculation more dynamic. Let's look at one more interesting feature of Excel, and that's your conditional formatting. Now, as you see on the screen, conditional formatting has different rules which can be applied on your data, and that allows you to basically differentiate or easily identify data values which are based on certain criteria or rules. So when you talk about conditional formatting, you have different options, such as you can highlight cell rules, you can get top and bottom values, you can apply different rules, apply different color scales, and you can easily manage these rules. So conditional formatting is very useful for people who would want to work on huge amount of data and easily perform some data analysis. It's easy to use as it is shown here, and with your conditional formatting you can format cells based on a preset condition. You can perform conditional formatting to identify cells. You can highlight a few significant cells, and you can easily perform conditional formatting as shown on the left side. Now, how do we work with conditional formatting? Let's have a quick look. So say for example, we have our Excel sheet, and if you see here, I am highlighting the salesperson who have generated revenue greater than 10,000. So we can be looking at the values where the revenue generated by a particular salesperson is greater than 10,000. It has a particular color. And how do we get here? So for example, let's select this data, and what I could do is I could go into conditional formatting. Now I could basically highlight cell rules, and we could just say greater than. That's an easier way. I could also go ahead and create a new rule, but then I can use one of this option. I can say greater than, and let's give some value. Might be we would be interested in looking at any value greater than 12,000. So let's choose 12,000. And here it says what color would you want to select. So for example, I would say something like yellow filled with dark yellow text, and let's say okay. So right now what I'm doing is I have all the values where the revenue generated was greater than 10,000, but then I have also selected all the sales people who have made or who have generated revenue greater than 12,000. So I can just do a control Z to see the previous result. Now here I had the values which were greater than 10,000, and the one which we did just now basically highlighted the values which are greater than 12,000. So this is one simple example. Now we can look at some other examples. Say for example, you want to format cells using 3-color scale. So if you look at the values here, I have a 3-color scale mainly in green, yellow, and red. And how do you do this? So for example, I can go in here and I can go to conditional formatting. So I would want to go for color scales, and here you can create different rules. So we can set up a 2-color scale. So we can say format only values that are above and below average. I can format only cells that contain something. I can get the top and bottom value. So these are different ways in which I can have a 3-color based scale. Now what I will do is I will select this, and let me show you the rule which I have. So for example, I can go into manage rules, and if you see here, there are certain rules which have been specified. Now what does that mean? So you would want to specify a 3-grade scale. So for example, if I would want to look at my first rule, it tells me that I'm choosing 3-color scale. I can choose lowest value, percentile, and highest value, and that basically will select the cells based on their values. So what we could have done is I can basically use one of these values. I can delete these rules which I have created. So for example, I have all these rules, but you should always carefully remember that the rules will be applied in the order shown. So for example, if I just delete these rules and then say apply and say okay, my data is back. Now it does not have any highlighting. Now I can go in here, I can say conditional formatting. I could go for color scales, or I could basically go into new rule. So I would want the cells to be using 3-color scale. So let's choose 3-color scale. Now when you say 3-color scale, it says what will be the color of lowest value, and we could choose, might be any one of this. Let's choose red. I can say midpoint is percentile 50, and then the highest value is green. And if that looks good, let's say okay. And now if you see, the lowest values have been highlighted as red. You have mid values, and then you have the positive value. So this is the 3-color scale, and that easily helps me in identifying the data based on the cell values. Now, in conditional formatting, what you can also do is you can basically color the cells based on their value. So what we are seeing here is if the revenue generated is greater than average, then that shows in green. And if the revenue generated is lesser than average, that shows in orange. Now, how do we do that? So we can basically again manage some rules. So I can basically create a new rule. Now here I can select one of the options which says format only values that are above or below average, and that's the option I would want to select. Now I can select this, and it says format values that are above average. So in our case, we had it in green. So for example, I'll say above average, and then here I can go for a particular color. So you can go for a particular size. So let's go and look into the formatting. So for example, let's choose yellow. Say okay. Now I'm saying wherever the cell values are above average, it would be yellow instead of green. And let's go in here. Let's go and look into manage rules. So this is basically the rule which we are applying. Now we can also add a new rule, and I need to select the values. So for example, I will say here, so we had gone for above, now we'll go for below. We'll go for format, we will choose red, we'll say okay, we'll say now these are basically the rules which we have created, and here it says applies to your data. So right now it has not been applied. So for example, if I select this, and then I could basically choose my area, just hit on enter. And similarly, you can go in here and then select your area, hit on enter, and say apply, say okay. And now if you see, I have really chosen bright colors, but then I have said wherever my revenue generated is above average, it should be in yellow, and below average should be in red. So we wanted above average to be in green and below average to be in orange. So that's what we have here, right? So you can always color code your cell values based on some rules which you are setting up. Now similarly, you can also find the top 10 and bottom 10 values, and that's pretty easy. So you can just select this, and then you can go into conditional formatting. You can go for top and bottom values, top 10 items, bottom 10 items, or you can go in for more rules. So you can say format only top or bottom ranked values. So you have top 10. Now you can choose the color, and for example, I'll go for blue, and I'll say okay. So now if you see, my top 10 values are blue. Now similarly, I can add one more rule. So I can say new rule, and I can say let's go for top or bottom. Let's go for bottom. Let's go for format. Let's say orange. Say okay, say okay, and that's it. So now you have your values which are top or bottom 10 values. So you are using conditional formatting where you are basically highlighting your cell values based on different colors, and here easy conditional formatting based on different rules helps us to do that. Now similarly, you can also have the values which is basically showing you how the values are increasing. So what we can do is we can select our columns. Either you could apply this to all the columns. Now here I have applied this only to Jan and April. Now I could apply this for June. So let's say June. So you can go for gradient fill, you can go for solid fill, you can obviously just select the color, and that takes care of the things. You can say, for example, select this, and now this is selected, but I would want to might be format this. So I can go in here, I can go into manage rules. Now that will tell me what rule has been applied in the order. So I can just do a edit rule, and that basically says this is a solid fill, which is color, you have no border, this is basically color is black. Now I can go for something like gradient fill, and I can say okay. And now if I say apply and okay, so this basically is like your first column. So you can use conditional formatting for various use cases, and you can highlight the values. So anyone who would look at the value would automatically notice which are the higher values, which are lower values. Might be here the revenue is getting generated or was getting generated but did not grow beyond a particular value, and so on. Now similarly, you can also go in for different options. Say for example, here we would want to see if the revenue was dropping, or if the revenue decreased, or say for example if the revenue was going up for this particular salesperson. So here we are looking at Carol. So in Jan the revenue generation by sales was very high, then in Feb it was falling down, in March it was kind of stable, then in April it went way below. So we can obviously work on this, wherein we can grade our cell values. So what we can do is we can go in for highlighting the cell values. Now you can go for color scales, you can go for icon sets, and this is where you can choose your different shapes. So you could choose one of these shapes. So for example, I would be interested in looking at the indicators like directional. I could go using this 3 arrows. I can go in for this color, I can choose directional, and then my values are automatically using directional. Now what we can also do is we can then go into manage rules, and that basically tells me what rules have been applied. So for example, the latest one is the icon set, which I have chosen. It shows the selected columns. I can obviously do a edit rule, and then I can choose. So I'm saying the format style is icon sets. I'm not using a data bar, I'm not using color scale. Now here I have chosen the style of icons, and then here you can basically give some values. So you have icon which is green when the value is greater than or equal to 67%. When I say hyphen or minus, it is less than 67. It's way below 33%, then you give this value. So you can obviously edit and easily highlight your cell values based on this icon set. So I can apply this, and that's how I use conditional formatting. So conditional formatting can be very useful if you would want to use icon set, if you want to use your data bars, if you would want to highlight particular values, if you would want to color code based on some calculation, if you would want to use a 3-color or a 2-color scale, or if you would want to just find out values based on some simple calculation. So conditional formatting is used extensively by data analysts, or people who are working in business intelligence teams, or people who would want to use Excel to easily identify the data, easily identify the cells which contain particular value, or finding out less significant or more significant cells to then pull out values and carry out your computations, calculations, or analysis. So let's continue learning on using Excel for various things. Now we have learned on conditional formatting and seen how that can be very helpful. Let's learn one more feature of Excel, and that's basically your data validation. Now this can be very useful when you would want to work on validating the data which is being fed in the cells. So you could limit it to basically a number between a particular value. You could also add some messages to it if you would want, or you could even circle invalid data or clear validation circles. So data validation really helps us in validating the data which is being fed in to particular fields. Now, it's a feature in Excel which is mainly used to control what a user can fill in a cell. You can decide what type of values must be entered. You can also restrict user to enter only valid data. And if any invalid data is entered, an error message will be displayed. Now that's where you can use your data validations. So let's see how that can be done. So for data validation, let's see some exercises here. So for example, you have a name column and you would want to restrict that the name should accept only 15 characters. Now, how do you do that? So you can basically select the cells, or you can just select a particular cell and then we can later drag the property to other fields. Now here, once the cell is selected, so for example, let's try this out and let's see if that works. So for example, I will say Peter Johnson, okay, and that is basically 5 and 9 and 12 characters. So let's say junior, and if I do this, it says input length is greater than 15. Do you want to continue? If I say yes, right, so basically it is allowing me to add the value here, but then it has basically violated the rule. Now this is giving a message to the user that the username should be entered less than 15 characters. Now how do we do that? So for this, we can basically select the column and then we can search for data tab and get into data validation. So this is where you can create or select different kind of rules. So for example, I can go into data validation, I can go into settings, and I can say the text length, and that should be less than 15. Now this is the maximum I'm giving, and it says apply these changes to all other cells within the same settings. So I can do this, or I can just drag and drop. So I can basically apply this formula, and now you can in fact randomly check in any particular cell, is the rule applied. So it says text length less than 15. So we can basically control data validation in this particular column, and that will allow only 15 characters. It will pop up a message if the user really wants to go beyond the particular limit. Now you also have similarly date of birth. So the restriction is date of birth should be between 10 Jan 1990 to 30 December 1998. So this is what we want to restrict. How do we do that? So we can select the field, we can click on data validation, and if you see here, I have selected date, and then date is between, and then obviously you can give a range, that is 10 Jan date 1990, 12/30, 1998. So that's the start and the end filter which has been applied. And once this is done, you can also check your input messages, which says when cell is selected, show this input message, enter a valid date. So if you see here on the left, there is a pop-up which is coming up which says enter a valid date. Now I can also say when user enters invalid data, show this error alert. So I can say stop. I can say invalid entered. And this is how I have set a rule. So for example, if I just do something like this, and that says invalid date entered, I can do a retry. It will take me back here, but unless and until I do not give the right format, the date will not be accepted. And again, the same thing applies to all the cells. Similarly, email. So we are saying the email should have @ present in the value provided. Now for this, we can use a formula and we can select, well, I would want to apply this rule to all these rows starting from C2 to C14. So let's get into data validation. Let's look in settings. And here we are choosing custom. Now within custom, I'm choosing what is the formula. So I'm saying is number, and then I'm saying find @ for the rows C2 to C14. So the only thing we are concerned about here is the value should have an email icon. You can input a particular message. You can say what has to be done for error alert. So for example, we can basically go in here and we can say invalid email. That's the title I'm giving. And we can say email should contain @ So if I do this and if I say OK, now you can test it. So you can say A, B, C, D, and that says email should contain @ and basically that will not allow me to add the values. So now you have the field called salary. It says salary should be greater than 50,000. Now we can limit the values by choosing a whole number. So for example, for salary, I can go into data validation. I can go into settings. So here I can say something like decimal, or I can go for whole number. So both of the things are fine. It depends on what kind of values get into this particular field. So if I say whole number, and if I say it has to be greater than 50,000, so I'm saying the minimum is 50,000. Or I could have given a decimal and then I can say greater than, less than, equal, or anything, or even between. So I can select greater than and then I can just say OK. Now for rank, the rule is rank should be between 100 and 200. So again, we can use a whole number. So ranks will generally not be decimal. So this would be whole number. Salary can be a whole number or it could be decimals. So we have chosen decimal here, and in rank, if you click on data validation, I have chosen whole number. I've set data between 100 and 200. Input message, nothing. Error alert, nothing, but that depends. I can give this. So this is how you can just do a simple data validation and control the values which land in the cell. Okay, so now let's also understand how we can restrict the values in a particular cell, which might be based on a list of items. Now, for example, here, if you see, I have two columns. So one column basically has the values of city names, and then you have places within that particular city. So if I would want to implement a data validation based on this, so for example, if you see here city, and that basically shows me only the 4 values which can be entered. And if I go to place, then it tells me for Maharashtra, I can only enter Pune, Mumbai, Nasik. Now, how do I do this? So say, for example, you take an empty field and you want to restrict the values of city names. So I could select data validation. I could basically select list, and then it tells me you need to enter the list values, that is the source. So you click here, and then I can just select these fields. Now, if I do this, and if I say OK, it has implemented a data validation. But if you look into this, it will show me the same thing, but then it shows me some empty cells which did not have any value. So this is fine, but it would be better if we do it in a different way. So I can select this, and I've already given my city names here. So I can just do a data validation, and here in the source, let me get rid of this. Now I can just have my cursor here. I can select these values, and then if I say OK, so now if you see, my city names have been restricted to these values. And that's how you can implement your data validation. So I have this data validation here, but I will get rid of this one by just doing a Control Z. Now I'll come here and say, for example, I would want to implement the same data validation. Now the easiest way would be in doing this for all my 4 cities. Now if you see here, I have data validation. I could choose Bangalore. And if you come and check here, there is no data validation, but we have implemented data validation here. Now, how is that done? So I could select this, or for example, I can go in here. I can select data validation. I can select list. And then here in the source, I will say for Bangalore, the values should be these. And then if I basically say, OK, now if we see, these are the values which are fed into Bangalore. So we could do this, or like what we have done here. So if you can check the data validation rule, I have used list, and then I have said indirect F2. So basically I'm giving in a formula which relates to the value which is in for the city Maharashtra. So we could do this, or in a simpler way we could do this and then just drag and drop here. So we could check for Maharashtra what are the values. Let's choose a different city. So for example, Kolkata, and here I will choose. Now since we did a drag and drop, it has basically taken the values of Bangalore. So that's not right. So we select this, we go into data validation, and here I can either feed in the values, that is such as Bangalore. I could basically say something like this, Kolkata, and I could say OK. So now if you see, it shows me the places in Kolkata. Now here we have, let's choose a different city. So for example, let's go for Delhi, and here I can go to data validation and I can just say Delhi. So this is an easier way of doing it. Or if you remember the formula, then what you can do is you can just give in indirect and then basically give the value of the cell for which you would want to keep in the values. So this is how you can do list validation. So you can provide a list of values, and then you can restrict the values in a cell which should be belonging to a particular list. So this is how you do a simple data validation by restricting the data in the form of a list. Now let's learn about pivot charts and tables, which is one more very useful feature of Excel and which allows you to work with your data or perform data analysis. Now, pivot table is a summary of your data. It is used in cases where there are numerous rows and columns in your data set, and it allows you to group your data in several ways so that you can derive meaningful information from it. Now, the visual representation of a pivot table is termed as a pivot chart. Now, how do we do that? So let's see an example. Now, here is some data. Here you see we have some row labels, which basically gives me some category of items here. It also tells me the sum of sales, and basically it gives me per item what is the total sum of sales which were made. Now, how do I get this here? So for example, if I would want to delete this, and I would be interested in getting the total sales under each category of items. Now we know that we have different data here and it's huge. For example, on the row end, if I just do a control and right arrow, it tells me what's my right last column. And if I just do a control and down arrow, it tells me there are 9,994 rows. Now I can use this And what I can do is I can basically work on insert and go to pivot table. Now this basically tells you need to choose the range. Now since I have chosen my first row and first column, it basically has selected the data, and that's fine. Now do you want the result in a new worksheet? I'll say existing worksheet, and I can choose a location. Now that basically needs me to select a field. Might be we can just select this field, and that should be good enough. So for example, if I close this or if I say OK, so this is basically an indication that my pivot table will be created. Now, what are the fields we are interested in? So as per the problem, we need to find out what are the total sales for each category. So let's go in here and let's select the field category. Now, as soon as you do that, it shows that the rows which are being selected are for this column category. And now we are interested in getting the sales. So we would want the sales per category. So let's select this. So you see sum of sales is selected. Now close this, and that's it. That's your data. So it shows you row labels. It tells you what are the different categories, and it also gives you sum of sales, which is per category. Now this is one easy example where we have solved the problem, where we have tried to find what were the total sales under each category of items. So for example, let's have another data set. So again, you can just check how many rows we have, and it is basically the same 9,994. And if I look in columns, it basically shows me profit is the last column. And here we would want to find out which category. So for example, let me get rid of this. Which subcategory of items sold the maximum under each category? So we have some categories here which says furniture, and it shows some subcategories, and then it shows me office supplies and then some subcategories, and same thing with technology. Now we know how we got this data, but this is different than what we were seeing here. So here we were just getting the categories, but we did not have any breakdown of subcategories within this particular category. And here you see there is a breakdown, and then basically you can also apply a filter which basically says what is the data you want, and if you are interested in finding out a particular value. Now how do we do this? So for example, let me get rid of this. Now we know how we can find out the category of items, but we would want to find out which subcategory of items sold the maximum under each category. So here we are not looking at sales, but we are looking at the quantity. Okay, so what we can do is we can go to the first row and first column, click on insert, click on pivot table. Data is already selected. Let's choose existing worksheet. Let's choose a location in our worksheet where we would want to have this. So might be I can select this particular field and then just close this. So it says this is the existing worksheet. Say OK, and now you need to select your columns. So for example, if I would want the data for categories, so I can select this. Now I know that within category, these are the options which we have, and then there is a subcategory. So let's select that. And if you see here, now we have the data which will be filtered. So based on your category and subcategory, and then we will choose quantity. So it automatically understands that this is something on which summation can be done. So let's select this and close on this. Now if you see here, we have got our items where we can see the subcategories within a particular category. Now I can basically close this, and that just shows me high level categories here. So here I can again select a particular row and column. I can go for either a new pivot table. So we could basically select this. The row is already selected. Existing worksheet is what I want. So now I will select this particular place, say OK. Now we do the same thing like what we did earlier. So we will select category, subcategory, and quantity. So the data has already come in. Just select this, and now you already have all your data. But this is not what we want. We want to basically apply a filter to this. Now how do we do that? So we can go for slicer. So I can go for insert slicer, and then it tells what are the subcategories which you are interested in. So for example, if I go for something like subcategory and say OK, so this tells me what are the categories you are interested in. So for example, we know that furniture has furnishings with the highest value. So I can select, say, furnishings, and then I was interested in office supplies. So within office supply, I can basically search for here binder. So I can just do a control and select binder. And then I can also know for technology, I can select phones. So I'll say control and select phones. And now if you see, the filter has been applied and we have these subcategories which are selected. So we have our data here. Now we don't need really this. So I can just delete this and I have my data which shows me furniture being the main category, and that has only furnishings, office supply having binders, and technology having phones, and that basically is a filter applied on the result of your pivot. So this is how we are seeing which subcategory of items were sold maximum for each category. So this is how you can easily use pivot tables and you can do some analysis. Let's look at some more examples. Now, let's see if you have to answer this question, which says which were the top 3 states for each region that made the highest average profit. Now, how do we calculate that? So for example, this is the data we have, and as I've instructed earlier, you can select the first row and first column. You can click on insert, go into pivot table, and that basically selects all your data. We will choose the result should be in this existing worksheet. So select this, click here, and then basically let's select this cell and I will say OK. So now my pivot table will be here. So we are interested in finding out top 3 states within each region which have made the highest profit or which have made the highest average profit. So for that, first we will select region. So when we select region, it shows here region, and within region you will then select state. So within every region you have multiple states, so that's what we are selecting. And then we are interested in looking at the profit, so let's select profit, and that automatically shows up here. So we can now say close this. So basically we have all the data, but we are looking at the sum of profit, but that's not what we want. We are looking for top 3 states from each region that made the highest average profit. Now, how do we change that? So here we have sum of profit. So I can do a right click and basically I can say summarize values by average. So now I'm getting the average here, and that basically tells per region I have the average profit. But first is let's sort this data. So let's go into sort more options, and here I have average of profit. Or for example, as I said, you can select region, say OK, and now it is basically having the regions, and then you have your state value. So again we can do a sorting here, and I can say let's go for more sort options. I'll say descending. The state values should be based on average profit. So let's say OK. And now if you see in particular region, we have the data which has been sorted, wherein you have the highest average profit on the top. Now what we can also do is we can basically Then go for filtering. We can say top 10, but I'm not interested in top 10. So I could reduce this to top 3. And this is the items, average of profit, say okay. And now you see per region, you have the data which is showing me top 3 states, what are the average, and then you are also looking at the subtotal, so which basically says average profit for your west. Now if you would want to arrange this, your west and south and east and central in a particular alphabetical order, if you would want to sort it, you can always do a sorting, and you can choose sort Z to A if that's what you would want to do, or you can go for sorting, more sort options, and you want to sort the region, which is as of now based on descending Z to A. Let's make it ascending, say okay. And now you see the data has been filtered, so it says per region. Now you can always select this and you can say what is this. So this is basically your average of profit. Now we are looking at each region and the states, the top 3 states as we wanted within a region, and what is the average. Now we have one more question. What is the percentage contribution of each subcategory of products under each category to the total sales? So we know there are different products, there are different categories, and all the categories contribute to the total sales. So we would want to find out what is the percentage contribution of each subcategory of products under each category. So we not only want the category percentage, but we would also want what is the contribution of each subcategory to each category to the total sales. How do we do that? So for that, we need to again just place our cursor here or select the first row and first column, click on your insert, click on your pivot table, and now the data is already selected, existing worksheet. Place your cursor here, and then let's select this cell, say okay. Now your pivot table fields are here, so we are interested in category. So let's select category, and then within a category we will have subcategories, and we are interested in the sales data, wherein it is already going to give us the sum of sales, but we would want this in the form of percentage rather than just the sum. Now we can click here value field settings, and it says if you would want to summarize this, it says show value as, and what are the values you would want. So you can straight away go ahead here and say percentage of grand total. So we could do that because we know we will get a sum of sales and grand total. Now I could basically say percentage of grand total, say okay, and then just close this. So once you have closed this, you see already the data is in percentage. So now we have our data with subcategories, but we also want the data to be sorted, might be in a descending order, which tells which subcategory is contributing more than others. We can select how many subcategories we are interested in. So we can basically select one of the subcategory cells, right click. Now you have option filter and you have sorting. So we can say more sort options. Now here I will say descending, and you want the descending to be sum of sales, which is already showing as percentage. Click on OK, and now you see for each category it shows the percentage contribution towards the sales. It shows the subcategories contribution to a particular category and also to total sales. So technically speaking, if you look at all these values which are subcategories, and if you would total them, that would be your total grand total. So this is how we can solve a simple problem like this. What is the percentage contribution of each subcategory of products under each category to the total sales? The next question is, which customer made the lowest profit in the home office segment in each state. Now here we know that we are looking for home office segment. We are looking for customer which made the lowest profit. We are also looking for the state as the main criteria. So in each state, we would look for home office segment, and within that we would look for customer which has made the lowest profit. That means the lowest value of the profit. So how do we do this? So let's get into selecting our row and column. We will go into insert. I'll say pivot table. I'll say existing worksheet, and let me get my result here. So let's say okay. Now that gives me the pivot table. So the first thing is we are looking at per state, and I would be interested in home office segment, or I could first start with segment. Now here we have segment, and in segment I can basically select home office. So I can just do a uncheck and select home office only, and now I can select state. So that will be my subcategory within segment, and then within state we would want to find out the customer. So let's get the customer name, and we are interested in finding out the lowest profit. So let's select profit, and here we have sum of profit. So the fields are selected. Close this, and now you have your data which basically shows me the names of customers which made the profit, but it's not sorted. So we can sort this, and we have state entries also, so that's fine. So what I can do is here I can basically say sorting, go to more sort options. I can say I want to do a descending, or I want to do an ascending based on sum of profit. So let's do that. Now you see the topmost value is the lowest value per state within home office segment. Now what we also want is we just want one value per state. So how do we do that? So we can just go for filtering, go for top 10 values. I'm interested in bottom value, and in that also I'm looking for only the lowest value. So let's select 1, say okay, and now you see we have data for home office segment per state, customer who has made the lowest profit. So we have easily answered this question using our pivot table. Now say for example we have a question which says find the sales made in each quarter of 2016 for all the regions. So the data has to be divided quarterly, and use order year as a slicer. We can do that by selecting what data we would want to slice, and then we would want to create a pivot chart also. So for example, how do we do that? So for example, I will get rid of this, I will get rid of this, my pivot chart, which we can recreate. So find the sales made in each quarter of 2016 for all the regions. So this is what we want. Now how do we do this? So for example, let's select this. We will do a insert pivot table. We will basically say existing worksheet, and then I can select this particular cell. I'll say okay, and now I'm interested in data quarterly. So first let's select our field here. So we should basically have, if all our fields are selected, say for example if I say order date, now you see we have quarters and years which are selected. Now we could be selecting these fields which says quarters, years, and if I would want data to be filtered based on years, I could do that, or I could get rid of years. So I have quarters, I have order date. So that's being already selected. Now what else we need? We need to find out for every region. So let's select the region, And we can also add region as a column here. So that will basically give me all the regions as different columns. And then finally we want the sales. So let's select this. And now let's look what we have. So if you see here, we have our data, which is for each quarter. It gives me the total data, but what we would be interested in is not looking at the total data, but we are only interested in quarter of 2016. Now, how do we do that? So what we do here is we have row labels. So let's click on this. So we have date filters, and then in date filters, we can go for between, and then we will say 2016, and the value has to be 1. And then let's select this, and let's change this to 2016, and this is 12th month, and then we can say 31. So we are saying the date has to be 2016, and it basically says not a valid date. So let's select a particular date and see. So the month has to be here. So let's change this, and let's make it date and say OK. And now we have our data, which is for 2016. So for example, I could basically select this, and here I could be looking at what are the filters we have. So it says clear filter from order data. So we have applied the filter on order date, and these are your date filters, which is basically date 16. Oh, this is wrong. So this one has to be changed to 2016. So select this, and now we have our data for 2016. So we have found the sales made in each quarter of 2016 for all the regions, the grand total for a particular quarter if we are looking at the value, or for individual months in a particular quarter. And we have sliced the data. Now we could have also introduced a slicer by selecting which field we would want to implement. So for example, if I would select a particular field and then I could click on slicer, I could choose I would want to slice the date based on order date, and then could have done it. Or we have just given the date for 2016. Now we just need to plot a graph for this, and that's very easy. So you just need to select the complete pivot data, and here you have the chart options. So let's go for line chart, and that basically shows me the line chart. So we can select this, we can just drag and drop it here, and then we can basically check if that is showing us the data. So if you see here, this is line chart where it has divided the regions in different colors. So we have all the regions. We could filter out in pivot chart a particular region. We have the quarterly time here. In order data, the filter is applied. It says it is 2016. In quarters, it tells me it is 16. So we have our data. We have created a pivot chart, and basically we have sliced the data for 2016. Let's answer one more question, and that's finding the profit made in each year for all the categories of products in East and West regions only. And then we would want to create a histogram for the same pivot table. So histogram usually gives us the frequencies. So let's look at how do we calculate the profit made in each year for all the categories. So what I can do is I can basically select my row ID here, and now I'll do a pivot table. So the data is already selected. I'll choose existing worksheet. Let's select this particular cell, say OK. Now what are we interested in? Now if you look at the fields, we don't see any years or quarters and so on. So for example, here I can just choose order date, and then basically I can choose, say for example, years or quarters, the data which is coming out from my order date. So here I will just select years. Now, then I have my order date. So we are interested in the years, orders, and we are interested in, let's look at our column or the question what we had here. So we have years, find the profit made in each year. So let's select profit. So that basically says sum of profit. But then I'm also interested in for all the categories of products. So what I can do is here I have my field which is category, and that I'll add to the columns. So that shows me what are the different categories, and this looks fine. Now I'm also interested in east and west regions, so that is basically in the region. So either we could add a slicer or we could do a filtering here by adding the filters. So first is I'll click on region, and here it says select all. I'm only interested in east and west, so let's select this, take this, put it here, let's say okay, and now we have the data which has been filtered based on the region. So here we have region, so you can always look at the filter, it is east and west, and we have our year data per year. We have different categories. You can always look at what are these column labels. So this is my different categories, and this is the profit per category, and then you have your grand total. So we have already our data. Now let's say close this. So we have our data for all these years, different categories, the profits made per year. And if I would want, I could go into an year and I could look into different months. So that also is showing up. And now we would want to basically plot a histogram with this data. So I can just place my cursor here, I can select this, and then I can go into insert, and here I have different options. So we can go for bar chart, we can go for insert hierarchy chart, we can go into waterfall, funnel, stock, surface, or radar chart. So there are different options what you have here, and we will go for a simple histogram which is two-dimensional. Let's select this, and here you see you can obviously select different regions. You have your years which shows up, you have your order date, and then you have your categories which can be chosen for your histogram or for your bar chart. And that basically is how you use your pivot table. You use some calculations, and then you can plot your needed graph to visualize the data and understand it in a better way.
Welcome to Simplilearn. In this video, we are focusing on ChatGPT and its groundbreaking role in data analytics. In a world where data is the new gold, understanding and analyzing this wealth of information is crucial. But as the volume of data grows exponentially, traditional analysis methods are being pushed to their limits. Enter ChatGPT, a revolutionary AI developed by OpenAI that's transforming how we approach data analytics. But what makes ChatGPT stand out in the crowded field of data analytics tools? How can it not only streamline complex processes, but also uncover insights that were previously hidden in plain sight? Stay tuned as we unravel the capabilities of ChatGPT, share real-world applications, and show you how it's being used by analysts and businesses alike to make smarter, data-driven decisions. And whether you are a data scientist, a business professional, or just a tech enthusiast curious about the future of AI in data analytics, this video is for you. So let's dive in and discover how ChatGPT is not just revolutionizing data analytics, but also how we understand and interact with the vast universe of data. And don't forget to hit that like button, subscribe, and ring the bell to stay updated on all our future explorations into the fascinating world of technology. Now let's get started and unlock the potential of ChatGPT for data analytics together. So guys, an Excel data analyst always looks for ways to improve their efficiency and gain deeper insights from the data. That's where ChatGPT comes in handy. So ChatGPT is an AI-powered language model that can assist you in various tasks, including Excel-based data analysis. And for that data analysis, let's dive into some demos to see how it works. So guys, as you can see, this is the ChatGPT 4, and you could see this has the support of DALL-E, browsing and analysis, and usage limits may apply. Like we have the version that has some usage limits. And for the data, I have downloaded the data from the Kaggle. I will provide you the link in the description. If you want to download the same data, you can. And I have that in my downloads. So this is the data that we'll be using. So the first thing we'll be doing is data cleaning and preparation. So firstly, let's explore data cleaning and preparation. Before diving into analysis, it's essential to ensure our data is clean and ready for processing. So for that, we will write a prompt in ChatGPT and ask him to clean the data. ChatGPT has the feature to insert the files, provide the Excel file to the ChatGPT, and we'll ask him that can you help me identify and remove duplicates in this Excel spreadsheet. So let's ask him, can you help me identify and remove duplicates? Duplicates from this Excel spreadsheet, from the provided Excel spreadsheet. So you could see that ChatGPT has started generating the response, and he is telling us that he can definitely help us with that, and he is analyzing that. So you could see that ChatGPT has provided us the response. So let's first go to our spreadsheet. So this is the spreadsheet: order number, quantity ordered, price of each quantity, and order lines. So you could see that first ChatGPT has encountered an error, and that is with the character encoding mismatch. And then he has loaded the spreadsheet successfully with the second attempt, and you could see that he has provided like the smaller or the briefer version of the spreadsheet. That is, the dataset consists of sales data with columns such as order number, quantity order, price each, order line, sales, order date, status. So he's asking us, could you specify how you would like to identify duplicates? For example, should we consider a row a duplicate if all its values match another row exactly, or are there specifically columns we should focus on to determine duplicates? So we should, or here we'll be focusing on the column section. So here we want to identify column section. So is asking which columns they should identify duplicates. So we want the duplicates in order number. So the ChatGPT has started analyzing the spreadsheet. So you could see that ChatGPT has produced the response that they have identified a total of 2,807 rows in the spreadsheet that have duplicates based on the order number column. So this indicates that multiple rows share the same order number, suggesting there might be different items or transactions within the same order. So would you like to proceed by removing these duplicates while keeping either the first or last occurrence of each order number, or do you have another approach in mind for handling these duplicates? So before identifying the duplicates, what we'll do is we'll first get rid of the extra spaces. So we'll ask ChatGPT that first find the extra spaces in the spreadsheet and help us remove them. So you could see that it has started analyzing it. So he is asking us that would you like to proceed with any further cleaning or data manipulation? Yes, we want to proceed further with data cleaning only. And now we will treat all the blank cells if there are any. Now treat all the blank cells if there are any. So the spreadsheet contains blank cells in the following columns with the respective counts of blank entries. That is, address line 2 has 2521 blank cells. Then the state. So depending on your preference or the requirements of your data analysis, we can treat these blank cells in several ways, such as filling them with a placeholder value that is not provided using a specific value that makes sense for data. That is, example, a default state or territory, but potentially leaving them as if blanks carry meaningful information in the context of your data. So what we will do, we will provide a placeholder, instead, that is not provided or not applicable. Okay. So you would see that ChatGPT has responded that it has replaced the blank cells in the columns, that is address line 2, state, postal code and territory, with the placeholder not provided. So you could see there's a verification sample showing the updates. So this is how you could clean the data. And now with ChatGPT, you can quickly identify and eliminate duplicates in your Excel spreadsheet using built-in functions and formulas, saving your time and effort. So that would be done by the ChatGPT, and you can download the Excel file from the ChatGPT only. After that, you can just ask him that provide me the output or the resulted spreadsheet. So if we talk about now data analysis and visualization, let's delve into that. So Excel offers powerful tools for analyzing and visualizing data, and ChatGPT can help you make the most of them. So for this also we'll write a prompt to the ChatGPT, and we'll write, for example, please create a pivot table and a corresponding chart to analyze sales performance by region. So let's see, like this prompt, what output does ChatGPT show to us. So let's ask him, please create a pivot table and a corresponding chart to analyze sales performance by region. So you could see that ChatGPT has started analyzing the data and the spreadsheet, and you could see that the pivot table below shows the sales performance by region or the territory. So this table indicates that the EMEA region has the highest sales performance, followed by regions where the territory was not provided, then APAC, and finally Japan. So now let's create a chart to visually represent this sales performance by region. You could see that it has provided a chart, that is a bar chart illustrating the sales performance by territory. So you could see the guys that it has provided us the analysis, and ChatGPT can guide you through the process of creating pivot tables, charts and other visualizations in Excel, enabling you to gain valuable insights from your data with ease. So let's move to advanced analysis and automation. So lastly, we will explore advanced analysis and automation. So Excel capabilities extend beyond basic functions, and ChatGPT can help you leverage its full potential. And for this also, we'll write a prompt to the ChatGPT that can you assist me in building a forecasting model to predict future sales based on historical data present in the spreadsheet. So let's see what ChatGPT respond to us. So let's ask him, can you assist me in building a forecasting model to predict future sales based on historical data. So let's see what ChatGPT respond to us. So you could see that building a forecasting model to predict future sales based on historical data involves several steps. So for this, you have to prepare the data, select a model, train the model, evaluate the model and make predictions. So let's start by preparing the data. We'll aggregate sales by order date to create a time series of total daily sales. Then we'll choose a model based on data's characteristics. So we will grant the permission to ChatGPT to proceed with the steps. So he started analyzing the data. So you could see that the data has been prepared into a time series of total daily sales. And before choosing a forecasting model, it's helpful to visualize the sales time series to understand its characteristics such as trend and seasonality. So ChatGPT has plotted a daily sales data, and then he has given the visual trends and the possible seasonal patterns. And the next steps would include testing for stationarity, model selection and parameter tuning, model training, and then forecasting. So you could follow all these steps with the help of ChatGPT and could create a forecasting model. If you want, we can move to the next step. So you could provide a prompt to the ChatGPT that move to or proceed with next step. So step by step, ChatGPT will provide you a forecasting model, or it will help you create a forecasting model. As you can see, it has started analyzing it. So the augmented Dickey Fuller, that is ADF test, gives up a p-value of approximately 0.0033. Since this p-value is less than the common significance level of 0.05, we can reject the null hypothesis that the time series has a unit root, meaning the time series is stationary. So you could see that he is asking us, shall we proceed with the SARIMA model parameter selection? Yes, here is the model parameter selection. So you could select any based on the trends and the bar graphs plotted by the ChatGPT. So you could see, guys, that the ChatGPT has analyzed the spreadsheet and provided the response that the grid search for the optimal SARIMA parameters based on the lower ACALI information criterion, such as the best fit model uses the parameter 011 and for ARIMA and 01112, that is for the seasonal component. So you could see that it has provided the model and the parameters. Now it's asking us, shall we move on to forecasting future sales with this model? Yes, proceed with that. So you could see that with ChatGPT's assistance, you can build complex forecasting models in Excel, allowing you to make informed decisions and plan for the future effectively. So ChatGPT is a valuable tool for Excel users and data analysis, offering assistance in data cleaning, analysis, visualization, and automation. And by integrating ChatGPT in your Excel workflows, you can enhance your productivity and uncover new insights from your data. So you can try ChatGPT for Excel data analytics today and take your Excel skills to the new level. And you could see that there's an error in the analyzing, and he has encountered an error while trying to plot the forecast with its confidence intervals. So this type of error can occur due to data type issues, particularly when handling data indices and forecast. And despite this hiccup, the forecasting process using the SARIMA model was completed and we were able to generate forecast for the next 12 months. Unfortunately, due to the plotting issue, we couldn't visually display it. So we'll ask him, can you try once again? So you could see that this time ChatGPT has provided us the forecast for the next 12 months. That is, the forecast have been successfully plotted along with the historical daily data. So here we have our forecast model, and with the ChatGPT's assistance, we can move with other analysis also.
Today, we are going to talk about Annova in Microsoft Excel, and I will walk you through a step-by-step guide on how to perform this in Excel. But before we dive into that, let's first take a quick look at what Annova really means. Annova, which is analysis of variance in Excel, is a statistical method to compare the means of 3 or more groups to see if they are significantly different from each other. It helps determine if variations in data are due to real differences or random chance. It's useful because it helps in finding differences as it shows if groups have different results. It saves time as it tests all the groups at once. It clears insights and helps make decisions based on our data. For example, if a teacher wants to compare the effectiveness of the 3 different teaching methods on students' math scores, they can divide the class into 3 groups of 14 students each. Using Annova, the teacher can analyze the math scores to determine if one teaching method is truly better or if the differences in scores are due to chance. Now that we have a basic understanding of what Annova actually is, let's get into Excel and see how you can easily calculate this using the built-in tools. I have a sample of data in my Excel to perform the Annova over. There is an amazing feature in Excel that many people are not even aware about. It's a data analysis tool pack. If you have not come across this word, the Data Analysis Toolpack in Excel is an add-in that provides the advanced data analysis tools for statistical and engineering calculations. It simplifies the complex data analysis task by offering the built-in features to perform various statistical tests and data processing without needing to write formulas manually. So we need to ensure first if we have activated the tool pack correctly. So for that, we need to go to the file and then options, and then we have to move to add-ins, and here in the manage you have to choose for the Excel add-ins and click on go. After that, you need to click on this analysis tool pack and click on OK. Now when you see the topmost bar, that is the data, if you click on this data, you will see a data analysis button over here. Now we are all set to perform the analysis of variance. To perform this, I will click on data analysis button, and from there I will choose Annova single factor and select on OK. Now here in the input range, we need to enter the range of the cells containing your data. For that, I will click on this upper arrow button and highlight my cells that are containing the data. The next option is grouped by, depicts how your data is arranged in your sheet. If it is arranged in a column like I have arranged, choose columns, and if it is arranged in a row, go for the rows. Now here in the labels in the first row, if you have labels like mine, like group A, group B and group C, do tick this button. Then alpha is generated, and here in the output options, this is where you want your result to be returned. The first option is the output range, is where you can specify a particular cell where you want your result to be returned. The second option will enter the answer in a new worksheet, and the third option will enter the result in a particularly new Excel file. I will choose the second option and will name it as Annova. Now we have got this result. Within just one click, you can definitely get the Annova single factor results. Now I will explain each factor, what it means, count, sum, average, variance, SS, DF, MS, etc. in the next PPT. So the first table depicts a summary of the data available in the analysis. So the first one we have got is count. Count is the total number of data points in each group. Here, in group A, group B and group C, we have 14 data points. Now moving on, we have sum. Sum is the total value if we add up all the values in each group. So the sum of group A is 958, sum of group B is 1093 and sum of group C is 1280. Now moving on, we have average. Average is the sum divided by the total number of data points in each group. So the average of group A is 68.42, the average of group B is 78.07 and the average of group C is 91.42. Now, lastly we have variance. Variance is the average of the square differences from the mean. Now, the variance of group A is 141.34, the variance of group B is 209.60 and the variance of group C is 119.49. Now the second table here is divided into three groups, the between groups, within groups and total. So the first row depicts the result when the between rows are classed as a source of variation. The second row depicts when the source of variation is within the groups. And finally the last row is just the total. Now we will see what each column represents. So the first one we have is SS. SS stands for sum of squares. Between group SS is the total variation explained by the differences between the groups. Within group SS is actually the total variation within the groups due to the random error or individual variability. And the total SS is the sum of the between group SS and within group SS. So the between group SS over here is 3735.19, within group SS is 6115.78 and the total SS is 9850.97. Now moving on, we have DF. DF stands for degrees of freedom. This is calculated slightly differently. For between groups, DF is the number of groups present in your data minus 1. I have 3 groups, so 3 minus 1, I have got 2. To determine this, Within groups, DF is the number of observations minus the number of groups, that is 42 minus 3, that is equal to 39. Then we have MS. MS stands for mean square. You can think it as the variance for each source of variation. To calculate this, we can simply divide the sum of squares by the degrees of freedom. Now moving on, we have F. F stands for F statistic. Here the F statistic is calculated as MS between the groups divided by the MS within the groups, and it is equal to 11.90954. Now moving on, we have the F critic. F critic stands for F critical value. It is calculated easily by Excel, or you can perform it manually by looking at the critical value table. So the F statistics is then compared with the F critical value. If the F statistical value is greater than the F critical value, we can conclude that the test is significant. Now moving on, we have the p-value, the probability of obtaining an F statistic as extreme as or more than the observed value, assuming the null hypothesis is true. A small p-value that is less than 0.05 suggests that the significant differences between groups exist. As my p-value is more than the alpha level, that is the 0.05, we fail to reject the null hypothesis. Therefore, there is no difference between the means of the three groups.
Hello and welcome to this session on time series forecasting. In this video, we are going to talk about what time series forecasting is. So this is what we are going to cover in this video. First of all, why time series? And then we'll talk about what exactly is time series data. And then what are the components of a time series data, like for example, the trend, seasonality, and so on. And then we will explain what each of these components are. We'll also talk about when we should not use time series analysis. And we will then explain what is stationary data in terms of time series, what is the significance of stationary data, and typically time series data is not stationary, so how to make time series data stationary. And then we will take you through an example of a car sales data, and we will show you how to solve the time series or how to perform the time series analysis manually without using a tool. And then we will do in the second part, we will actually use R, and we will do the same thing once again in R. Okay, so without any further delay, let's get started. And so why exactly do we need to do time series analysis? Typically, we would like to predict something in the future. And it could be stock prices, it could be the sales, or anything that needs to be predicted into the future. That is when we use time series analysis. So it is, as the name suggests, it is forecasting. And typically when we say predict, it need not be into the future. In machine learning and data analysis, when we talk about predicting, we are not necessarily talking about the future. But in time series analysis, we typically predict the future. So we have some past data and we want to predict the future. That is when we perform time series analysis. So what are some of the examples? It could be daily stock price, the shares as we talk about, or it could be the interest rates, weekly interest rates, or sales figures of a company. So these are some of the examples where we use time series data. We have historical data, which is dependent on time. And then based on that, we create a model to predict the future. So what exactly is time series? So time series data has time as one of the components, as the name suggests. So in this example, let's say this is the stock price data and one of the components. So there are two columns here. Column B is price and column A is basically the time information. In this case, the time is a day. So that primarily the closing price of a particular stock has been recorded on a daily basis. So this is the time series data and the time interval is obviously a day. Time series or time intervals can be daily, weekly, hourly, or even sometimes there is something like a sensor data. It could be every few milliseconds or microseconds as well. So the size of the time intervals can vary, but they are fixed. So if I'm saying that it is daily data, then the interval is fixed as daily. If I'm saying this data is an hourly data, then it is the data is captured every hour and so on. So the time intervals are fixed. The interval itself you can decide based on what kind of data we are capturing. So this is a graphical representation. The previous one here we saw the tabular representation, and this is how to plot the data. So on the y-axis is, let's say, the price or the stock price, and x-axis is the time. So against time, if you plot it, this is how a time series graph would look. So as the name suggests, what is time series data? Time series data is basically a sequence of data that is recorded over a specific intervals of time and based on the past values. So if we want to do an analysis of time series past data, we try to forecast a future, and again, as the name suggests, it is time series data, which means that it is time dependent. So time is one of the components of this data. Time series data consists of primarily 4 components. One is the trend, then we have the seasonality, then cyclicity, and then last but not least, irregularity or the random component. Sometimes it is also referred to as the random component. So let's see what each of these components are. So what is trend? Trend is overall change or the pattern of the data, which means that the data may be, let me just pull up a pen and show you. So let's say you have a data set somewhat like this, a time series data set somewhat like this. All right. So what is the overall trend? There is an overall trend which is upward trend, as we call it here, right? So it is not like it is continuously increasing. There are times when it is dipping, then there are times when it is increasing, then it is decreasing and so on. But overall, over a period of time, from the time we start recording to the time we end, there is a trend, right? There is an upward trend in this case. So the trend need not always be upwards. There could be a downward trend as well. So for example, here there is a downward trend, right? So this is basically what is a trend. Overall, whether the data is increasing or decreasing. All right, then we have the next component, which is seasonality. What is seasonality? Seasonality, as the name suggests once again, changes over a period of time and periodic changes, right? So there is a certain pattern. Let's take the sales of warm clothes, for example. So if we plot it along the months, so let's say January, February, March, April, May, June, July, and then let's say it goes up to December. Okay, so this is our December, a D. I will just mark it as D. And then you again have Jan, Feb, March, and then you get another December. Okay, and just for simplicity, let's mark these as Decembers as the end of the year, and then one more December. Okay, so what will happen when, if you're talking about warm clothes, what happens? The sales of warm clothes will increase probably around December when it is cold, and then they will come down. And then again around December, again they will increase, and then the sales will come down. And then there will be again an increase, and then they will come down. And then again an increase, and then they will come down. Let's say this is the sales pattern. So you see here there is a trend as well. There is an upward trend, right? The sales are increasing over, let's say these are multiple years. This is for year 1, this is for year 2, this is for year 3, and so on. So for multiple years, overall the trend, there is an upward trend. The sales are increasing, but it is not a continuous increase, right? So there is a certain pattern. So what is happening? What is the pattern? Every December, the sales are increasing or they are peaking for that particular year, right? Then there is a new year. Again, when December approaches, the sales are increasing. Again, when December approaches, the sales are increasing, and so on and so forth. So this is known as seasonality. So there is a certain fluctuation which is periodic in nature. So this is known as seasonality. Then cyclicity. What is cyclicity? Now, cyclicity is somewhat similar to seasonality, but here the duration between two cycles is much longer. So seasonality typically is referred to as an annual kind of a sequence. Like for example, we saw here. So it is pretty much like every year in the month of December, the sales are increasing. However, cyclicity, what happens is, first of all, the duration is pretty much not fixed, and the duration or the gap length of time between two cycles can be much longer. So recession is an example. So we had, let's say, recession in 2001 or 2002 perhaps, and then we had one in 2008, and then we had probably in 2012, and so on and so forth. So it is not like every year this happens probably. So there is usually when we say recession, there is a slump, and then it recovers, and then there is a slump, and then it recovers, and probably there is another bigger slump, and so on, right? So you see here, this is similar to seasonality, but first of all, this length is much more than a year, right? That is number one. And it is not fixed as well. It is not like every 4 years or every 6 years. That duration is not fixed. So the duration can vary. At the same time, the gap between two cycles is much longer compared to seasonality. All right. So then what is irregularity? Irregularity is like the random component of the time series data. So there is like you have part which is the trend, which tells whether the overall it is increasing or decreasing. Then you have cyclicity and seasonality, which is like kind of a specific pattern, right? Then there is a cyclicity, which is again a pattern, but at much longer intervals. Plus there is a random component, so which cannot be accounted for very easily, right? So there will be a random component which can be really random, as the name suggests, right? So that is the irregularity component. So these are the various components of time series data. Yes, there are conditions where we cannot use time series analysis, right? So can we do time series analysis with any kind of data? No, not really. So what are the situations where we cannot do time series analysis? So there will be some data which is collected over a period of time, but it's really not changing. So it will not make sense to perform any time series analysis over it, right? For example, like this one. So if we take X as the time and Y as the value of whatever the output we are talking about, and if the Y value is constant, there is really no analysis that you can do. Leave alone time series analysis, right? So that is one. Another possibility is, yes, there is a change, but it is changing as per a very fixed function, like a sine wave or a cos wave. Again, time series analysis will not make sense in this kind of a situation, because there is a definite pattern here, there is a definite function that the data is following. So it will not make sense to do a time series analysis. Now, before performing any time series analysis, the data has to be stationary. And typically, time series data is not stationary. So in which case, you need to make the data stationary before we apply any models like Arriva model or any of these, right? So what exactly is stationary data? And what is meant by stationary data? Let us take a look. First of all, what is non-stationary data? Time series data. If you recall from one of my earlier slides, we said that time series data has the following four components: the trend, seasonality, cyclicity, and random component or irregularity, right? So if these components are present in time series data, it is non-stationary, which means that typically these components will be present. Therefore, most of the time, a time series data that is collected raw data is non-stationary data. So it has to be changed to stationary data before we apply any of these algorithms. All right, so a non-stationary time series data would look like this, which means, like, for example, here there is an upward trend, the seasonality component is there, and also the random component and so on. So if the data is not stationary, then the time series forecasting will be affected. So you cannot really perform a time series forecasting on a non-stationary data. So how do we differentiate between a stationary and a non-stationary time series data? Typically or technically, one is, of course, you can do it visually. In non-stationary data, the data will be more flattish. The seasonality will, of course, be there, but the trend will not be there. So the data may, if we plot that, it may appear somewhat like this, right? It's a horizontal line. Along the horizontal line, you will see. Compared to the original data, there was an upward trend, so it was changing somewhat like this, right? So this is non-stationary data, and this is how a stationary data would look visually. What does this mean? Technically, this means that the stationarity of the data depends on a few things: the mean, the variance, and the covariance. So these are the three components on which the stationarity of the data depends. So let's take a look at what each of these are. For stationary data, the mean should not be a function of time, which means that the mean should pretty much remain constant over a period of time, right? So there shouldn't be any change. So this is how the stationary data would look. And this is how a non-stationary data would look. I've shown in the previous slide as well. So here the mean is increasing. That means there is an upward trend. Okay, so that is one part of it. And then the variance of the series should not be also a function of time. So the variance also should be pretty much common, or should be constant rather. So this is if we visually take a look, this is how time series stationary data would look, where the variance is not changing. Here the variance is changing, therefore this is non-stationary, and we cannot apply time series forecasting on this kind of data. Similarly, the covariance, which is basically of the ith term and the I plus mth term, should not be a function of time as well. So covariance is nothing but not only the variance at the ith term, but the relation between the variance at the ith term and the I plus mth or the I plus nth term. So once again, visually this is how it would look if the covariance is also changing with respect to time. So these are all three components should be pretty much constant, and that is when you have stationary data, and in order to perform time series analysis, the data should be stationary. Okay, so let's take a look at the concept of moving average, or the method of moving average, and let's see how it works. We'll do simple calculations. So let's say this is our sample data. We have the data for 3 months, January, February, March. The sales in thousands rather, not hundreds, thousands of dollars is given here, and now we want to find the moving average. So how do we find the moving average? We call it as moving average 3. So moving average 3 is nothing but you take 3 of the values or the readings, add them up and divide by 3. Basically the way we take a mean or average of the 3 values. So that is as simple as that. So that's the average first of all. So what is moving average? Moving average is if you now have a series of data, you keep taking the 3 values, the next 3 values, and then you take the average of that, and then the next 3 values, and so on and so forth. So that is how you take the moving average. So let's take a little more detailed example of car sales. So this is how we have the car sales data for the entire year, let's say. So rather for 4 years. So year 1 we have for each quarter 1, 2, 3, 4, and then year 2, quarter 1, 2, 3, 4, and so on and so forth. So this is how we have sales data of a particular car, let's say, or a showroom. And we want to forecast for year 5. So we have the data for 4 years. We now want to forecast for the 5th year. Let's see how it works. First of all, if we plot the data as it is taken, the raw data, this is how it would look. And what do you think? Is it stationary? No, right? Because there is a trend, upward trend. So this is not a stationary data. So we need to, later we will see how to make it stationary. But to start with, just an example. We will not worry about it for now. We will just go ahead and manually do the forecasting using what is known as moving average method. Okay, so we are not applying any algorithm or anything like that. In the next video, we will see how to apply an algorithm, how to make it stationary, and so on. All right, so here we see that all the 3 or 4 components that we talked about are there. There is a trend, there is a seasonality, and then of course there is some random component as well. Cyclicity may not be, it is possible that cyclicity is not applicable in all the situations. For sales especially, there may not be, or unless you're taking a sales for maybe 20-30 years, cyclicity may not come into play. So we will just consider primarily the trend, seasonality, and irregularity, right? So random, it is also known as random irregularity, right? So we were calling the random or irregularity component. So these are the 3 main components typically in this case we will talk about. So this is the trend component, and we will see how to do these calculations. So let's take a look, redraw the table including the time code. We will add another column which is the time code, and this is the column. And we'll just number it like 1, 2, 3, 4 up to 16. The rest of the data remains the same. Okay, so we will do the calculations now. Now let us do the moving average calculations or MA4 as we call it, for each year. So we take all the 4 quarters and we take an average of that. So if we add up these 4 values and divide by 4, you get the moving average of 3.4. So we start by putting the value here. So that will be for the third quarter, let's say 1, 2, 3, the third quarter. Then we will go on to the next one. So we take the next 4 values as you see here and take the average of that, which is the moving average for the next quarter, and so on and so forth. Now, if we just do the moving average, it is not centered. So what we do is we basically add one more column and we calculate the centered moving average as shown here. So here what we do is we take the average of 2 values and then just adding these values here. So for example, the first value for the third quarter is actually the average of the third and the fourth quarter. So we have 3.5. Now it gets centered. So similarly, the next value would be 3.6 plus 3.9 divided by 2, so which is 3.7, and so on and so forth. Okay, so that is the centered moving average. This is done primarily to smoothen the data so that there are not too many rough edges. So that is what we do here. So if we visualize this data now, this is how it looks. Right, so if we take the centered moving average, as you can see, there is a gradual increase. If this was not the case, if we had not centered it, the changes would have been much sharper. So that is basically the smoothing that we are talking about. Now let's go and do the forecast for the 5th year. So in order to do the forecast, what we will do is we will take the centered moving average as our baseline and then start doing a few more calculations that are required in order to come up with the prediction. So what we are going to do is we are going to use this multiplicity or multiplicative model in this case, and this is how it looks. So we take the product of seasonality and the trend and the irregularity components, and we just multiply that. And in order to get that, this product of these two, we have basically the actual value divided by CMA. YT value divided by CMA will give you the predicted value, or YT is equal to the product of all 3 components. Therefore, ST into YT is equal to YT by CMA. So this is equal to YT, right? So therefore, if we want ST into YT, the product of seasonality and irregularity, it is equal to YT by CMA. So that is how we will work it out. I also have an Excel sheet of the actual data. So let me just pull that up. Alright, so this is how the data looks in Excel. As you can see here, year 1, quarter 1, 2, 3, 4, year 2, quarter 1, 2, 3, 4, and so on. And this is the sales data. And then this is the moving average. As I mentioned, this is how we calculate. And this is the centered moving average. So this is the primary component that we will start working with. And then we will calculate, since we want the product of ST into YT, that is equal to YT by CMA. So if you see, these values are nothing but the YT value divided by CMA. So in this case, it is 4 by 3.5, which is 1.14. Similarly, 4.5 by 3.7, 1.22, and so on and so forth. So we have the product ST into YT, and then the next step is to calculate the average of respective quarters. So that is what we are doing here, average of respective quarters, and then we need to calculate the deseasonalized values. So in order to get deseasonalized value, we need to divide YT by ST that was calculated. So for example, here it is 2.8 by 0.9. So we got the deseasonalized value here, and then we get the trend, and then we get the predicted values. So in order to get the predicted value, which is basically we predict the values for known values as well. Like for example, year 1, quarter 1, we know the value, but now that we have our model, we predict ourselves and see how close it is. So we predicted as 2.89, whereas the actual value is 2.8. Then we have 2.59, the actual value is 2.1, and so on, just to see how our model works, and then continue that into the 5th year, because for 5th year we don't have a reference value. Okay, and if we plot this, we will come to know how well our calculations are, how well our manual model. In this case, we did not really use a model, but we did on our own manually. So it will tell us the trend. So for example, the predicted value is this gray color here, and you can see that it is actually pretty much following the actual value, which is the blue color. Right, and the gray color is the predicted value. So wherever we know the values up to year 4, we can see that our predicted values are following or pretty much very close to the actual values. And then from here onwards, when the year 5 starts, the blue color line is not there because we don't have the actual values, only the predicted value. So we can see that since it was following the trend pretty much for the last 4 years, we can safely assume that it has understood the pattern and it is predicting correctly for the next 1 year, the next 4 quarters, right? So that is what we are doing here. So these 4 quarters, we did not have actual data, but we have the predicted values. So let's go back and see how this is working in this using the slides. So this is, we already saw this part, and I think it was easier to see in the Excel sheet. So we calculated the ST, IT, the product of ST and IT using the formula like here, Y by YT by CMA, we got that, and then we got ST, which is basically YT. So this is average of the first quarters for all the 4 years. And similarly, this is the average of the second quarter for all the 4 years, and so on. So these values are repeating. They are calculated only once, they get repeated, as you can see here. And then we get the deseasonalized data, and that is basically YT by ST. So we calculated ST here and we have YT. So YT by ST will give you the deseasonalized data. And we have got rid of the seasonal and the irregular components so far. Now what we are left with is the trend. And before we start the time series forecasting or time series analysis, as I mentioned earlier, we need to completely get rid of the non-stationary components. So we are still left with the trend component. So now let us also remove the trend component. In order to do that, we have to find we have to calculate the intercept and slope of the data, because that is required to calculate the trend. And how are we going to do that? We will actually use what is known as a regression tool or analytics tool that is available in Excel. So you remember we have our data in Excel. So let me take you to the Excel, and here we need to calculate the intercept and the slope. In order to do that, we have to use the regression mechanism, and in order to use the regression mechanism, we have to use the analytics tool that comes with Excel. So how do you activate this tool? So this is how you would need to activate the tool. From Excel, you need to go to options, and in options there will be add-ins, and in add-ins you will have analysis toolpack, and you select this and you just say go. It will open up a box like this. You say analysis toolpack and you say okay. And now when you come back into the regular view of Excel, in the data tab, you will see data analysis activated. So you need to go to file, options, and add-ins, and then analysis toolpack. Typically, since I've already added it, it is coming at the top, but it would come under inactive application add-ins. So when you're doing it for the first time. So don't use VBA, you just say analysis toolpack. There are two options, one with VBA like this one and one without VBA. So just use the one without VBA. And then instead of just saying okay, just take care that you click on this go and not just okay. So you say go, then it will give you these options. Only then you select just the analysis toolpack and then you say okay. Alright, so and then when you come back to the main view, you click on data. Okay, so this is your normal home view perhaps. So you need to come to data, and here is where you will see data analysis available to you. And then if you click on that, there are a bunch of possibilities. What kind of data analysis you want to do? If there are options are given. Right now we just want to do regression because we want to find the slope and the intercept. So select regression and you say OK. And you will get these options for input Y range and input X range. Input Y range is the value YT. So you just select this and you can select up to here and press enter. And input X range, you can, for now, you start with the baseline, or you can also start with the deseasoned values. So you can just click on these and say OK. I have already calculated it. So these are the intercept and the coefficients that we are getting for these values. And we will actually use that to calculate our trend here, right? So which is in the J column. So our trend is equal to intercept plus slope into the time code. So the intercept is out here, as we can see in our slide as well. So if you see here, this is our intercept, and the lower value is the slope. So we have calculated here and it's shown in the slides as well. So intercept, so the formula is shown here. So our trend is equal to intercept plus slope into time code. Time code is nothing but this one, T, column A, 1, 2, 3, 4. Okay. So that's how you calculate the trend, and that's how you use the data analysis tool from Excel. Using these two, we calculate the predicted values. And using this formula, which is basically trend is equal to intercept plus slope into time code. And then we can go and plot it, see how it is looking. And therefore, so we see here that the predicted values are pretty close to the actual values. And therefore, we can safely assume that our calculations, which are like our manual model, is working. And hence, we go ahead and predict for the 5th year. So till 4 years, we know the actual value as well. So we can compare how our model is performing. And for the 5th year, we don't have reference values. So we can use our equations to calculate the values or predict the values for the 5th year. And we can go ahead and safely calculate those values. And when we plot for the 5th year as well, the predicted values, we see that they are pretty much, they captured the pattern, and we can safely assume that the predictions are fairly accurate, as we can also see from the graph in the Excel sheet that we have already seen. Okay, so let's go and plot it. So this is how the plot looks. This is the CMA, or the centered moving average, the green color, and then the blue color is the actual data, red color is the predicted value, predicted by our handcrafted model. Okay, so remember, we did not use any regular forecasting model or any tool. We have done this manually, and the actual tool will be used in the next video. This is just to give you an idea about how behind the scenes or under the hood, how forecasting works, or time series analysis, how it is performed. Okay, so it looks like it has captured the trend properly. So up to here is the known reference, we have reference, and from here onwards is purely predicted. And as I mentioned earlier, we can safely assume that the values are accurate and predicted properly for the 5th year. So let's go ahead and implement a time series forecast in R. First of all, we will be using the ARIMA model to do the forecast of this time series data. So let us try to understand what is ARIMA model. So ARIMA is actually an acronym. It stands for Autoregressive Integrated Moving Average. So that is what is ARIMA model. And it is specified by 3 parameters, which is P, D, and Q. P stands for autoregressive. So let me just mark this. So there are 3 components here: autoregressive, integrated, moving average. Okay. So these 3 parameters correspond to those 3 components. So the P stands for autoregressive, D for integrated, and Q for moving average. So let us see what exactly this is. So these 3 factors are: P is the number of autoregressive terms, or AR. We will see that in a little bit. And D is how many levels of differences that we need to do, or differentiation we need to do. And Q is the number of lagged forecast errors. So we'll see what exactly each of these are. So AR is the number of autoregressive terms, and which is basically denoted by the P. And then we have D, which is for the number of times it has to be differentiated. And then we have Q, which is for the moving average. So what exactly AR terms. So in terms of the regression model, autoregressive components refer to the prior values of the current value. Well, what we mean by that is, here when we talk about time series data, focus on the fact that there is regression. So what exactly happens in regression? We try to do something like, if it is simple linear regression, we do some equation like y is equal to mx plus c, where there are two variables. One is the dependent variable, and then there is an independent variable. Let me just complete this equation as well, mx plus c. Right? So this is a normal regression curve, or a simple regression curve. Now here we are talking about autoregression or autoregressive. So autoregressive, as the name suggests, is regression of itself. So which means that here you have only one variable, which is your maybe the cost of the flights or whatever it is, right? And the other variable is basically time dependent, and therefore the value at any given time, and that we will denote as yt, for example. So there is no x here, there is only one variable, and which is y, and we say yt, which is basically the predicted value at a time interval t, for example, is dependent on the previous value. So for example, there may be a1 and then yt minus 1, and then there will be like plus a2 and plus a2 and yt minus 2 and all right, and then plus a3 into yt minus 3. Correct. So basically here what we are saying is there's only one variable here, but there is a regression component. So we are doing a regression on itself. So that's how the term autoregression comes into play. So only thing is that it is dependent on the previous time values. So there is a lag, let's say this is the first lag, second lag, third lag, and so on. So the current value, which is yt, is dependent on the previous time lag values. So that is what is autoregression component. So this is what is shown here. For example, in this case, instead of y, we are calling it as x. So that's the same. And this is represented by some equation of that sort, depending on how many lags we take. So that is the AR component. And the term P is basically determines how many lags we are considering. So that's the term P for. Now, what is D? D is the degree of differencing. So here differencing is like for the non-seasonal differences, right? So for example, if you take the values like this, which are given for 5, 4, 6, and so on and so forth, if you take the differencing of one after another, like for example 5 minus 4 or 4 minus 5, the next value with the previous value, so 4 minus 5. So this is known as the first order differencing. So the result is minus 1. Similarly, 6 minus 4 is 2, 7 minus 6 is 1. So this is first order differencing, and here we call it as D is equal to 1. Okay, and same way we can have second order, third order, and so on. Then the last one is Q. Q is the actually we call it moving average, but in reality it is actually the error of the model. So we also sometimes represent as ET. Alright, so now ARIMA model works on the assumption that the data is stationary, which means that the trend and seasonality of the data has been removed. That is correct. Okay, so this we have discussed in the first part, what exactly is stationary data and how do we remove the non-stationary part of it. Now, in order to test whether the data is stationary or not, there are two important components that are considered. One is the autocorrelation function and the other is the partial autocorrelation function. So this is referred to as ACF and PACF. Right? So what is autocorrelation and what is the definition? Autocorrelation is basically the similarity between values of a same variable across observations, as the name suggests. Now, how do we actually find the autocorrelation function, the value, right? So this is basically done by plotting, and autocorrelation function also tells you how correlated points are with each other based on how many time steps they are separated by and so on. That is basically the time lag that we were talking about. And it is also used to determine how past and future data points are related. And the value of the autocorrelation function can vary from -1 to 1. So if we plot, this is how it would look. Autocorrelation function would look somewhat like this. And there is actually a readily available function in R. So we will see that and you can use that to plot your autocorrelation function. Okay, so that is ACF, and we will see that in our RStudio in a little bit. And similarly, you have partial autocorrelation function. So partial autocorrelation function is the degree of association between two variables while adjusting the effect of one or more additional variables. So this again can be measured and it can also be plotted, and its value once again can go from -1 to 1, and it gives the partial correlation of time series with its own lagged values. So lag again we have discussed in the previous couple of slides. This is how a PSEF plot would look in RStudio. We will see that as well and once we get into the RStudio. And with that, let's get into RStudio and take a look at our use case. Before we go into the code, let's just quickly understand what exactly is the objective of this use case. So we are going to predict some values or forecast some values, and we have the data of the airline ticket sales of the previous years, and now we will try to find or predict or forecast the values for the future years. All right. So we will basically identify the time series components like trend, seasonality, and random behavior. We will actually visualize this in RStudio, and then we will actually forecast the values based on the past values or history data, historical data. So these are the steps that we follow. We will see in RStudio in a little bit. Just quickly, let's go through what are the steps. We load the data, and it is a time series data. If we try to find out what class it belongs to, the data is actually air passengers data that is already comes preloaded with RStudio. So we will be using that, and we can take a look at the data, and then what is the starting point, what is the end point. So these are all functions that are readily available we'll be using, and then what is the frequency. It's basically frequency is 12, which is like yearly data, right? So every month the data has been collected. So for each year it is 12. And then we can check for any missing values if there are any. And then we can take a look at summary of the data. This is what we do in exploratory data analysis. And then we can plot the data, visualize the data, how it is looking, and we will see how the data has some trend, seasonality, and so on and so forth. All right, then we can take a look at the cycle of the data using the cycle function, and we can see that it is every month. That's the cycle. End of every 12 months a new cycle begins. So each month of the year is the data is available. Then we can do box plots to see for each month how the data is varying over the various 10 or 12 years that we will be looking at this data. And from exploratory data analysis, we can identify that there is a trend, there is a seasonality component, and how the seasonality component varies also we can see from the box plots. And we can decompose the data. We can use the decompose function rather to see the various components like the seasonality, trend, and the irregularity part. Okay, so we will see all of this in RStudio. This is how they will look. This is the once you decompose, and this is how you will you can visualize the data. This is the actual data, and this is the trend. As you can see, it's going upwards. This is the seasonal component, and this is your random or irregularity, right? So we call it irregularity, or we can also call it random, as you can see here. Yes, so the data must have a constant variance and mean, which means that it is stationary before we start any analysis, time series analysis. And so basically, if it is stationary, only then it is easy to model the data, perform time series analysis. So we can then go ahead and fit the model. As we discussed earlier, we'll be using ARIMA model. There are some techniques to find out what should be the parameters. So we will see that when we go into RStudio. So the auto ARIMA function basically tells us what should be the parameters, right? So these parameters are the P, D, and Q that we talked about. That's what is being shown here. So if we use auto ARIMA, it will basically take all possible values of this P, D, Q, these parameters, and it will find out what is the best value, and then it will recommend. So that is the advantage of using auto ARIMA. All right. So like in this case, it will tell us if we use this parameter trace, we set the parameter trace is equal to true, then it will basically tell us what is the value of this AIC, which has to be minimum. So the lower the value, the better. So for each of these combinations of P, D, and Q, it will give us the values here, and then it will recommend to us which is the best model. Okay. Because whichever has the lowest value of this AIC, it will recommend that as our best PDQ values. So once we have that, we can see that we can potentially get a model or the equation. Model is nothing but the equation, and based on the parameters that we get. And we can do some diagnostics. We can do some plotting to see whether there is a plot for the residuals, so which shows the stationarity. And then we can also take a look at the ACF and PACF. We can plot the ACF and PACF, and then we can do some forecasting for the future years. So in this case, we have up to 1960, and then we can see how we can forecast for the next 10 years, which is 1970, up to 1970. And once we have done this, can we validate this model? Yes, definitely we can validate this model. And to validate the findings, we use junk box test, and this is how you just call box.test, and then you pass these parameters, and you will get the values that will be returned, which will tell us whether how accurate this model is, how accurate the predictions are. So the values of P are quite insignificant in this case. We will see that, and that also indicates that our model is free of autocorrelation, and that will basically be it. So let's go back and into our RStudio and go through these steps in real time. So we have to import this library. Forecast package is not installed. You have to go here and install the forecast package. Okay, so that's the easy way to install rather than, so click on this install. I will not do it now because I've already installed. So the first time, that's only one time. Then after that, you just have to load it into memory and then keep going. So we will load this data called air passengers. So by calling this data method, and if you see the data air passengers is loaded here, and if we check for the class, it is a time series data, TS data. So we can check for the dates. We can also view the data in a little bit, and the start date is 1949 and January, and our end date is 1960 December, and the frequency is 12, which is like collected monthly. So that is the frequency, which is 12 here. And then we check if there are any missing values. There are no missing values. And then we take a look at the summary of the data. This is all exploratory data analysis. And then if you just display the data, this is how it looks. And then we need to decompose this data. So we will kind of store this in an object TS data, and then use that to decompose and store the new values. Let me just clear this for now. And if we decompose, basically, as we have seen in the slides, decomposing is breaking it into the trend, seasonality, and irregular or random components. Then you can go ahead and plot it. So when you plot it, you can see here, let me zoom this. This is our original plot, or observed value as it is known as. Then we have decomposed the three parts, which is basically the trend. As you can see, there is a upward trend. Then the seasonal component. So this is some regularly occurring pattern. And then there is a random value, which is basically you cannot really give any equation or function or anything like that. So that's what this plotting has done. And then you can actually plot them individually as well. So these are the individual plots for the trend, for the seasonal component, and the random component. All right. So now let's take a look at the original data and see how the trend is in a way. So if we do this linear regression line, it will show that it is going upwards. And we can also take a look at the cycle that are there, which is nothing but we have a frequency of 12, right? So the cycles will display that it is January, February to December, and then back to January, February, and so on and so forth. And if we do box plots for the monthly data, you will see that for each of the months, right? And over the 10 years that the data that we have, we will see that there is a certain pattern, right? This is also in a way to find the seasonality component. So while January, February sales are relatively low, around July, August, the sales pick up. So especially in July, I think the sales are the highest. And this seems to be happening pretty much every year, right? So this is every year in July, there seems to be a peak in the sales, and then it goes down and slightly higher in December and so on. So that is again part of our exploratory data analysis. And once again, let's just plot the data. Now, as I said, in order to fit into an ARIMA model, we need the values of P, D, and Q. Now, one way of doing it is, there are multiple ways actually of doing it. The earlier earlier method of doing it was you draw the autocorrelation function plot and then partial autocorrelation function plot and then observe that and where does this change and then identify what should be the values of P and Q and so on. Now, R really has a very beautiful method which we can use to avoid all that manual process that we used to do earlier. So what R will do is there is a method called auto arima, and if we just call this auto arima method, and it will basically go and test the ARIMA model for all possible values of this parameters PDQ, and then it will suggest to you what should be the best model, and it will return that best model with the right values of PD and Q. So we as data scientists don't have to do any manual, trial and error kind of stuff. Okay, so we got the model now, and this is the model. It has PDQ values are 211 PDQ, and this is the seasonal part of it, so we can ignore it for now. And so if we want to actually understand how this has returned these values 211 as the best one, there is another functionality or feature where we can use this trace function or trace parameter. So if you pass to auto arima the trace parameter, what it will do is it will show you how it is doing this calculation. What is the value of the AIC? Basically, AIC is what defines the accuracy of the model. The lower, the better. Okay. So for each combination of PDQ, it will show us the value of AIC. So let's run it instead of me talking so much. Let's run this. If we run auto arima with trace, you see here there is a red mark here. That means it is performing, it's executing this, and here we see the display, right? So it starts with certain values of PDQ, and then it finds that value is too high. So it starts with again with some 0, 1, 1, 0, and so on and so forth. And ultimately it tells us, okay, this is our best model. You see here, so it says this is our best model 211. Let's go back and see, did we get the same one? Yes, we got the same one when we ran without trace as well, right? Now, why is 211? Let us see where is 211. Here is our 211, and if you compare the values, you see that 1017 is pretty much the lowest value, and therefore it is saying this is our best model. All other values are higher. So that's how you kind of get your model. And now that you have your model, what you have to do, you need to predict the values, right? So before that, let us just do some test of these values. So for that, you install T-Series. Again, if you are doing it for the first time, you would rather use this package and install and say T-Series and install it. And then you just use this library function to load it into your memory. All right, so now that we got our model using auto arima, let us go ahead and forecast and also test the model and also plot the ACF and PSCF. Remember, we talked about this, but we did not really use it. We don't have to use that, but at least we will visualize it. And for some of the stuff, we may need this T-Series library. So if you are doing this for the first time, you may have to install it. And my recommendation is don't use it in the code. You go here and install T-Series. And I will not do it now because I have already installed it, but this is a preferred method. And once you install it, you just load it using this libraries function, and then you can plot your residuals, and this is how the residuals look, and you can plot your ACF and PSCF. Okay, so this is how your PSCF looks, and this is how your ACF looks. For now, there is really nothing else we need to do with ACF and PSCF. This is just to visualize how it looks. But as I mentioned earlier, we were actually using these visualizations or these graphs to identify the values of P, D, and Q. And how that was done, it's out of scope of this video, so we will leave it at that. And then we will forecast for the next 10 years. How do we forecast that? So we call forecast, and we pass the model, and we pass what is the level of accuracy that you need, which is 95%, and for how many periods, right? So basically we want for 10 years, which is like 10 into 12 time periods. So that's what we are doing here. And now we can plot the forecast value. So you see this is the original value up to I think 62 or whatever, and then it goes up to 72. This blue color is the predicted value. Let's go and zoom it up so that we can see it better. So from here onwards, we are forecasting, and you can see that it looks like our model has kind of learned the pattern, and this pattern looks very similar to what we see in the actual data. Now, how do we test our model? So we can do what is known as a box test, and we pass our model here, residuals basically, with different lags, and from those values here, the p values here, we find that they are reasonably low, the p values, which means our model is fairly accurate.
Hey there, have you ever looked at a pile of data and thought, how do I make a sense of this? Well, that's where Power BI comes in. Imagine turning boring spreadsheets into stunning interactive dashboards with just a few clicks. That sounds exciting, right? And in this video, we are diving into Power BI from the basics to transforming data, creating charts, visualizations, and even building a real dashboard in our demo. So whether you're a beginner or looking to sharpen your skills, this is the perfect place to start. So let's get started.
Welcome back everyone to Simplilearn. Today, we are diving into the exciting world of data visualization with Power BI, where we will explore how you can transform raw data into powerful insights and visual stories. Whether you are a business professional, a student, or an IT beginner, this session is designed just for you. We will go through the introduction of BI, see how to install Power BI, then we'll see the data transformation. We will deep dive into visualizations principles and creating charts and graphs. After creating charts and graphs, we will go ahead and create an interactive report in Power BI. Before diving into Power BI, let's first talk about business intelligence or BI. BI refers to tools and processes that helps organization to collect, analyze, and use data to make smarter decisions. Think of it as your compass in a sea of information. It points you to trends, predicts outcomes, and helps improve general performance. Let's see how Power BI helps us with its feature to analyze and make informed decisions. Now, Power BI is one of the most popular BI tools out there. It is developed by Microsoft and allows you to connect to different data sources, create interactive visualizations, and share insights seamlessly. Whether your data lives in Excel, SQL databases, or even web applications, Power BI can connect to it. Why Power BI, you ask? Because it is user-friendly, powerful, and widely used by businesses worldwide. Plus, its visualizations help you to present data in a way that's easy to understand. Let's dive deeper. These are three major components of Power BI. First is Power BI desktop application. Second is Power BI online service. Or this Power BI service can be your server where your organization data resides and you can go ahead and share your reports across your teams within your organization. And then the next here you have Power BI mobile application. All these three make sure that the report is developed and it is shared across, plus it can be viewed by the end user easily too. We are going to create reports in Power BI desktop application. Let's go through the installation and setup of Power BI. Installation and setup is very easy. You can simply go ahead and download this desktop for free. You need to, if you want to go ahead and explore the sharing, then only you need the online Power BI. However, to understand and learn Power BI desktop, you can go ahead and simply download. You can click on download free button, enter the required details if asked, and start on get started. You can also go ahead to Microsoft applications if you're working on Windows. And from there also you can go ahead and download Power BI desktop application. Once you have downloaded, you can simply follow the on-screen instructions and download, install and download the application on your systems. Once installed properly, your Power BI desktop might look like this, where you have ribbons on which features are displayed. On the left hand side, you will have a vertical menu card with the report view, table view, model view, and query view. On the right hand side, you will find 3 panes: filter, visualizations, and data. You might have a vertical pane on right side too, where we can go ahead and switch on and off the selections on the pane. Similar to Excel, you will also find here page 1. You can simply click on plus sign here and add more pages and reports here. Now, once you have the desktop, we need to go ahead and connect with the data sources. Power BI can connect to multiple data sources, that is 95 plus data sources and the connectors available there. The most popular ones are Excel, text and CSV files, SQL servers, web, APIs, and more data connectors. Power BI makes connecting to data incredibly simple. You can pull the data from Excel, perfect for small data sets like sales reports or budgets. SQL Server, a go-to for larger databases. Web data sources, imagine pulling live data from APIs or websites. And other connectors are Power BI supports countless connectors for any data that we need from other applications, softwares, clouds, and servers. For beginners, start with an Excel sheet or a CSV. It's familiar and Power BI integrates with it beautifully. Before we go ahead and look at the visualizations in Power BI, let me show you how do we connect with a simple text or a CSV file. This is our Power BI desktop. Under the Home tab, we can see we have data and queries here. We want to connect with a simple CSV here, so we go to the Get Data drop down. We click on Text or CSV. Currently, I am going to connect with a CSV dataset, a simple retail sales dataset, everyone. See here. You can see right now, this is the date, region, category, sales, and profit. And the delimiter here is comma. All these columns are automatically identified from a simple CSV file. Now we have 3 paths to select: load, transform data, and cancel. Load here will directly load this particular dataset into the Power BI desktop. Transform data will take us to another window, which is Power Query. Within Power BI desktop, Power Query is one of the components which will help us to connect with data. The components that we see in data group and in the query group, these both belong to Power Query. They both belong to Power Query. Power Query helps us in ETL process. ETL is extract, transform, load the dataset. We can see here we do have 2 options, that is load and transform data. Both the paths here are from Power Query. So let's go ahead and have a quick look into what is Power Query and how does it look like. So we're clicking on transform data here and we are directed to Power Query Editor here. Power Query Editor is going to be a separate window. This is our Power BI desktop. This Power Query Editor window, you can see we have our tabs here, the ribbons. These ribbons are majorly concerned with transformation and cleaning of dataset. Also observe there are 3 panes, queries. This is preview. In Power Query Editor, we have 3 panes, queries, which are dataset that we are extracting from the data source. Second is this is a preview pane, and third is query settings. Currently, we will deep dive into visualizations part and into cleaning and transformation. We will see that in another video. We will still go through the basics here. So first is look at this date. We can see the preview that this is a date column. We can click on this calendar icon and we can change the data type that we have here. Usually, Power BI is successful in identifying the data type. As you can see right now, for the region, it has a successfully identified text. For number, it's a decimal number, and likewise. We also have a vertical bar with the help of horizontal bar, we can explore other columns that we have inside the data set. As you can see, the data type is properly identified. We are only going to go ahead and change the name of the data set. Currently, it's a retail data set. So let's rename this to retail data set here. And now we will go ahead, closing the Power Query editor and applying and loading the data set into the Power BI desktop. We do have an option to only apply and not close the editor. We do have the option to only close and do not load the data set there. Currently, we will be closing and loading the data set there. Closing and loading the data set into the Power BI desktop. You can see the data set is loading up here. It's a small data set of 100 rows. Now here we have our retail data set. Once we have our data set loaded, now we can go ahead and start working on creating visualizations. But before we create visualizations, we should be aware about the basic interface of Power BI and the terminologies related to Power BI interface and desktop. First is, there is not much space here to build. You can see the dotted line square here. Let's understand visualization. What are visualizations? All visuals are images created from data. They help you see patterns, trends, and insights at a glance. In Power BI, you can create visuals like pie chart, line charts, maps, and KPIs. Pie charts are great for showing proportions like sales by region. Let's discuss them one by one. Bar or column charts. Bar or column charts are created to see the distribution between one categorical variable and one numerical variable. As in the example, you can see we are looking at month-wise sales variance in percentage. Or you simply want to go ahead and see the average selling area size for two different store types here. Line and area charts. Ideal for tracking trends over time like website traffic, sales from last year and next year, or to look at a certain patterns, seasonal or cyclical. Line charts and area charts are typically created over time series. Time series is any component of date hierarchy or time hierarchy, meaning year, quarter, month, weeks, or days. Says pie charts, donut charts, and funnel charts. Charts are great for showing proportions like sales by region, sales by different chains or categories. Similarly, donut charts can be used for similar reasons to show percentage distribution across certain dimensions and categorical variables. Funnel charts here can show you proportion in percentages here. As you can see right now, opportunity count by sales stage. We are looking at the sales funnel right now. How many leads we had? How many qualified out of that? How many have we provided solution for? Then out of that, how many went into the proposal stage? And how many out of the 100% were at last finalized and converted? So Power BI offers 4 core built-in map visuals to help you represent any kind of geographical data set. So here display geographic data such as sales by country, or maybe by state, or any other location or geographical location-based data set. There are 4 built-in maps. First is your basic bubble map. They can be created like these. Here are a few examples. Another is filled map. Filled map is where the area, geographical area inside the map is filled with colors. Third is ArcGIS map. ArcGIS map is an online connected map which can show you individual district. It is interactive and dynamic. It has many more features as compared to a simple bubble map and filled map that we have seen. Last one is shape maps. Shape maps are good for highlighting. In the shape maps, we cannot have data labels and it can only highlight or color the region which we add in. Let's begin with creating charts and reports in Power BI. Hi everyone, welcome back to Simplilearn, where we explore the world of data analytics and visualization. Today, we will dive deep into Power BI to create a variety of charts and explore how to make interactive, engaging dashboards, just like this. We will work with a sample retails dataset to visualize key metrics like sales, profit, units sold. By the end of this video, you know how to create bar charts, line charts, pie charts, donut charts, stacked bar charts, and even a map visualization all on one page. So grab your laptop, open Power BI, and let's get started. Now, we're in Power BI. In this Power BI interface, you might find a few new things. On the right-hand side, vertical corner, you can see a data pane. You have to click on the second build pane, which will give you the options for visualizations. The third icon here is to format whatever object or chart that you select. With the plus sign here, you can customize and get more icons from the insert menu here. If I click them on again, these will be vanished from your view. You can show and hide the panes by clicking on these icons. The left-hand vertical pane remains unchanged. Here are your report view, these are table view, and here you have the model view. Today we are going to explore different type of charts in Power BI. To create and explore the different type of charts, we are going to work on a very simple retail dataset, which is a CSV file. To connect with text or CSV, as usual, we can see here same as text to columns in Excel. It has identified comma as a delimiter. Now we are going to click on transform data. This will take us to the Power Query. In Power Query, there is let's check the data type right now. We have date with the date proper data type here. Sales, profit is in decimals. Then we have country and state, which is text. This all seems fine with us. Let's close and apply. Always remember that the interface might look different as Power BI gets updated every month. Not interface, but the Power BI and Power BI online service, that too. Once we are connected with the here retail sales, we can see we have category, country, date, and profit. Let's set their properties first. Category is fine. It is simple text, and we are okay with that. Country is a geographical data set. So we go here and we will describe this, categorize this as country. It is now recognized as geographical data set. Same goes with the state here. We will decide that this is a state. We communicate this to Power BI. It is a geographical data set. Now, let's begin here by exploring different type of charts. As you can see, the dataset we are using is a sample retails dataset, which includes date, region, the geographical location, category, the product category, sales from individual amount, from individual date, total sales amount, profit earned on that particular date, and the total number of units sold for that particular category. We have started by importing this data into Power BI, and now we are moving on to visualization. Let's see some basic visualizations here. First, let's create a bar chart. You can see here we have a bar chart. It's a stacked bar chart, and here also we have a bar chart. Let's create sales by region. Click on the clustered bar chart visual in the visualization pane, which is the first row and the third icon here, inside the build pane here. On the right hand upper corner, you can see the preview of this bar chart. As soon as you have the preview of bar chart here, observe below the build pane, we have y-axis, x-axis, legend, and more options here. Drag region to the axis field. You can also go ahead you check on region. You can either drag and drop, or you can simply check on region. Region gets added into the y-axis. Then drag sales to the values field, that is x-axis here. So here is sales. We are dragging this to x-axis here. Or we can simply check on sales here. Now as you can see, a bar chart is created. We can resize it and keep it here. Now let's format this chart. Let's see the formatting options for the bar chart. To switch on the formatting options, I will go to the right hand side. In the vertical options, I'll click on format. Once I click on format here, you can see this particular format pane consists of all the formatting options designed only for this bar chart. First, let's switch on the data labels. Just scroll down and switch on the data labels here. Switching on data labels will give more information about the chart rather than going and comparing with the y and x-axis. Once we see the numbers here, they are not much visible. So we can expand data labels, put values, and increase the font size, maybe change the font style here. And you can see now they are pretty much visible. We can also decide what units we would like to see here. Maybe we would like to see thousands with 1 decimal point. Now see, these numbers right now are written at the end of the bar, as you can see, and the position is not decided. You can scroll up here, and within the options, just above the value and the title, you can see the position currently is automatic. Automatic means whenever you will change the font style or size, the position is decided automatically. If you want to fix the position, you have the options here like inside end, outside end, inside center, or inside base. Currently, I am liking it better at the inside end. I would also like to go ahead and change the color of the bar, which is by default blue. In your organization, you might have been given template to follow, a color template to follow. You should go ahead and follow that template. Currently, I am following the basic color here. Format, under the visual format settings, we have changed the bar color and given the data labels and formatted them too. In the format, we do have properties. These properties are not specific to the chart. These properties appear on every chart. For example, the header icons. We want tooltips to be there. This is the tooltip. When you hover over the cursor, what do you see? You do have advanced options here. Okay, we do have advanced options here too. All these are common to each chart. Visual here, you have size and style. The size and position of this particular chart, it can be created from here. You can also decide the background, visual border, and the shadow of this particular chart. Currently, I'm going to switch on the borders and the shadow here to show you how the basic formatting looks like. Below the size and style, we have title. Currently, title is sum of sales by region. Usually, we don't write like sum of sales by region. Instead of we will be writing total sales by region. Or only sales by region will work too. You can also decide what kind of font should be there. Always follow the font given by the organization. They will have a fixed font to be used. You can also decide the font style, font size. If you want to give any background color to it. Now also remember that it is once it is given, it can be reused multiple times. So no, we don't have to do it multiple times. We are formatting this only once. So this is a simple bar chart with the formatting techniques. Now we want to build up another chart. So let's see a line chart, everyone. Let's figure out trend over months. To create another chart, make sure that you click outside and none of the options should be visible for this particular chart. So click outside in the blank area and automatically you will see only the format option remains. Okay, that is the simple format for the page and the wallpaper. Once you're outside, let's go ahead and create a line chart, everyone. You might find the line chart here in the build pane. So click on the line chart and here we have the line chart. I'm going to place it up here on the second quadrant of the screen. You can see a preview of a line chart here. Now since we're creating a line chart, always remember, line chart is always created to show a time series pattern and trend, meaning we need a time series, a date column here. So we do have a date. We will simply check on date, and by default that date goes into x-axis. You can see we have added year, quarter, month and day, everything at once, because date is a hierarchy, everyone. It's a natural hierarchy. So when you click on date here, it will add up to the day. Since let's see the sales trend over months, so we are not looking for day, we are not looking for quarter, we are only looking for year and month. So we will simply add year and month. We can simply cross it off here. Once we have the x-axis here, we want to see total sales here over trend over month. So we will check on sales. It will go to the y-axis. However, we are not looking at the line chart. What we have here is a single dot. Now let's figure out why. See here on the x-axis, it says that on 2023, this is the total sales. It means we have the data for only 1 year. Also observe, now you have multiple arrows, icons at the corner of your chart. These multiple arrow icons are the options to drill down. Currently, we can see year-wise sales here. See these 2 parallel arrows? It says that go to next level in hierarchy. The next level in our date hierarchy is month. So if I click on double parallel arrows here, now we can see monthly pattern here. We will drill up with up arrow key here. You can see a single dot again. Similarly, you see this fork here. This will expand down to all the levels in the hierarchy. It looks like a hierarchy flowchart. When you click in here, it will show you year and month both. See the icon here. See the x-axis here. We have got January 23, May 23, July 23. And here we have a trend. So we have successfully made a line chart which is showing us sales trend over month. Let's format this properly, everyone. I'm going to switch on the format. To keep the size here, I'm going to switch off data label for now. I have switched off data pane for now. Here is the format, everyone. In this format, now you can see we have size and style. That is fine with us. Now we have, scroll down, we have something else other than the data labels. Always remember, in the line chart, we don't switch on the data labels. If you want to show the numbers on a line chart, it is always advisable to create the column chart or a table with the same date and the numerical value to show the numbers. Because here, line charts are only created to show trend and patterns and to predict those patterns there. Instead, what we have here is markers. When you switch on the markers, now you can see where each month lies that we cannot see on the x-axis here. When you increase the size of the line chart, okay, you might be able to see a little bit more. When we have switched on the markers, when you scroll down, you do have the option to change the shape of the marker. As you can see here right now, you can also increase the size of the marker. You can also go ahead and change the color of the line. Now, how do we change the color of the line here? So we scroll up. Here was our markers. Above the markers, here we have lines. And the lines here, currently we have just one line. So we are going for all. The line is solid, dashed or dotted. So currently we are going with the solid line here. Join type is round. We have here miter, bevel. Okay, it doesn't show anything here. This is the width, everyone. I'm keeping it round. It doesn't show any changes here. Now this is the width that you can increase here. Okay, and currently we are going to keep it either linear. You have got a smooth option here. It looks like this. And here is the step option. Currently I'm going to go with linear. And remember that it might not be available in your Power BI. This is the latest version we are working with. Of course, you can go ahead and change the line color from here. So this is the line chart, everyone. And do remember, we need to still work with the title. So we scroll up, go with the size and style, which is common to every chart here. We can scroll down here. We have visual borders and shadows if you want. Below that, you will find the title. Inside this title, we are going to name this as sales trend over months. Here, try to be give exactly similar. So here we have got line chart. I'm going to resize both of them so that they are looking aligned on our dashboard. We have seen a simple bar chart and a line chart. Next is a pie chart, everyone. As usual, to create another chart, we click outside in the area within the report. Now we can see a pie chart on the build pane. With the help of pie chart, we'll see sales contribution by category. So I'm going to click on pie chart. I'm switching off the format to have a better space. Now we can see the pie chart here. We want to see sales distribution by each category. So let's click on category, everyone. Automatically, you can see it is going to legend right now. Pie chart only shows the percentage distribution values here. So let's check on sales and directly go to the values. And automatically, you can see here, it is calculating the percentage for us. We can see category numbers are also here with the list of category legend here. So we do have got colors, we have got name of categories like the size as legend. Here, to make it readable and a better visualization, let's go ahead and format this pie chart. There are a few things that we are going to fix here. First is the vibrant colors. Second is I can see the number and the percentage. However, to connect it with which category it is, we have to still match the colors with the legend. Instead of that, we'll bring the name of the legend within the data label itself. So again, I will switch off data. I will switch on the format option here. The format options is specifically for the pie chart. You must have experienced by now. For every chart, there is a different options to format. Let's first fix the detail labels, everyone. So here they are not calling it data label, they are calling it detail labels because we can add any details we want here. For example, we are not looking for number, we are looking for percentage and the name of category. So the details options here. Our position is outside, this is where we prefer here. Now we can go to label content, find here category and percent total. We do have more options here. We are going with category and percent of total, the most logical option right now. Now we can see both of them are here, right? Now we will expand the values. Again, you have the option here to change the color so that they are more visible. Maybe make them bold or increase the font size here. Now we can see here. Are there any units right now? There are no units. This is in percentage. Click on none. You do have the option to percentage decimal points. We can type 2. This is our detail labels. After detail labels here, we have the rotation. For example, if you want to show the highest one first, you have the option to rotate it and show the highest slice first. It all depends on you. Which kind of rotation are you looking for? These settings are similar to what you have seen in Excel so far. You'll find the exact same settings in Excel too. Now, last is the vibrant colors and the legend. So we don't require legend anymore. We can simply switch it off here. Let's fix the colors. What I'm going to do here is I'm going to simply select the lighter version of each color. Remember that usually you will have a template given to you by your organization and you are supposed to follow that template and the colors that are associated with the brand. And that is a much better way to go. Currently, picking up the colors which are more soothing to the eyes and have a good contrast to be seen with each other. So this is our pie chart, everyone. Now in this pie chart here, we do like to go ahead and edit the title and the background and the shadow, right? Now we can actually do, what we can do here is we can again go here to size and style. With size and style, we have the visual border and the shadow, and below that we have got title. And this title here, this is sales contribution by category. So let's name it properly, sales contribution by category. Okay, we can increase the size, we can change the font style right now. We can give a background color here and make it at center. Now, this is our pie chart, everyone. Next chart is donut chart. Let's explore the donut chart here. Let's figure out profit by region. So we have profit margin here by region. To do that, to see profit margin by region here, Let's see it by donut chart. Now to create a donut chart here, it is just beside the pie chart. Again, click outside in the region. We are going to click on the donut chart here. In this donut chart, we have the exact same portion here. Remember that donut chart and pie chart are exactly similar in concept. However, they do look different, as you can see here right now. You can see the preview of the donut chart. It is quite different from pie chart. It is still showing the percentage distribution here, but the center part of the pie, it looks like a ring. So let's go ahead and view how does a donut chart look like. We are simply going to check on region and the profit as we did for the pie chart. Now we would like to go ahead, and you can see here it is exactly like the pie chart with the middle circle is gone. We would like to go ahead and format it similar to the pie chart with all the regions written here, with only the region and the percentage of the profit here. And of course, we would also like to write the title here as it is. But since we are in Power BI, we don't need to go ahead and format it every time. Since we are in Power BI, we are not supposed to do redundant steps here. We'll simply go ahead and select pie chart. We can click on Format Painter. We can come back here. You can see the paintbrush is here. And now click. And here we are. You can see the title has been changed. You can see the labels are here. Only thing that is not changed is the colors. So we now open the format. We switch on the data here. In the format, I'll go to slices, and again, I'm going to simply select a shade lighter than the original color here. Here we are. You can see sum of profit by region. Of course, you would like to go ahead and change to a proper title. So let's give the title as profit margin by region. As you can see, there is no OK button. Whatever changes you do in the format pane and build pane, they are automatically applied here. That is total region by, we have seen 4 charts: bar chart, line chart, a pie chart, and a donut chart. Now, next is we will see a little bit advanced visualizations. For that, I'm going to the next part here. I have added one more sheet, named it Basic Charts 2. And you can see I have a background here. What are the other basic charts that we're going to see? In here, we are going to see stacked bar chart, drill through line chart, and a map visualization. Let's first see what is a stacked bar chart. We are into the build here. The first chart that you see here is called as a stacked bar chart. A stacked bar chart, as you can see here, it looks like a normal bar chart. However, we do have the option. Here to add more than one categorical value and see the distribution over one single numerical value here. For example, here we can see units sold by region and category. Region and category being 2 categorical variables. And we want to see the distribution of units sold by region and category both. So first check on region, then on category. You will see automatically they will place themselves. Since there are 4 regions will go to y-axis here. Legend is coming back to category. And now we check on units sold, everyone. And it goes directly to the x-axis here. And here is our stacked bar chart. Of course, it is the exact same bar chart, right? With in each bar is getting divided into individual regions here. So here category, we have groceries and region both. I don't want to go ahead and do the formatting all over again. So we can go back here. We can select the bar chart. We can format paint it and paint it out here. Now let's understand this bar chart effectively. Each color represents individual category. So as you can see here, okay, we have got clothing, electronics, furniture, and groceries. And each of these numbers represent the number of units sold in that particular category in that particular region. It means that 362 units of groceries have been sold in this region. And within one bar, we can see the differences here. This is units sold by region and country. It is a stacked bar chart, everyone. Let's resize and keep it here. Let's explore the formatting options that we have here. You will find the formatting options are exactly similar to what we have seen before. We have seen data labels, but here we do have total labels here. Total labels will give us total by whichever we have on the y-axis. Right now, I don't see much use of the x-axis right now. So we can scroll up. We can go to the x-axis and we can say that I don't want to see neither the values here nor the title, which will give us a better space. It will give us a better space here. This is a stat bar chart. Now let's learn in detail what is a drill through line chart. Let's learn. To understand about the drill through line chart, you might be thinking that we have just seen a line chart. We have drilled through that. Yes, we did. But now we have to actually learn the difference between the continuous and the discrete drilling down in line chart. So let's see here. We are going to go ahead and explore the line chart again. So click outside, please. Then click on the line chart here. The line chart appears, as you can see here right now. As we are aware, line chart requires the time series. So we go ahead and we check on date hierarchy, which automatically goes into x-axis here. Now this date hierarchy actually goes ahead and gives us the drill down ability. We don't want to drill till individual day here. We are looking for only year, quarter and month. Usually we only have one line that we have seen so far. So we go ahead and we check on sales for now. Now we are aware that currently it is showing us only by year. That's why we have just one dot, because we do not have multiple years. And we are also aware that we can go to the next level in hierarchy. This time the next level in hierarchy is quarters. So when you go ahead and go to the next level in hierarchy here, okay, what you're looking at quarter-wise total here. Sum of sales for each quarter. Since it is only 1 year, this particular sales of quarter is fine. It shows us quarter 1, 2, 3 and 4. However, if you had multiple years like 2022, 23, 24 and so on, then it will still show quarter 1 total sales from all of the years. Meaning currently it is showing us discretely only for quarters. It is not considering that quarter belongs to a certain year. Similarly, you can see right now, since we have one more hierarchy left, that is month, we do have this is still activated. If we go in here, we do have monthly distribution of sales over the month. In here also, it will aggregate every year, month sales over all the years that are present. So it is just 1 year. It doesn't show much difference to us. Now I will drill up again and we see quarters again, and then here we see years. Now if I go ahead and switch in here, expand all down to one level in hierarchy, here you can see same January, April, July and October 2023 here. However, it does write month on the x-axis, but this line chart shows only as per quarters. You'll also find that currently this will also ask you that here is still the scope of drilling down is available. So we go ahead and we click here again, and here we are having exact same line chart as we have seen before after the drill down. What is meant by drilling down more here? So here you can click on the chart here. Now since we are looking at the basic charts here, let's also explore. Right now we have only just one line. We have always added only one line in a line chart. Let's also go ahead and add profit here within the line chart. Now you can see we have got two lines everyone, and now both the lines can be drilled up or can be drilled down, and we can compare the trend between profit and sales. Again, we will go back to basic charts here for the formatting. We will go ahead and get our format painter here and use the format painter to format our line charts. Since we have got two lines here, we might want to go ahead and change the colors. So we will go scroll down here. We do have lines. We can decide the color for individual line. So remember that when we go to the lines here, you need to select which line you want to change the color for. So for example, I'm going for sum of profit. We will scroll down here and we expand the color. Now we can change the color here for the profit like this. As you can see, This width and everything will remain exactly same as the formatting before. Below the lines here, we do have markers. Again, for the markers, you can choose which particular line are you looking forward to. Go ahead and change the markers for. I'm simply changing the color for the markers here. So right now, what we can see here is sum of sales and sum of profit here. You can see here, it says add a legend title right now. This is for sum of sales and sum of profit, but we don't see the title is required. So we can collapse these options right now, scroll up and find the legend. Within the legend here, we do require the sum of profit and the sum of sales. This particular explanation here in the legend that what these lines represent. We do have the option right now to switch off the title. We don't need the title anymore, so we can see the titles right here. If you think that these are too small to be seen, you can increase the font size here. And you can decide the position of the legend too. You can keep them at top right. So at the end here, you can see that what these lines are for. You can also decide to keep them here too. So it all depends on you. Where would you like to keep the legends? Currently, I'm going to keep them at top and center. So these are the line charts where we have two lines in one single chart here. Of course, if you want to go ahead and set the title here, you can always go to the title and change the title here to monthly sales and profit trend. Sales and profit trends. To remember that, these drill through options will be available to the end user too, whether they have editing rights or not. This is one of the interactive features in Power BI. Next, the most interesting one here is the map. As you can see right now, in Power BI, we do have multiple different type of maps. This is our basic bubble map. Another is filled map. This is shape map. This is an Azure map. Yes, it is related to Azure. We have to go ahead and we will see the map from there. Another map is ArcGIS map. That on all these maps are needed to be this map here. Simple map is available to everyone. This doesn't need to be activated here. So first, let me show you how to activate the map visuals here, and then we'll go ahead and create a map. File here, everyone. We go to options and settings. And options and settings, we go to options. Options. We have two types of settings, global settings and the current file settings. We'll do our global settings here. In the global settings, go to security. In security, scroll down, and you can check on, you can go ahead and check on ArcGIS for Power BI. You can also check on map and filled map visuals. We are simply activating them. After activating them, Power BI might ask you to restart the whole software application. Remember that restarting means closing each and every instance of Power BI that you have opened up currently. After security, you have regional settings, and then you have preview features here. Now, these preview features here might differ in your case and this particular version here. As you can see, the first checkbox is shape map visual. Simply check on that, please. You can also go ahead and explore other options here. These are not related to the map for now. Simply check on shape map visual. So we have done two settings here, everyone. First setting was security, and the second is preview features to switch on the maps. And then click on OK, everyone. It might ask you to restart it. Yes, you need to restart to activate the maps. So save your file and restart. Currently, maps are already activated in mine, so I will continue with to show you the map visualization. To create the map visualization, as usual, click on the blank space here. This is the first map that we are creating. As you can see, it shows that it's a bubble map. We can see the bubbles here and the grayed out preview feature too. To create the map here, we are going to use the geographical columns here like country and state. When you're creating a map, look at the options that we have available here: location, legend, latitude, longitude, bubble size, and tooltips. We don't need to have latitude and longitudes here since we have country and state. Please remember that any data visualization tool, if you have the ISO standard spelling of country and state, correct spellings as per ISO standard, then any data visualization software can go ahead and fetch the latitude and longitudes and place them on the map visualizations. If you require to pinpoint a certain geographic location, okay, which can be a pin code or maybe it is a particular district or a street area, then you might require the exact latitude and longitude to be uploaded here. For now, we will check on country and state. When you check on country and state, the bubble chart doesn't look good. Why? Because by default, you can see the country is getting added into location and the state directly going to the legend. However, we want our state to be added below the country. So we'll drag and drop the state below the country here. As usual, you can see, and we will close off the legend from here. Now you can see we have got bubbles across here, right? The countries here, and we do have the option of drill down. Once we drill down here, we will see few more bubbles across. So now it is showing us individual states in each country. That's good for now. So we have bubble here. If we will scroll down, you will also find currently these bubbles are only showing the position right now. If you scroll down here, we have few more options like legend. Then we have options here like bubble size. It means that we can use the bubble size here to see how much sales has happened where. And as soon as I drag and drop the sales into the bubble size here, it is sum of sales right now, and we can see the size of the bubble has changed, and we can figure out the highest sales here is in Scotland. Similarly, we have legend. In the legend here, if I will go ahead and bring the state again into the legend, you will find that each state is colored separately. We can see the legend up here. Let's go ahead and format this map. To format this map here, everyone, we will go ahead and switch on the format options here. In the format options, we do have very less options in the format visual settings here. First is our legend, which is not properly visible. So we can switch on the legend right now. The position is top left, which is not properly visible. We can go ahead and keep them on the left side stacked like this. Now they are pretty much visible to us. We don't need the title right now. We know these are states. So we can switch on the title here. Now we have the whole map in front of us. We do have few map settings. In these map settings here, okay, we have different styles of map. This is our road map right now. We do have an aerial map, which we are accustomed to, the satellite map. We have dark themed map and the light themed map here. Please do remember that if you're using dark theme, your whole report has to be dark themed. This is our grayed out map, and it's a simple road map here. Why it's called a road map? Because if you will zoom in, okay, you can actually see the road maps here, just like this. Next here is controls of the map. In controls of the map here, currently it is automatic zoom here. For example, if I click on west here, it will show me only west region and it will automatically zoom on that particular part. We can also add the zoom buttons out here. So you will have plus and minus zoom buttons here too. This is all in the maps. So currently what we have created is a bubble map, everyone, and we can see each bubble here and where we have the signs. Now it depends on you. How would you like to keep your legend and add more colors to it? And as usual, okay, we want to go ahead and format the title here. So we can always go ahead and use Format Painter and we can have the title painted here. Use the Format Painter to paint the title here. Of course, we can always go ahead to the title here. And what we are looking at here is the sales distribution by location. So let's give a proper title, everyone. This is sales distribution by location. You might have observed that there is no option here to add data labels here. We do have category labels. Category labels will simply go ahead and switch on the name of the state and the country. If you have city and district name too, it will add it back to here. However, we cannot go ahead and show the labels out there. So I don't like the state labels always. Okay. It crowds your map and it is not properly visible. I'm going to switch on the category labels right here. So everyone, these are stack bar chart, multiple line chart, and a bubble map. Now let's go ahead and create a report out of these charts that we've created so far. In this report here, we will also add few more objects and we'll make our report interactive. Now in Power BI, there's a difference between a report and a dashboard. In general, what we call a dashboard is the collection of multiple charts and other objects, which are either interactive or static, but they should serve and solve a particular objective or a function. However, in Power BI, whenever we are working in Power BI desktop, each of these pages that you open up, and when you have multiple charts on it, it is called as an individual report. When we will publish this into Power BI service, or you can call it online Power BI, currently we call it Microsoft Fabric, then there we create a dashboard, and that dashboard can create charts from multiple Power BI reports, not only one data set, from multiple data sources too. So dashboard is a different part. What we are going to create here is an interactive report. Now that we have all charts on individual report page, let's go ahead and copy paste few charts here within the pages too. Report page, we are going to design it as per the objective of analyzing our sales and profit for this particular retail store. First, let's give a title to the report, everyone. To give a title here in the Home tab, we'll go ahead and click on text box. In the text box here, I'm going to simply type right now that it's an annual sales for performance report. So this is annual sales performance report, and we are keeping it for retail sales 2023, for example. Now this is a text box. I'm going to increase the size of the text box here. Of course, the data that we have written here, it is not visible. So you can Control A or select, as I've done right now. I'm going to change the font size here. I'm going to keep it bold. Let's keep it at the center. I am going to change the size of this retail sales 2023 that I've written here. Like this. And here we are. So this is our annual sales performance report. What I'm going to do here is showing you another way to create this. I'm going to select this whole thing. Alright, I am going to make it a little bit gray. Of course, white and gray is not visible. So we go ahead and we open the format option for it. And in the format option, within size and style here, we are going to give it a background color. We are going to give it a darker background color here. And here we are. Much better. We will give it a border too and a shadow here. So this is going to be our title for the report. You can size and place the title. Once the title is here, you do have few options like padding. Okay, what does that mean is how far it is from the borders here. If you want, you can go ahead and decrease or increase them as per your choices. Within the visual borders here, okay, you can change the color of the border here. Corners rather than a rectangle. Here you can have the rounded corner rectangle. You can see it looks like this. Here, do you see the rounded here? Rounded corners here. It looks like this. So right now, this is the title that we have given. After the given title, let's go ahead and get few charts. So first, I'm going to go ahead and get the simple bar chart. I'm simply copying and pasting for now and keeping them at a certain place. I'm also going to get our line chart and the map here. As you can see right now, we are resizing it. Every chart is getting resized here. Since we are bringing all the charts together to create a certain report that can give us the performance of sales here. I'm also going to bring our pie chart, and a donut chart. It does look everything is very small and compact. However, it is because we are currently designing in the zoomed out version here. As in when, we will resize it to a proper viewing capacity of your laptop screen and the general 16:9 size. It is going to be perfectly visible. So we do have our all charts here. Let's go ahead and add few more objects that are required in the reports. Few other objects are, first, let's go ahead and add a slicer for country. Why not see the sales distribution by region, by category, and by location for each country? To bring out the slicer here, click outside on the And here is the slicer, everyone. This is how the icon looks like. What is a slicer here? Slicer here is an interactive filter which the end user can directly interact with. They can change the view of the whole report. And this particular slicer by default will be connected to each and every chart here. So if I select here, for example, Australia, you can see it zoomed in into Australia here. I can see over the time here. You can see contribution by category and region too. If you want to clear it out, okay, you can go ahead and clear selections from here. However, we do have an option. So if I open up the formatting options here for slicer, okay, we go to slicer settings. In slicer settings, we have vertical list. That's good. This is what we are looking for. In the selection, we can go ahead and switch on the select all button. Select all button, make it easier for the end user to understand what's going on here. And if they want to go ahead and uncheck any selection here, okay, they can simply go ahead and select all too. It gives them flexibility to understand how the slicer works. Now, after the slicer here, I would like to keep my KPIs and the aggregate numbers on the display here. To do that, we have multi-row cards. So again, click outside here. I'm going to click on multi-row cards. Cards are the display cards here. In these cards, we can go ahead and display any numbers that we are looking for. I'm going to show the cards here. I'm simply placing it in the available space here. Inside this card, as you can see here, within the format and the build, it simply has one option to fill, that is fields. In this fields here, let's go ahead and check on our numerical variables, like we have got sales here, profit here, and number of units sold. When you check on these, within the format here, we do have the option here to make them visible. Property, for example, we can go ahead and decide the font here, which kind of font you will be looking for values and the labels too. So I'm going to increase the font style for values. Okay, you can go ahead and also decide the font style too. So these are category labels and these are the numbers here. The cards here. Okay, you can go ahead and decide the background color for individual card too. Now there are multiple formatting options available for us. If you want to go ahead and give border to these, okay, you can go ahead and give the border too. Like this. Okay. So now here are our multi-cards. Multi-cards, we can have our KPIs placed, like we can see our sales, total profit, and the sum of units sold too. This is multi-cards here. When you talk about objects on a report here, okay, now we have got a slicer and multi-row cards here. Now we can also have an image. How do we insert an image here? You can always go to the insert drop down here. Right hand side here, you can see image. This is an image that we have here. Let's find another. Here I'm using one image right now. Okay, a general logo here. Here for Simplilearn. As you can see, the image is right here. I'm going to keep it here. Now remember that this image can serve multiple purposes too. You can add actions into it. You can add multiple formatting options too. So right now, I'm not giving any title to it. Okay, and this is our image style. Currently, the scaling is normal. Either we can fit it to the size here, or we can ask it to fill whatever size that we create here. It all depends on us that how we would like to go ahead and view this image. And save this image here. Right? Now it all depends on what kind of scaling you are looking for here. So here we have added an image as a logo, everyone. I'm keeping the scaling as normal. So if you're working with me here, congratulations. You have created a fully interactive Power BI dashboard with bar charts, line charts, pie charts, and map visualization too. Now let's go ahead and decide the interactive part, everyone. Here, whenever you click on a chart here, you will find two extra tabs called as Format, Data, and Drill. Let's go to the format here. So currently I'm selecting the bar chart here. I go to the format. In the format here, we have on the left and upper corner, we have edit interactions. This edit interactions here decides that how each chart decides to behave with another objects and charts available on this particular report. When we switch on edit interactions, you can find that this particular bar chart is currently filtering out the map. We have three options here: highlight, filter, and stop, meaning none. So currently it is highlighting the donut chart, highlighting the pie chart here, filtering the line chart, and filtering the map. What does that mean? So let's see here. If I click on West bar chart, you can see the line is getting filtered out. Your bubbles are changing. However, look at your pie chart. Your pie chart currently has highlighted a certain area of a certain slice of that particular West region. And within the West region here, it is trying to highlight within the donut that how much percentage is here. So for West, it only highlights West as 32%. We would like to change that. We would like that only filter should work. So we go ahead and we highlight filter and we highlight filter here. We can go ahead and decide the interaction for individual charts too. So if I click on the pie chart here, I would like it to filter out the bar chart and filter out the profit margin chart too. I click on the donut chart. I will make sure that it filters out the bar and the pie chart here. Similarly, we decide for the line chart here. Okay, it is going to filter out each chart here. By default, everything is set on highlight. Same with the map here. We can select on map here. And we can ask it to go ahead and filter out each chart that is associated with it. If you want that no one should be able to click on the line chart and filter out anything else, then you can go ahead and select none. If you select none, then it will not be parted out here. Once you're done with the settings for individual charts, you can go ahead and switch off edit interactions here. And remember to save your work. Now let's see how does it look like. This is our final report, everyone. If I want to go ahead and see what's happening in Australia, I can simply check here the slicer. Okay, we can see the Australia here. Over the time, how was the sales? How was the profit there? What was the how the sales? We have sold out clothing at 41%. And the highest grossing region has been West here too. So if I click on West within Australia, the West region, we can see the West here. We can see the South here. Okay, we can see the North and the East here too. In a similar manner, we can go ahead and check for another countries too. And you can see how easily and smoothly the map moves. And we can go ahead and give multiple filters by using slicers and multiple charts too. If you want to go ahead and give multiple filters, always remember, you can select on individual chart by holding on to control on your keyboard, just like this. So West into clothing store, this is how the sales and the profit has been working. Australia, if I want to go ahead and see the West and only the clothing, this is the trend that we see. If I select only for UK, this is the trend that we see in UK and US too. So here, we are applying multiple filters too. So congratulations everyone, you have created a fully interactive Power BI dashboard with multiple charts and interactions. Remember, always choose the right visualization for your data. Avoid clutter and focus on insights. Use interactivity to make your reports engaging for the end user. Thank you very much everyone. If you found this video helpful, please like, share and subscribe to our channel. And see you in the next video with text measures.
Hi everyone, welcome to Simplilearn. Today we will learn how to build DAX or data analytics expressions in Power BI. For that, let's consider a small problem statement, or in other words, a use case. So here it goes. In a mid-sized car dealership network, analyzing profit margins and sales trends across multiple dealerships and car models was a challenge. The raw data was scattered across the three datasets: dealership information, data inventory, and transactional sales. Manually calculating key metrics like profit margins, top performing dealerships and seasonal sales patterns was time consuming and error prone. By leveraging DAX in Power BI, the problem was resolved with ease. Measures like profit margin, total revenue, and revenue contribution percentage were created to dynamically calculate insights. Relationships between datasets enable seamless data integration. Interactive visuals allow decision making to filter and drill down into key insights by dealership, car model, or even time period. This automation reduced analysis time by over 50%, providing faster, more accurate business insights. Power BI's DAX capabilities transformed a data challenge into a strategic advantage for decision making. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. So before the demonstration part, let's understand what exactly is DAX in Power BI. So let's say you have a sales data set with you and your manager is expecting you to give you some sales insights like the top performing product or the least performing product, or he or she wanted you to manage the inventory with those products which are on high demand, right? In a similar way, you had to perform some analysis, you had to perform some checkings on your data. But if you are checking like about 10,000 rows of data, then it might be a little difficult for you. What if you had a SQL-like capacity in your Power BI, SQL-like a query thing in your Power BI, which can work for you by just taking some simple queries from you, like summing up a few details on the revenue, summing up a few details on the profits, and also calculating which is the highest performing product, which has highest demand. You can count the orders, which is that single product which has the highest count of orders, right? Sounds a little too interesting, and it helps you in real time as well. So data analysis expressions, or DAX, is a single formula expression language used in analysis services like Power BI, Power BI, etc. DAX formulas include functions, operators, and values to perform advanced calculations and queries on data in related tables and columns which are in tabular data models, right? So you can perform some aggregate functions like minimum, maximum, sum, count, etc. And after that, you can also perform some mathematical operations like basic mathematics, sum, difference, and division, multiplication, etc. And in few scenarios, you can also apply some logical functions based on if condition, switch condition, and minimum. Like if you wanted to find out or categorize the sales in 3 different categories: minimum sales, maximum sales, and medium sales. Let's say you got 10 total orders, and out of which there is a single product which got 5 orders, and there is a product which got about 3 orders, and there's that last third product which got about 2 orders. Then you can categorize the one with the highest orders is maximum orders, the one with lowest orders is the minimum order, and which is in between the maximum and minimum is the median number of orders, right? You can perform such DAX applications as well. So this is all performed on the DAX programming language or the expression language in Power BI. Now that we have a basic understanding of what exactly is DAX in Power BI, let's get started with a practical session where we will create our own sales dataset using generative AI, and after that we will pull that dataset onto Power BI dashboard or Power BI desktop and then begin with the DAX operations. We will prepare some use cases and we will create a DAX expression and extract the insights that we are looking for, right? I hope that's clear. Now let's switch to the generative AI and the prompt that we designed to generate a dataset of about 5,000 or 10,000 rows as per the requirement for this particular analysis. So now we are on the prompt. So we will be going to create a dataset based on customer data India, and we will be having the following columns: row ID, order ID, etc., and all the product names and everything, subcategory, traffic. Most important part. This will be the most important part. Traffic, leads, orders, quantity, price, discount, cost to company. And this is something which we will be calculating in real time. So profit is nothing but the price that we are selling a product minus the cost to company which we had spent to create that product, and what's the rate of each product, number of units sold, and everything, right? And we will also give some key areas where ChatGPT needs to focus on. states. For states column will be having the Indian cities, and regions will be north, south, east, west, and some brands which are randomly chosen, and some product names as well, right? So this will be our prompt. We will just copy and paste this onto the ChatGPT, and ChatGPT will generate us the required data set. So now we are on ChatGPT. You can just paste the prompt here and keep it running. It might take a couple of minutes to get this query executed and our data to be ready. So far we have already created this data, and it looks something like this. So we will be having about 10,000 entries of data. So we have each row ID here, and also a specific order ID, and the order date and ship date. And apart from that, we have also got a ship mode, all the details including the traffic leads, order, price, discount, cost to company, and rate of each product. So far so good. Now we can proceed with the DAX analytics in Power BI. So you can just save the data, and now we can switch to our Power BI window. So we will be having a blank report, and the data that we created is in Excel format. So you can just click the import data from Excel. So you can import data from various types of sources. It can be a web page, it can be an Excel document, it can be a comma separated value, it can be a website data, or anything, right? As long as it has data in it, even if it's a database from different varieties, if it's an Oracle DB, if it's a Cloud DB, you can pull it, right? As long as it is a data, you can pull it onto the Power BI window. And we have a separate tutorial on how to load data from various data sources. Now that we are working on DAX, so we have the data somewhere here. So this is the data that we'll be working with, which is a CSV. Just open it. There you go, you have the preview. So these will be your rows and columns. This is a quick preview. Check the data type and everything. If you have any issues with the data, you can proceed with data transformation to check on that and refine the data in the way you want, right? You can arrange the columns in places. You can also calculate some things. You can perform some mathematical calculations and get the data set ready. And apart from that, if you wanted to add a couple of new columns, you can also do that. And if you're looking for an exclusive tutorial on transformation of data, we have that in our tutorials list as well. Data transformation in Power BI, you can go check for the reference. Now, so far we are having a healthy data, and we can quickly proceed with DAX, right? So I'll just select the load option here. The data will be loaded shortly. There you go. We have successfully loaded all the 10,000 rows of data, and here you have all the columns that you're looking for. And on the left side, you can see we have a report view which we are currently on, and here we have a table view where we can have a preview of the data set, and also we have data models. So data model will be in use if you got your data located in multiple data sources. Let's say, if not multiple sources, let's say you have the same data segregated in 3 different data sets, like you have an orders data, and you have a customer's data, and you have a dealership data, right? Then this is the place where you can go check your data models. Right now, everything is in one single source of sheet. So you have one single model here. In instances where you have multiple sources, like part of the data might be in a SQL database, part of the data might be in an Excel workbook, right? You can establish a relationship between those 2 data sources. That's when the data modeling comes into picture. And we have a dedicated tutorial on that part as well, data modeling and star schema, or you can also call it as the snowflake schema in Power BI. You can have a quick look on that front as well. So far so good. So we have the data set here, and we are on the report view right here. Now we can begin with the DAX applications. Now you can add any DAX application or DAX expression using this particular thing here, which is called as data expression. So you can just click on it and go ahead with writing. But before you go ahead with writing manually the DAX expression, I'd like to show you a quick tutorial about quick measure. So basically, DAX is nothing but a measure, right? You can also call it as a measure. So for quick calculations, you can go with the second window here, which is having a flash logo on the calculator logo. And if you just expand it, here you can see some wide range of applications. Average per category, max, minimum, weighted average per category, filtered value, sales, right? It's basically giving you some recommendations for quick calculations. If you want to perform some time intelligence, year-on-year sales, quarter-on-quarter performance, you can go with it. And if you want to add some mathematical applications like addition, subtraction, everything else is really available here. And if you're going with some text related or pattern matching operations, you can also go with this text operations here. So it'll give you a quick way to just design your DAX. And right now, let's proceed with the manual way of, for the learning purpose, let's go with the manual way of designing a DAX and understand how exactly DAX functions in Power BI. So far, so good. Now, let's begin with our use cases. Now, let's say we wanted to find out, let's go for the table view. So here we have a column which is related to quantity. Now we don't know how many number of or what's the quantity of items we shipped on an overall scale in the year 2023 to 2024 or 24 to 25. We wanted to calculate that part. So to do that, let's go to the report view and create a new measure. And you can measure or name it as. So basically it comes out as a measure by default, but you can give your own customized name for your measure. So we can call it as total orders. And you can just give a sum function here, summation of, here you can see multiple columns, right? So we want to check the quantity. So I think we named it wrong. No problem. We can customize it again. So we wanted to check the total quantity, sum of the quantity of products we deliver. So instead of orders, we can name it as total quantity. There you go. Now that we have no errors in this particular query, we can proceed. Now it's committed and we have a new measure here, total quantity. And also, if you want to avoid confusion, you can also drop a note here. This gives me total quantity of units ordered or total number of units ordered. There you go. Commit and you have a new measure there. Let's pull up a visualization for that. So I'd like to go with the bar graph, and apart from that, let's pull down the data for product name as x-axis, and on our y-axis will be the newly created total quantity, right? So here we have a brief understanding of what's the product which has the highest number of sales here, right? So 4,000 plus in quantity was ordered for this particular product, which is lying in the first place, this one, right? Now this is how you can make use of DAX. Apart from this use case, let's proceed with a few more on the line. Let's proceed with a similar one. I'll create a whole new measure and it will be named as total revenue. So you can see I'm not following the underscore thing here. You can if you want, but it's not SQL, so we can continue without having the underscore or combining both the keywords here. So total revenue, you can write this in format of which looks something like this, or you can just place a spacebar and write this. If you were on SQL, then that could be mandatory. But since we are not on SQL, we can take it a bit little easier. So sum of revenue. So let's check the column names. Price. So we have named revenue as price, not a problem. So that's the one we're looking for. Close your parenthesis. And if you want to comment, you can give a comment here. This gives me total revenue made. There you go. To commit this, just click on this button here, commit, and there you go. You have successfully created a new DAX, or you have successfully created a new measure. Now, proceeding ahead, let's create a new visual for that again. You can create a matrix and you can drag some categories which are the otherwise named as the company names, which we created using our ChatGPT or GenAI. Now we want to know what's the revenue made by these three categories. Now for that, you will pull the total revenue DAX which we recently created. Here you can see, so that's the total revenue, which is $27,38,133 or rupees in revenue. Now let's proceed and create another fresh DAX for cost for company. Now why do we do that? We are going to use both the existing DAX. So we already have a DAX which is for the total revenue we generated, and also we'll be creating a new DAX which will give us the total cost the company spent on, creating an inventory, creating the products and making them available for the dealerships and etc. Right? Now we will be using both these DAXs and create a new DAX and find out what's the profit, so that we can, basically categorize based on the companies. We have multiple brands here, so we can find out, you can pull out the data for multiple brands and find out what's the cost they spend in creating their inventory, what's the revenue they generated after selling these premium products to the dealerships, and what's the profit they made using all the 3 DAX that we created, right? It can be used in that way. Now let's pull up a new DAX function here, and you can name it as total cost spent for the from the company, and you can create a sum function, and you can pull the column cost to company here and enter, or you can also provide kind of shift enter and comment it as total cost spent by company, right? And you can commit this, and similarly it's been created. So if you want a visualization, we can also do that. We can pull up a new tab here, and you can add those things onto the tab. So we will be pulling category on first, and then we will be pulling the newly created DAX, which is the total cost spent, and you'll be adding it here onto the table exactly where it should be. Now this is the amount of cost the company spent, which is 20,000 or 20,52,335 dollars. Now we will be calculating a new DAX, which will be done using the existing DAX here, right? So we will be creating a new DAX, which is here, and you can name it as profit made. And now we will be pulling 2 DAXs, total revenue, press tab to select, minus total cost spent. You can do it this way, or you can also, I'll just copy this. You can do it this way, or you can also pull up the subtraction function or the difference function maybe. Or maybe not, we have some issues here, not a problem. Let's proceed with the generic method, what we know. And you can just comment it as calculating profit. So maybe we were supposed to use the calculate function here and then provide the, so we have a calculate function here, so we should be using that function and then give the difference, the different columns that we want to include, and provide the sum, or provide the kind of operation we want to perform, that is subtraction. So that's when it comes out. But anyways, this is good enough. Now we will commit this particular DAX, and we will have a new table working on it, and that's done. Profit made. This is our new DAX here. Now let's pull a new table, and you can add it here, and again pull the category and pull the profit made, which is here. And now you have a fully functional column which gives you an entire report of what's the cost spent, what's the revenue made, and what's the profit made. In case if you want to add this particular data onto your data set, you can also do that. All you have to do is just go to this particular table, and you can also think of add a column here, new column. Now you have it. You can provide a, okay, let's name it as profit 2 for eliminating confusions, equals to, you can select the price column, or you can just use the DAX, press tab to select, enter, and you have it here, right? You can even include the DAX formula and the outputs of the intermediate results of the DAX that you prepared to be as your new column in a table data set. Right, that's how you do it. And now let's go back to the report view, and let's try to explore a few more use cases. Now let's say we have 3 different categories here, right? So 1, 2, 3. Now let's say we wanted to divide this profit they made in form of percentage. Here you have mere numbers, but we don't know, or maybe to present to a client, it might be a little more interesting if you presented it in the form of a percentage. What's the market share they have? Now let's create that DAX here. So you can straight away pull up a new DAX here, measure here, percentage of market share equals to. Now we will be using the profit DAX that we recently created. divided by total revenue DAX that we recently created. We'll be using two different DAXs here and create a new profit share in percentage. Or you can also give it, kind of a comment, modulus symbol, which indicates it's a percentage. Now you can just commit this, and again you can create a new visualization, or for this maybe we'll go with a pie chart or download chart, and then we will pull the category. Then we will also pull the newly created DAX, which is about the percentage of market share, and you will have it here. And if you kind of expand it a little, you can see we have decimal numbers. And also, if you can see, Power BI has already helped us by providing the accurate percentage here by doing the data formatting for us. So we have about 33% by category and about 33.52% from ITC, and lastly 33.35% from Nestle. Right, so this is how you do data formatting in Power BI DAX. Now let's keep it aside and let's proceed with a couple of more use cases. So those are a few instances on how you can use exactly the data analysis expressions in Power BI and extract some valuable insights on the number of leads you get, number of orders you receive, what's the traffic, what's the revenue, profit, and cost you spent to maintain the inventory, and a lot more than that, right? So those were a few use cases on how to use DAX in Power BI.
Imagine combining the simplicity of Excel with the power of Python. Sounds exciting, right? You must be wondering if it requires a lot of coding. What if I tell you that with almost negligible coding, with Python in Excel lets you perform the advanced data analysis? You don't need to be a coder or a developer to use it. With Python and Excel, you can analyze large datasets, create stunning visualizations with libraries like Matplotlib, and even automate tasks like report generation, all within Excel's familiar interface. It's a game changer for anyone looking to work smarter and faster with data, no matter their coding experience. In this video, I'll show you some amazing things you can do with Python in Excel. From creating data frames to filtering data with the simple queries, it's packed with features that make your work easier. But before we dive in, let's take a quick look at what Python in Excel is all about. Python in Excel is a feature in Microsoft Excel that integrates Python directly into the Excel environment, allowing users to write Python code and execute it within Excel sheets. This integration combines Python's powerful data analysis, visualization, and automation capabilities with Excel's familiar interface. Now that we know what Python is in Excel, let's explore how we can use it. So, I am inside Excel and you must be looking for Python over here. So, basically, you can go to this formula section and see Insert Python option available over here. You can get started just by clicking on the icon, or you can just click one cell and you can write equal to py and then press tab. Now, the Python mode is activated. So, as we are working with data, the first step is to send the data to that Python because it needs to see it so that it can actually work with it. To do that, you need to select the whole data set. For that, I'll select this, and now you can see over this section that it is written the data range, I mean the cells range, and headers is equal to true, as we have headers over here. Now press enter. Now you can see that it didn't happen anything, only it went to the next line. For me to run this, we need to press Ctrl plus enter. Ctrl plus enter. And see what we got. We got a data frame over here. If not aware, data frame is a two-dimensional tabular data structure in Python provided by the Pandas library. It is similar to an Excel spreadsheet or an SQL table consisting of the rows and the columns. Now, take a look at beside the formula button. Here, this is actually the Python object, and even we have a drop down over here. So it is written Python output, and we have a Python object that is the present form and the Excel value. Now I can switch to this Excel value and will get my whole data available over here. This is basically dates. So we have imported this data set over here. Now, as it is taking too much space, I can go back to the Python object and make it compact. Now, if you're interested in knowing what's inside this data frame, you particularly click on this image and there will be a visualization appearing for you. The first 5 sets over here and the last 5 data sets over here. It is basically the beginning and the last part of the whole data set. This data frame is a fundamental part of a specific Python library that's called the pandas. Pandas is like your go-to toolkit in Python for working with data. It makes the handling tables like spreadsheets or databases like this super easy with its data frame structure. So whether you're cleaning the messy data or analyzing trends or merging data sets, Pandas has covered everything. Plus, it works great with the libraries like NumPy and Matplotlib. So you can explore and visualize data effortlessly. So better you can go and research about it. I will talk about this later. But guys, now I'll tell you what all cool things you can do with this. Now, I'll go to another cell, then switch to Python mode, py and tab, and then take the reference of this previous data frame and I'll write dot describe, open and close parenthesis, and then control plus enter. See, I got another data frame back. So as I got a new data frame, I'll switch to this Excel mode value and let's see. It's a date. So we have some information. So the total count of quantity we have is 20. The mean is 23.7 and the sales mean is also 1687.6. Minimum is this and everything we have got. Now, we'll move to Python object. It basically gives a quick insight of the data set. Now, it must be planning to perform various calculations using this data set. So it's better we give it a name so that you don't have to reference to the cell again and again. For that, you need to go and select the first data frame and then write in the formula bar here. Just type the name given to it. I will give it as df, which represents the data frame before everything, and then you can press Control Enter. So I have already defined the name to this. So every time I don't need to take a reference of this data frame. Now basically we can now go and write df.describe. Control Enter. Now nothing has changed. Now let's talk about the shortcut keys like the quotations. Now suppose if I go to this Excel value and I want my product details over here, so for that I would go here, df.product.describe and Control Enter. Now you can see that the total product count is 20, the unique products we have is 8, and the top selling product is headphones, and the frequency of that headphones are 5. Now keep one thing on mind that now my value for this header is just product. If I would be having like product details, like having spaces and everything, I can't write product over here. I need that third bracket on and third bracket off. So keep that in mind. Unless you don't have a space in your header name, you can type like this. You can write df.product.describe. Now there are lots of functionalities in Python. I repeat, now there are various functionalities in the pandas library. Some of them that all are familiar with is a sum and average. So let's suppose I want the total sales over here. So I'll shift to this Python mode and I'll write df dot sales dot sum and open and close parenthesis. Then I'll press Ctrl Enter for running it, and you can see the total sales has come. In a similar way, you can even get the average. You just have to replace this sum method with mean and then Control plus Enter. And now you can see the average value of the sales. So you must be thinking right now that this can be done with Excel functions as well. So why do we need Python? Don't worry, I have got you covered. So let's take this tutorial a little forward. Let's think we want the total sales for each date available over here. Then for this I'll switch to a different cell and I will activate this Python mode and then type df, that is this data frame initially we have, dot group by, this is a function in Excel, then open parenthesis and we'll write date, then close parenthesis, dot sales dot sum, just like the previous one we made. And then Control plus Enter, and I want an Excel view of this whole series. So let's see. This may be loading and you can see the date over here and the corresponding sales. It works so wonderfully that you can do data filtering and data analysis in just a few seconds. So now I want everything on a monthly basis. So for that I'll get inside this group by and I'll write pd dot grouper, first bracket on, and we'll write key equal to date, comma, frequency equal to m, and close parenthesis and Control Enter. So it has basically given C for February, for March, for April, May, and in this way you can get the whole monthly wise sales. Now I want to give this a name as chart. Type as, and I will press enter. Now I will write chart dot plot x equal to date, comma, y equal to sales, comma, kind equal to line, and I will close this parenthesis. Now press Ctrl Enter and you will get a very little chart over here. Have to wait for some time and you can see a great thing, very interesting one over here. Now I'll show something more cooler than this. So I'll select one cell over here. Now I will select something over here equal to Python and tab, and then I'm using pd.melt, start the first parenthesis, df, that is the first data frame, comma, id, verse, that is equal to date, comma, product, close the third bracket, then comma, value, verse, equal to, third bracket open, quantity, comma, sales, and Control Enter. And we'll see something amazing. We'll go to this Excel view. And we can see the date product variable, and we have actually merged the quantity and the sales, and this is basically the date. So with this, you can do very amazing things in Excel using Python. So there are much more than this.
Today we will learn how to use Power Query for automating the mundane task of data cleaning and transformation for data analytics. For that, let's consider a small problem statement, or in other words, a use case. So here it goes. Let's assume that you're a business analyst working with top banking firms. The banking systems generate performance numbers across multiple states and regions and intend to grow. They found out loans can also be a key performance area that can be tapped out to grow better. They hire you to help them out filter out a couple of loan applications that were held pending or rejected despite the applicant having a good background. Due to repetitive manual data cleaning, report structuring, and calculations, the process was taking several days, delaying the decision making. Bankers struggle with errors and inconsistencies due to high data complexity. Now, you being a business analyst with the right skills can help bankers by performing and automating the process of application background check and risk detection. Now you can quickly jump into the Power Query, generate some data transformation steps to fulfill the requirements for present and for the future simply by automating the process that drastically reduces the manual effort. As a result, report generation time drops by more than 50%, and reports and dashboards are more insightful, and bankers also receive an actionable insights faster. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. So what exactly is Power Query? Power Query is a Microsoft tool that helps users extract, load, and transform the data. Power Query is a Microsoft tool that helps users to extract, clean, transform, and load data. It's built into Excel and other Microsoft products like Power BI and can be used for the following. Firstly, connect. Import the data from a variety of sources like CSV, cloud services, or locally. Second step is clean and transform. Shape the data to meet specific needs while keeping the original source intact. Followed by that, we have the next stage, which is either combine or directly load. So if you have data in different sources, like a part of the data in CSV and another part of the data in cloud, then you can integrate the data from multiple sources to create a unique view. Just imagine if you have all the data in one source, let's say a CSV file, then you can directly clean and transform and proceed with loading the data to an analytics platform like Tableau or Power BI. And then the last part is transferring this clean data to a data visualization platform like Tableau or Power BI, or anything that the end user is dependent on. Now, the stages of all this process, starting from data collection to data visualization, there are multiple stages, out of which this part where you clean the data, you transform the data, and you transfer it is the most prominent one and the most time-consuming one. Now, if I tell you there is a tool which can help you do this, and again, if there is a possibility to automate the whole process of cleaning the data, transferring or transforming the data, and then transferring the data to the end user just by a few couple of clicks, would you believe it? That's what Power Query is designed for. So using Power Query, you can just drag and drop your data on the Power BI or Power Query platform, because the Power Query is similar to Excel as well as Power BI. So you just load the data and then you explain Power Query what you are planning to do. For example, splitting the data into first name, last name, or adding some mathematical calculations to understand what is the risk number, and if you want to calculate some interest ratios or overall due, right? If you wanted to do such things or filter out a couple of things to eliminate null values, there are n number of possibilities. We're just scratching the surface, right? And if you just help Power BI to understand your plans, then it will sequentially make those steps aligned. And whenever you give fresh data to it, it'll just perform all those tasks for you within just a couple of clicks, saving you tons and loads of time, which you can invest in planning and strategizing the next step of yours to increase your business potential. Now, to understand it in a much better way, let's quickly switch to Power Query and present some demonstrations for a better learning experience. For now, we are on Excel. So this will be our sample data. This is completely created using generative AI, and we also have created a prompt for that. So we will be including customer name, ID, email, phone number, and all the required columns that usually a banking sector follows. Now, what are we supposed to do is, you have a plan. You're supposed to find out there are a couple of people with very good background, having less number of credits and no bankruptcies and good CIBIL score or credit score, and they have applied for a loan, which can be a personal loan or a car loan or a home loan. So we also have a couple of loans here, loan type, if it is secured, unsecured, and different types of interest for different types of loans, everything, their total income and their total due if they take up a loan, right? You need to sort out those applicants who have very good background, very good credit score, and they are no risk for providing a loan. So there are certain number of situations in which a bank might not provide you a loan for certain reasons. And overall, during the timeline, a couple of reasons due to which the bank has selected not to approve a loan might disappear. Maybe an existing loan can be a reason. And over the time, he might have cleared that existing loan or improvised his credit score. And you have a good opportunity for now for approving his candidature. Or maybe some other reasons due to which lack of funds in the bank. Let's imagine it might not be a real situation, but due to such situations, let's imagine due to such situations, even if the candidate was really good and we or a bank cannot provide him that particular loan amount, right? Now, if the bank situation is really good and ready to provide loans, they want to identify which were those candidates who were trying to apply for a loan in their bank. And if there is a chance to contact them back and let them know that we are now ready to approve your loan. So this is the overall problem statement. And now we're supposed to run this a couple of queries and filter out a couple of data and fetch those candidate details. Now you can say that this could be a really easy task, but let me remind you, this data has almost more than 4,000 to 5,000 applicants, in which a couple of loans are already approved and a couple of loans are already, rejected or in pending zone. And you can just filter out to give me a loan or details of the guys whose status is rejected or pending, right? But again, a couple of people might go with unsecured loans and a couple of people might go with secured, but their credit score could be low, right? There are multiple possibilities. Now, this could be a little more challenging for bankers. So this is the time when they take the help of data analysts. You being a data analyst should help them do this couple of steps and give them the filter data. Now, if this data is on a monthly basis, you could do that once in a month, maybe. And if this is, let's talk about a week, right? Maybe you can do it on a weekly basis. Now, if this particular data is on a daily basis, because you're running about 4 to 5 banks, you are a business analyst for 4 to 5 banks. 4 to 5 banks might have joint venture to hire you to get them the data on a daily basis. Would you end up doing this mundane task for multiple times? That could be a lot of time consuming task, right? So what you might do or what you might prefer to do is try to automate it. So this is where you take help of Power Query. Now let's close this data set and let's create a new sheet and run some steps using Power Query. Register those steps, and next time you just add new data to that particular folder or that particular file and run some steps, and you get the new data, updated data. Now let's continue. Now we are on a new sheet. So what you do is go to the data pad or data ribbon here, and here you have the option of dragging and dropping data from various set of resources. It can be from a file, it can be from a database or cloud, it can be from a Power Platform or any other resources, can be a PDF, web, right? there are multiple options you can go with. Power Query is ready to extract data from anything and everything which is considered as data, as long as it has tabular elements, rows and columns, right? For now, our data is in a file. So we would be going with this particular folder option. Why folder option again? Because the new data files will be added to this particular folder. So I'll go with folder. My folder resides in downloads, and in downloads I have named my folder as bank data AI generated, and inside this we have some data. Just open, it is getting connected, and now you get a preview. Now if you are happy with your data, you can just proceed with the load, but I want to do some transformations. So I'll go with the transformation option, which enables you to the Power Query window, and here just click on this expand button and you can find the preview of the data you're looking at. Select the sheet. This is your preview. Select OK. There you go. You have your data preview. And this is where the applied steps get registered. Now you can see a preview of your data set. Here you have the source name, and after that you have the column names, customer name, customer ID, and everything else, just like a bank data that looks alike. Now I don't want this particular A column and just delete it. What you can do is just simply remove, and there is a new step got registered, and followed by that check for a couple of more details. Here you have income, credit score, bank name, loan principal amount, loan amount, and everything else. Now let's go back to our initial stage. Let's say you are working with a couple of banks, and those couple of banks, or let's say are selected in or located in the region East, West, and Central. Now you want to filter out those. Filter out East, Central, and West regions alone. Press OK. And the filtered step is also present there. And loan status. Loan status should not be null or approved. It should be only pending and rejected ones. Press OK for that. And after that, you want to check if the candidate has any bankruptcies or not. So select only the ones with no bankruptcy history so that you are secure on that particular front. And again, here you don't want null options here, because you might be wondering, you might just end up wondering if he has multiple other credits or not. So for safer side, we don't want null elements, and we don't want more than 2 other loans. So if the candidate is having 1 or 2 loans, he might have a feasible commitment to close his loan in the earliest way possible with no risks. That's my next filter. And interest rates. So let's say your bank people told you that we cannot take any more risks. I don't want to give up any unsecured loans. So I just want secured loans. If he or she is ready to provide some security deposit to get that loan, then it's well enough. So fine. So far so good. Your data is done. And again, in this particular segment, you don't want missing emails or missing numbers, right? You do end up missing a good chance to contact them, right? Even in phone numbers, just check if there are any nulls. So far so good. And your data is almost filtered, and you have all the states in the region of West, East, and Central. And let's say this is good enough. And again, if you want to eliminate any risk possible for this particular loan approval task that all the banks have given you, then you can proceed with a simple calculation called as LTI. So this stands for loan to income ratio, right? So what's the amount of income that a person is getting, and what's the amount of loan that he's looking for? So there is a particular number, a whole number. So if the ratio is anything equal to or below than 4.5 or 5, banks consider it to be a very good score. And if it is beyond the 5, they might think it might be a little risky, and they might think of negotiating, or they might think of talking through the customer and understanding what are his income basis and what are his plans to repay, right? So you might want to give them a purely filtered list. So let's give them that. So for that, you just select the last column or any column that you go with. So I want to go with the last column, and I want to add a conditional column. And this conditional column, okay, before considering to proceed with a conditional column, let's add a normal column, a mathematical calculation column, a custom column. Here you can write the formula as LTI, which would be equal to which would be equal to, open a bracket, loan amount, income. You will go with income divided by loan amount. So select this particular column, add okay, it's not supposed to be here. LTI would be the name, and here you'll be writing down the formula, divided by income per annum divided by loan's principal amount. What is the amount of loan he is focusing on getting, star or into 100. So this is the formula. Now just insert this column and you'll be getting some ratios. Or I think they might be a little, okay, it already took the percentage number because we multiplied into 100. So if there is a risk of 45% or below that, then the banks will directly approve it. Now you can give it a data type, change the data type, data type to maybe, okay, so far so good. We can keep it as a number. Got it. Eliminate this step. Change type to maybe, let's keep it as a decimal number itself. If we kind of transform it into a percentage, so here you can see 27.28, right? It will be turned into 2728.28. So we don't want such a huge number. Let's keep it as a decimal number for now. Now let's add the conditional column that we were initially talking about. So we will now here approval, rename it as maybe risk assessment, and here we will be selecting the column, and the column we will be selecting is, let's go to a little top so that we can see the column, LTI equals or less than or equal to 45% or 45, then safe. If not, negotiable or risky. And it's now the bank's call if they can feel like going ahead and negotiate the terms with the candidate or deem it risky and leave it, right? You've done your job with perfection. So here you got all the numbers, so you can just go with safer candidates so that it's already a well-filtered option for the banks. And now you get all the required details. You can just export it and save it. So for that, go to Home, Close and Load. So there you go. Now you got a filtered data, right? So you might be still having a question. This has been done for the current part. What if I want, okay, there is another thing. Yeah. What if the another part is, what if I wanted to go with the candidates which are fresh applicants? So this was the old data, right? Now let's go back to the query once. I think we missed something important. We missed the credit score, right? So let's also add a credit score. We will filter out. We will have another column, which will be a conditional column again. And now this conditional column will be named as check credit score. And now we will give the credit score numbers. Here we'll select the credit score column. Yeah, here's the credit score. And ideally, if the credit score is above 739, it's something around that number. If it is equal to or greater than 730 or 739, then it's a very good call. Give it as 739. Proceed. Else thinkable. There you go, you've done it. So here again you can proceed with a filter which says you only the option about how to proceed or just proceed with the numbers, right? So here you have a completely filtered list. Now just save and close and load. Now you have a filtered list of data. Just refresh it. Okay, that could be some error with null values, but not a problem. Go back to the query once so that you have a better idea what exactly went wrong. Check the null values that we filtered out. It can be a database error due to data type. Yeah, I guess we did with email, right? So this is the problem. Okay, not a problem here. List may be incomplete. Not a problem. Maybe this is the reason why it came up. So far so good. You can just just refresh the preview and it's done. And now just close and load. Now we would have a filtered data. Now you might be wondering if this can be replicated if I have a new kind of new data set. maybe this is an old data set, and if I load the new data set from the current year, just the previous year, can I do this correctly? Yes, you can. You just have to go to home and firstly we'll save it, and then okay, let's save it as filtered data, Excel workbook. Fine. And what you can do is you can just make some changes to your source data. Here on the same downloads window, we have a new data here, which is new data. You just have to drag and drop it to the section where we have bankdata.ai and go to the Excel sheet that we had made. And all you need to do is just go to the data and refresh. Ignore the null values. Now the new data has been added to this particular data set, and new generated list is also ready for you to proceed with the calls and get the loans approved. And that brings us to the end of the session on automation using Power Query.
We will be discussing about Tableau. Tableau is a very powerful and fastest growing data visualization tool used in the business intelligence industry. It helps in simplifying raw data into a very easily understandable format. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. So today we will learn Tableau through the following agenda. First, we will understand what exactly is business intelligence and what is the importance of business intelligence in real-time business. Followed by that, we will have a brief introduction of Tableau, and we will also learn how Tableau really helps in business. Next, I will guide you through the installation procedure, where I will help you to install Tableau into your local system. Once the Tableau is installed into your local system, we will have a brief tour about Tableau, the kind of worksheets you can work with, the kind of data it can import, the options provided in the Tableau, the kind of charts, everything. So once we have a better understanding of Tableau and the options provided in it, we will directly move into the worksheets, where we will work on the Excel data and try to create some worksheets. Once we are good with the worksheets, we will enter into the next segment, where we will understand how to create a real-time dashboard. I hope I made myself clear with the agenda. Now let's begin with our first topic, that is the business intelligence. So what exactly the business intelligence term mean? So to understand business intelligence in a much better way, let us imagine that you have started a business. So a business of online marketing, where you sell some phones, some products, and some other items which are necessary for your customers. So what would you do to best reach your customers? First, you will understand their needs and requirements. You will either try to mail your customer or try to contact your customer through a phone call, and you will understand what exactly he needs and what type of requirement he has. Just imagine that your customer needs a phone. You will understand his need and then try to call him and understand his requirements. For example, it may be an Android phone or it may be an Apple phone. So he will be having some requirements, certain size of RAM, certain size of ROM, and extended memory or operating system. So you will basically understand his needs and requirements and try to provide him with the best product. So in this situation, if you provide him with the right and best product, then you'll be having a good customer satisfaction and positive reviews. This customer satisfaction and reviews come under the sentimental analysis. These sentimental analysis and positive feedbacks and reviews from your customers will help you gain more customers, and in result you will have a good market profit. So this is what exactly business intelligence means. So to make things easier in business intelligence, we have certain softwares: Tableau, SAP, SAS, Oracle, MicroStrategy, Qlik. These softwares are the segment leaders in market research and business intelligence. So today we will be learning about Tableau. So why Tableau? You might have that question in your head, right? So the answer for that is, according to Gartner, there are multiple business intelligence softwares like MicroStrategy, BestLooker, Demo, IBM, Salesforce, Tableau, Microsoft, Qlik. But the best in the market leader in the ability to execute and completeness in the vision, Tableau is ranking in #1 position. Now we have understood what exactly business intelligence is and why Tableau is on the top. Now we will understand a brief introduction to Tableau.
So Tableau is a business and analytical software tool developed in America. Tableau helps people to understand, visualize and make data-driven decisions in real time with extreme agility and accuracy. To better understand what exactly Tableau does, let us imagine that you're given some data in the form of Excel sheet that has thousands or even lakhs of rows and some hundreds of columns or even thousands of columns, and you had to kind of filter or kind of apply some operations on that and get some insights of that particular data. So basically, if you do it in a brute force method, it could be really time consuming. But what if there is a software that can write all the SQL queries possible on your data, and all the data you wanted is readily available, or all the information you ever wanted on your data is readily available just by a single click? Yes, exactly. That's what exactly Tableau does. It automatically writes all your SQL queries in the background, and it can provide you the information in the form of a variety of charts like the bar charts, pie charts, and it can even give you some live data and also the advices based on which you can move ahead and improve your business. Now let's go through some sample data and understand how it exactly does it. So on my screen you can see some Excel data which is based on some store in America. So here you'll be having different regions of America, that is South, North, East and West, and the category of furnitures, subcategory bookcase, and etc., which kind of category is selling most in which kind of region, and what's the discount, what's the quantity, and what's the profit, etc., in this particular Excel data. So you'll be using this particular Excel data to get some insights of this sales happening in America. So this is how business intelligence works basically. So here we should use the Microsoft Excel to get the necessary insights of this particular data. Now just select all these cells of this particular Excel and select insert, and on the left corner you can see pivot table. Select that, and here if you had an existing worksheet you can select the existing worksheet, or if you don't have that you can select the new worksheet option and then just press OK. Now we have our pivot table over here, and we have our fields in the Excel data on the right side part. Now just select a region and push that into the columns, and now let's select sales and push that into the values. Now we have the sum of sales option, so we have the east zone, central zone, south zone, west zone, and the summation of sales happening in that particular section of America or region of America. Now we can also make some changes to the values, like we have summation, and we can select some value field settings, and inside that you can go through count, average, maximum, minimum, and select few more options based on which you have to calculate it. Now let's push the rows, or let's push the regions from columns to rows so that we can have some good data in a more understandable form of view. So there you go, you have the central region, east, south and west on the left side, and on the right side you have the summation of sales happening in that particular region and the grand total of the sales. Now let's try to do this in the Tableau. So there you go, your Tableau just got started. So on the left side you have got the connect option and the various types of files it supports, that is the Microsoft Excel, text file, JSON file, Microsoft Access, and more on that in the next upcoming part where we'll have a tour on that. Now let's select Excel. So we have already an Excel file on the downloads part. Just select that one and just open it. And there you go, you can see all the rows and columns here. Now let's go to our sheet. So on the screen you can see that on the left part we have the data which is connected to the Tableau, that is sheet 1, the store data, and these are the dimensions and these are the measures. So basically Tableau divides the data into dimensions and measures automatically, and you can see some options provided on the top row, which is the file, data, worksheet, dashboard, story, analysis, map, format, window, help, etc. And here you can see some marks, which is the color. So here you can just imagine that you worked on some bar data or bar chart, so that you can use color options to provide different colors to your bars. And you can also select the size of your bars, add some text if you wanted to add in, and you can add some details if you wanted, and some tool tips, etc. And on the right side you can see show me option, and this particular tray helps you to get different types of charts you wanted to keep on your data. For example, you want to select pie chart, you can just select pie chart. If you wanted to go with bar chart, you can go with bar, and some area charts, and you can see maps, etc. And the best part is when you hover over this particular chart or any kind of selection you wanted to make, then Tableau automatically helps you for having the dimensions and measures for that particular chart. You can see in the bottom part where it is highlighted for pie charts, try one or more dimensions and one or two measures. So if you hover over the bar chart, you can see that Tableau tells you for side-by-side bar charts, try one or more dimensions and one or more measures. So basically it is telling you to have one or more dimensions or one or more measures in order to use the side-by-side bar charts. Now let's do the same thing what we did in Excel. So here we'll just select the region and pull that over the columns, and now we shall select the sales and push that over the rows, and there you go. You can see the bar chart over here, and it's automatically telling you the kind of sales happening in that particular region. Now you can even select the region part and drag that over to color so that it gives you different colors. Now if you see on the right side show me tab, you can see different types of charts available for your data. So you can have a pie chart, you can have the bar chart, you can have few more map charts, etc, etc. So that's how Tableau gives you automatically all the types of options that you can work on the data visualization by using different types of charts. So that's how Tableau basically works. Now we will go into the next step where I'll help you to install Tableau into your local system. Once the installation is done, we will get back to Tableau again, and we will understand each and every part of Tableau in much more detail, and we'll also work on each and every type of chart present over here, and we'll work on multiple sheets, and finally we'll enter into the dashboard. So far so good. I hope you have understood the basic introduction to Tableau and basics of the Tableau fundamentals, how to use rows and columns, what are dimensions, what are measures, and what is show me, and how do you change colors of your bar charts over here, and you can highlight this. So we'll work on everything after we finish the installation process and get back to worksheets. So before we go any further on Tableau installation, let us understand the Tableau products first. So there are multiple types of Tableau products. So here we will be having Tableau's desktop, Tableau public, Tableau server, Tableau online, and Tableau reader. So let us understand Tableau desktop first. Tableau desktop is a paid desktop application. It is also called as Tableau Desktop Professional Edition. This is where the developers create charts, formula, dashboards, actions, and everything. It has a 14-day trial too. The dashboards we create here can be published on any server listed above. The data can also be opened from Tableau Reader. Moving ahead, we shall understand the Tableau Desktop. So for beginners, let me tell you, Tableau Desktop is like open source data. Whatever the data or whatever the sheets, whatever the dashboards you work on using Tableau Public will be available for public. So keep this as your reminder. And it is not preferable if you want to use Tableau for your company's confidential data, because it might go public and it might be risky. So Tableau Public Desktop is a free desktop application. It is the developer place for Tableau Public Server. It is free and has to come with some limitations like cloud save only, no live or database connection. They are widely used by learners, bloggers, and public information related institutes like media, etc. Now moving ahead, we have the Tableau Server. So Tableau Server is a free server in the internet. This is the YouTube or blog spot in Tableau data visualization world. It is free and people post their ideas and visualizations here. We call it the visual blog. It has no user management or folder management options. You can hide your work though. It cannot have live data source, but only extract. So many people publish their ideas and custom visualizations here. We can find the inspiration from here. Now next we have the Tableau Online. Tableau Online is a paid server application too, but it is already hosted by Tableau software, and so no need to install it on any Windows server. It is better you need the Tableau dashboards to be accessed from anywhere. It has almost all the features of Tableau server, but only on the internet, not on your local system. And finally, we have the Tableau Reader. So Tableau Reader is a free desktop application which can help us to view the Tableau dashboards created by Tableau Desktop. It supports only extract connection files. It can help new people to try Tableau by getting one license for Tableau Desktop and installing this free software on their end user's machine. It can open the dashboards, interact with them like filtering, tooltip, and parameters. We cannot edit the formula or charts here. Now I hope we have some good understanding of Tableau, its introduction, and the various products of Tableau available for users. Now let's begin with the installation. So the third segment, Tableau installation into your local system. Now here we'll be trying the Windows operating system. Now to install Tableau into your local system, all you have to do is open Google and type in download Tableau public. And you have the first option that reads download now Tableau public. I would recommend for beginners to select Tableau public because it is free. Now let's go back to Google once. Now on my screen we have opened Google. Just now type in download Tableau. So once you type in download Tableau, you can see various options. The first one though is Tableau Desktop, which is a paid version. As I said you have to select Tableau and it is free of cost, and you can try out your sample data over here for free. And once you select the Tableau public option, you have this particular web page open. And if you go back to the presentation, you can see that I have written something called abc@gmail.com. This is basically your email address for getting registered and downloading the application. So you can write in your email over here, which can be anything like I have written abc@gmail.com. Just make sure that the mail ID you provide is an official one or it is an operational one, as you might have to confirm your download. Once you write in your mail ID, just select the download app option, and you can see on the bottom left corner, the application will be getting downloaded. Now I have already downloaded the Tableau public desktop exe file into my local system, so I'll just cancel it for now. Now we are back on the presentation mode, and we were in this particular stage where the Tableau public desktop.exe was getting downloaded. Once the file is downloaded, just run the file from your downloads part and you can see this particular screen on your Windows, which will greet you, welcome to Tableau. And here you might have to select I have read and accept all the terms of the license and just install. And there you go, the Tableau public 2020.4 is installing into your local system, and that's how you install Tableau into your local system. Now we have entered into our next segment where we will be having the Tableau tour. So once you open your Tableau, your screen will be looking something like this. So this is the Tableau in my local system, and you'll be having the screen which is similar to the presentation one. And here you have various options to connect to your data file, which might be an Excel, text file, JSON file, Microsoft Access, PDF file, spatial file, statistical file, or if you had to download some data directly from the server, you can even do that. So now we'll be working with the local data or the local Excel file in your local system. Just select that Excel file and open it. And there you go, you're on your first worksheet. Just select the Go to Worksheet option and you'll be having your screen redirected directly into the worksheet. and you have the dimensions and measures on your left corner, and you have the show me tab on your right corner, and some marks in here, and filters, pages, and various options on your toolbar. Now we have finished the introductory tour to our Tableau, and we'll understand more about all the options provided in this particular Tableau screen through our worksheets as we start with our first worksheet. So far we have understood what is business intelligence and the Tableau's role in improving your business. Followed by that, we have understood what exactly Tableau is. Then we have understood how to install Tableau into your local system, and we had a brief introduction or brief tour on Tableau. Now we will move ahead and continue with making our own worksheets and the dashboards based on the worksheets we have worked with. So advancing into the fifth part, we will be working with the Tableau worksheets, and followed by the worksheets, we will be working on the sixth part, which is the dashboards. Now without further ado, let's get back to Tableau. So we have successfully booted up our Tableau, and we are on the home screen of the Tableau. And on the left bar, you can see that we have various connect options to the Microsoft Excel, text file, JSON file, Microsoft Access, PDF file, spatial file, statistical file, etc. And if you had to connect to a server, this particular option is not provided in the public Tableau. It might be available in the server Tableau, and you can see that if you had to connect to the server just in case, then you're provided with various options here. Like you can connect with Google Sheets, OData, Web Data Connector, etc. etc. So today we'll be working with local data that is present in my local system. That happens to be an Excel file. So you can see that in my downloads we have a set of Excel files. So we'll be selecting car sales updated data file. Now you can see that the data has been connected to the Tableau, and the rows and columns have been presented on the screen. So before getting started with Tableau, let's have a quick update on the data. So many times it happens that you download a data from Google, and sometimes one or the other rows or columns might have some incomplete data. As you can see, there is an incomplete cell over here, which is the curve weight of a particular vehicle that happens to be Cadillac Chevrolet. You can either try to remove this row, or you can add some value over here. Like I'm going to add some value. I'm just going to drag this one because they both look a little bit similar. They have a same wheelbase and a kind of same width, so might be the curve weight might match. So we'll just drag it over here, or we'll just write it. Okay, I forgot to enable editing. Fine. So I'll just drag it here, and I will have some values. Let's change it a little bit. Okay, so you can see that we have filled up the cell over here. Let's just check if anything else is incomplete. Yeah, there is another one incomplete over here. Let us just add some random values because this is just for practice. Yep, everything else seemed to be fine. So the important point or the update I wanted to give you guys is that when you save this, so when you get into a file and save as sales updated, so when you save it, make sure that you select the Excel workbook. If you don't select the Excel workbook, you might face some troubles while connecting the data to your Tableau. That was the important update I wanted to give you guys. So just select OK, and your data has been saved now. And let's get back to Tableau. Now let's connect to the data again. By selecting the connect data option, you can see the dialog box come up on my screen. So you can just select Microsoft Excel and car sales updated. Open, and you can see the data got connected just now again, and you can see the rows and columns over here. So everything looks fine, and now let's get back to our sheet. So this is the sheet we'll be working on. We'll be creating multiple sheets. So we are creating multiple sheets because we have some options over here. You can see that, right? So this is the sheet, and this is the new sheet option, and this is the new dashboard option, and this is a storyteller option. So basically we'll be working on multiple sheets, and then we'll start a new dashboard, and we will drag all the sheets that we have worked on onto the dashboard so that we can have a view on all the sheets in one single screen. So basically that's what dashboard is. There are multiple operations on dashboard, like connecting to multiple dashboards together and applying some operations like filter, etc. on the dashboards. We will learn more advanced topics on dashboards in the advanced part, which is the next part 2 of the Tableau tutorial. So we'll have a basic understanding of Tableau functions in this particular part 1 right now. No worries on that. So you can see that we have options or the row names written in 2 different colors. You can see that the manufacturer, model, vehicle type, etc. are written in blue, and we can see that there is some sort of ABC text represented on the left side. And similarly on the other half, you can see the curve weight, engine size, fuel capacity, fuel efficiency, horsepower, length, price, etc. And you can see that there is an asterisk written just besides them. So why is this difference? Because Tableau automatically categorizes your data. So it will categorize the data into 2 forms, that is the dimensions and measures. So the dimensions happen to be the unique values of the data, and the values are the numerical values used in your data. So basically the curve weight is a numerical value, engine size is a numerical value, the price, resale values, width, wheelbase, car sales, etc. are the numerical values. And in the dimensions you have manufacturer, model, vehicle type. This happens to be the non-numerical values. So the manufacturer might be Audi, BMW, etc., etc. And the model would be some 320i from BMW, S-Class from Mercedes, etc., etc. And vehicle type might be some just a car or off-roading vehicle, something like that. So these are the non-numerical values. So these are categorized into dimensions. So sometimes there is a chance that you will also find the numerical values in measures. Like just imagine that you are in a college, and the name, address, and your percentage, etc., etc. are your values, and the percentage will be categorized into the numbers, which is the measures. And if you have a student ID which happens to be a number, that will not be in the measures, that will be in the dimensions. But why? Roll number happens to be a numerical value, because the student ID will be considered as a unique value, and Tableau automatically considers it as a dimension. If you want that to be in the measures, no problem in that. You can just drag it down into the measures and it will lie in the measures from dimensions. So that's about the left tabular column, where you can see the dimensions and the measures used in your data. And these are the filter options, these are the page options. This is a mark sheet where you can make some modifications onto your chart by making different colors, sizes of the charts, adding text to your results, and adding some details, adding some tooltip. Tooltip is basically something which explains you about the data which you're working with. We'll work on that. We'll see everything in detail, no worries on that. And now coming on to the right side, you can see the Show Me tab, which will help you with the various kinds of charts available that you can work with. So you have text tables, you have heat maps, you can have pie charts, you can have symbol maps, and just maps, pie chart, and side-by-side bar chart, stacked bar chart, horizontal bars, line graph, etc., etc. You can have scatter plots, you can have histogram, you can have box and whisker plots, and many more. Don't worry, we'll be working with various types of charts over here,
And the best part of Tableau is that if you wanted to use a specific chart, then it will automatically help you with the kind of data you need for that. For example, if you wanted to go with text tables, you can see that it is providing you the prescriptions over here. So it needs one or more dimensions or one or more measures together on the rows and columns in order to use this kind of text table kind of chart to represent your data with. And if you wanted to go with a pie chart, it says you need to have one or more dimensions and one or two measures. That is a must. If you have these kind of data on your rows and columns, only then you can use a pie chart. So this actually helps you out in real time. And now let's get started with our data. Now let's try to identify which is the manufacturer with the highest pricing. Now when you double click on the sheet, you can actually edit it, or you can actually right click on that and just select the rename option, and you can rename it. Now let's select or just write in the highest pricing. Yeah, there you go. Highest pricing is the name of our sheet right now. And now let's grab the manufacturer and drop it down onto the columns. And now let's select the price from the measures and drop it down onto the rows. Yeah, there you go. You can see that we have the data output on our screen. So this particular bar chart helps us identify that Mercedes-Benz has the highest pricing amongst the other manufacturers. Now you can actually make some modifications onto this chart, like you can increase the size of the bars. It is automatically selected over here. You can just scroll it to the right and left by manually, and you can make some changes to the bars. And apart from that, you can even choose an option here which says the sort ascending by sum of price with manufacturer. Basically it sorts it out. So if you select this particular option, you can sort it from the least value to the highest value in the ascending order. And if you choose this one, it will be arranged in the descending order, and you'll get to see the highest one on the left and the lowest one on the right. So this is how it works. And you can see that the first highest pricing manufacturer is the Mercedes-Benz, and the least manufacturing pricing is the Infiniti. And you can see the Beamer over here, the BMW. Personally, I'm a fan of BMW. Okay, now it's just looking, kind of plain without some any additional colors or without a vibrant way of representing your data. I think you know what I mean. So for that, you can just drag the manufacturer onto the color option, and voila, you can see different colors for different manufacturers. And this one basically tells you the highest manufacturer, or this color basically tells you the highest pricing manufacturer, that is the Mercedes-Benz. And yeah. And another option is the chart type. So basically when you chose the manufacturer and the sum of price, the Tableau automatically chose the bar chart. But you can change that. You can just select a line over here, and you can see the complete data has been represented in the form of a line, and you can even select density, and you can select area. So this is how you can change the way you can represent your data. So automatic was the best one over here. So basically the Tableau automatically chose the best way to represent your data, which happened to be the bar chart. You can even select the shape though, and you can make some changes to the shapes. So that's how it is. Now let's get back to automatic again, and it's got the bar chart again. Now let's try to create a new sheet, and this time we'll be working on the horsepower. So which manufacturer offers the highest horsepower? Yeah, so we are on the sheet 2 now. You can see that we have named it to highest horsepower. And yeah, when you come back to this one, you can see the name over here. You can even edit your table by just double clicking on the name, and you can reset some things over here. And that's how it is. And now when we come back to the horsepower, which is the second sheet, I think you remember, right? We are making multiple sheets just so that we can work on our dashboard. So now on the second sheet, we'll be taking up the model name. We are going to identify the car which is having the highest horsepower. Okay, those are a lot of cars. Now just select the sort option, and there you go. We have the Dodge Viper. Yeah, Dodge Viper happens to be a muscle car, and yeah, it should be having the highest horsepower in the manufacturing model, or what do you say it, the basic model without any modifications to it, extra modifications. So the production model of the Viper will be having a 450 brake horsepower. That's really huge. Now we can actually make some modifications. Since we have different manufacturers like Bema, Merck, and any other manufacturers, you can actually categorize the models over here. You just need to drag the manufacturer over here, and you can bring the manufacturer to the first position, and then the model. Okay, another trick I would like to tell you guys is, if you wanted to switch the manufacturer with the model, then all you have to do is just drag the model and place it on the manufacturer. This will automatically switch them. Okay, I didn't place it correctly, I hope. So when you do it, it will actually switch it. Yeah, that's how it's done. So we're going to categorize this models based on the manufacturer now. Let's bring back our manufacturer. Now let's drag it to the second place. And now we have the manufacturer first. So you can see that the data got automatically categorized based on the manufacturer. You can see we have Acura, which happens to be the American version of Honda. So we have Integra, RL, TL, what happens to be the car or model names. So these are the cars offered from Acura with the horsepower 255, or no, it's 225, and 210 and 140. So this is actually the tooltip which is giving you the data according to that bar chart. And now we have the Dodge Viper here with the highest horsepower in the production model. You know, the Dodge and the Ford are known for their muscle cars with highest horsepower.